Hi everyone and welcome to Code Quality Conference 2024. We are back after an year. I'm so excited that we are doing this third edition of Code Quality Conference. Uh, at C Sharp TV, we have been doing a lot of events, right? We do a lot of conferences and live shows throughout the year. But it is these virtual conferences where it's an opportunity to meet all the industry leaders on one particular niche. And I'm really excited to welcome you all for the 2024 edition. If you're someone who is joining us for the very first time in these conferences, this is organized by CSharpCorner, which is actually the world's one of the largest developers community. I'm your host Simon. As always, I don't change in last 3 4 years, and I'm really excited to have you all. Quick few things before we get started. I'm going to share my screen and take you to the conference website and show you what we have got for you today. So, of course, you can also go ahead and register for Code Quality Conference now. Now, what does that mean? Is if you register, we'll send you all the recording and stats and also keep you posted with all the upcoming events. So if you can still go ahead to the Code Quality Conference, you can find the link here in the screen. It's codequalityconf.com and register yourself over there, and I will keep you posted with upcoming updates. I already see some of these people joining in. Drop us in the comment section where you all are joining us from, and we'll be happy to see for all the audience that we're getting. We have speakers from great companies. All the sessions are going to be somewhere between 40 to 45 minutes, and we're very open to go ahead and ask your questions to the speaker in the comment section. And if the speaker may take your session questions during the session, or they may take towards the end, no problem at all. We are taking all your questions. No question is wrong. And yeah, so we have a list of speakers. We have Mahesh, Paco, Wahid, Matt, and the very first speaker joining us today is Sagar. He'll be here in just about a minute. One thing to note that we often miss is to follow the code of conduct, right? This is a virtual conference, and I want you all to be very kind to each other in the comments, respect each other, and make sure that you are welcoming to every single person. We have the playlist. I said this is the third edition, only to realize that this is the fourth edition. We have been doing it from last 3 years now. You can find all the playlists 2021, 2022, 2023 on the website. You'll also find all the recordings of this conference here on this website too. And here's the schedule. The first one to joining us today is Sagar. He's going to talk about ensuring code quality in DevOps culture. I think this is the best session you can start with. DevOps is so important. And on top of that, he's going to talk about quality. It couldn't get any better. After that, we're going to have a session by Rijwan and Sarin Satyakarki. They both are Microsoft MVPs. Last time I checked, they were in Philippines. I think they're back in Nepal. A very good friend to us, and also CSharpCorner MVP. Then the session will be followed by Abhishek. Will fly back once again to India. He's joining us from, I think, Mumbai or Pune. And then we have session by Wahid. We'll travel to Israel. He's also a good friend to us, speaks in many events. And then we move to Europe. There's a lot of things coming up. So without any further ado, I think I should actually go ahead and invite the very first speaker of our conference. He is Sagar. Sagar is a Red Hat. He's a software quality engineer, and he works at Red Hat. How interesting! I'm hosting Sagar for the very first time. So everyone, let's welcome Sagar to the Code Quality Conference. Hi, Sagar, and welcome to the Code Quality Conference.
Hey, hi Simon.
Thanks, Sagar,
Thanks
to
for
begin with. Thanks for accepting the invitation. I am really happy to host you today. Where are you joining us today from, by the way?
yeah, I'm joining from home only.
Okay, so are you based out of India?
Yeah,
Okay,
yeah,
I didn't
based on
see that in the
Pune,
video.
India.
Pune, that's great. That's great. So, are you working from home, or because it's 4 p.m. here in India, right? Ideally, one should be at the office.
Yeah, yeah. So currently we are working as a flex module in Red Hat. So for this
Wow.
conference, and I took work from home.
Wow, thanks, Sagar, for doing this for us. I can't wait for you to get started. I'm going to add your s- slides to the stream. Everybody else can see it. And next 40-45 minutes is all your Sagar.
Yeah, sure, Simons. So, Simon, just one question.
Hmm.
So you don't want me to share the screen, right?
Yeah. I've added your slides to the stream. Everybody can see it. And then you can
Mhm.
use your arrow keys to go back and forth, or maybe
I will just
mouse.
check. Mm,
If you hold, yeah, I can see your slides going, but it won't have the animation because you've uploaded it.
okay.
You good to go?
Yeah, sure. You. So, hey, hi everyone. My name is Sagar Mahendrakar and I am from India. I hold a bachelor's degree and currently working with Red Hat. I have almost 5 years of experience in a quality engineer role. Mostly, I am responsible for BU tasks of project involvement in sprint planning, sprint releases, automating test cases, integration it with CI/CD pipelines, and to make sure that our product is bug free. So today I will share one of my experience. When I was working with a previous organization, we used to follow a waterfall methodology, and because of this, our development cycle was too long. We face some challenges like difficulty in accommodating change request because customer requirement keeps on changing with time. It was difficult to accommodate any change request after a requirement specification phase was completed. Also, in the waterfall model, testing is typically done towards the end of the development process. That means this means that defects may not be discovered until the late in the development process, which can be expensive and time consuming to fix. But when I joined Red Hat, where agile methodology is used, I got to know why agile is important for development and testing purposes, and what makes it successful is DevOps. So let's start with the today's topic, ensuring quality in DevOps culture. Moving to next slide. Yeah, just yeah, yeah. So let's walk through from the agenda for the today's session. Uh, we will start with the introduction for DevOps and their importance. Then we will learn the relationship between DevOps and the quality engineering. Moving further, we will discuss the role of QE in DevOps and their responsibilities in brief. Then we can discuss more about challenges that make QE face while working with DevOps. We will have some deep knowledge about tool chain integration and their importance. At last, we will discuss more about skills required for QE to work with the DevOps. And then we can have a conclusion in the QA section. So moving to the first slide. Yeah. So, what is DevOps? DevOps combines development and operation to increase the efficiency, speed, and the security of software development and delivery compared to traditional processes. It also allows organization to serve their customers better and compete more strongly in the market. In simple words, DevOps can be defined as a alignment of development and IT operation with a better communication and collaboration. There are few reasons that why DevOps is necessary for modern businesses. I have listed a few of them here. Like first one is short development cycles, early error detection, reduces operational cost, improves customer satisfaction. So starting with short development cycles, DevOps allows developers to release their product much quicker because they no longer have to wait for approval from other teams before releasing a new software versions. Instead, they can release new version as soon as they are ready for testing, which means that bugs can be caught much earlier in the process and fixed before they become significant issues. Second one, early error detection. When teams work together on project, there is more opportunity for errors than a team works separately from another on the same project. In a DevOps environment, when one team makes an error in coding or testing, The another team can detect it immediately and fix it before it causes any damage introduction. It leads to higher quality products and fewer problem down the road. Third one is reduces operational cost. It's hard for business to keep up with the pace of technology use. If you are not keeping up, you might as well close up your shop because your competitors will leave you in the dust. One of the biggest reason why DevOps is so important, DevOps is so important because it helps companies lower operational cost by increasing efficiency, which means they can spend less on support staff, servers, employers, and other resources while maintaining their competitive edge. Fourth one is improves customer satisfaction. One of the most important aspect of any business is keeping your customer happy. There is no better way to do this than by providing excellent customer service, which can be difficult for some companies. DevOps can help make this easier for us and our team. Integrating our development team with our operation team can create a seamless experience for both customers and internal employees. It will also increase customer satisfaction because they don't have to wait long for their request to be answered. It will also keep things running smoothly within our organization because everyone's know what they need to do next. Hope we got some basics and importance of the DevOps. Now moving to next slide. Yeah. So now we will discuss a relationship between QE and where exactly QE fits. So DevOps becomes so popular with the implementation of Agile, but where does QA fit in the world of continuous integration dominated by DevOps? Well, pretty much almost in every release, a quality analyst is required to assure the robustness of the product, especially in the world of DevOps where updates take place in an application almost on weekly basis. With so many frequent changes taking place, outages look to be very common, and outages are supposed to break the life of the developer and the manager. Everyone needs a quick hot fix when a service of a product goes south, affecting more than a single customer. But an immediate fix needs to be thoroughly tested before it gets migrated in production. Developers and product manager would want the job to be done in a way. This is where QA needs to step up and take the responsibility of evaluating whether the immediate fix for an outage does not end up affecting any other functionality, or it shouldn't be breaking the existing functionality. So just as much as developer is needed to get rid of an outage by a quick fix, quality analyst is needed to prevent future outages to many extent as possible. Yeah. So this was the relationship between the QE and the DevOps. Moving to next slide. Yeah. Challenges faced by QE teams in DevOps. So there are several challenges may arise due to the fundamental changes in workflow, collaboration, and technology use that such as integration entails. Quality engineering in a DevOps environment, it is not just about ensuring the quality of the software, but also about enhancing the processes that led to the development of high quality software products. So here I will discuss some of the main challenges quality engineer might face. I have listed few of them like shift left, speed versus quality trade-off, automate testing expertise, keeping up the changes. So starting with the shift left and continuous testing, DevOps emphasize shifting left, which means testing early and often in the development cycle. This requires the QA team to integrate testing seamlessly into the daily workflows of development, which can be a significant change from traditional models where testing was a distinct phase. And also, QA teams must adapt by developing automated test case that can run effectively at every stage of a CI/CD pipeline. Second one is a speed versus trade-off. speed versus quality trade-off. DevOps prioritize speed and efficiency in delivering updates and new feature. QE team are challenged to maintain the high standard of quality without slowing down. This can sometimes create a tension as the drive for rapid releases may compromise the thoroughness of testing. Third one is automated testing expertise. With the emphasis on automation in DevOps, QV team must possess strong skills in automation testing. This includes the ability to write, maintain, and understand the automate testing scripts and framework. Developing this expertise required time and training, which can be a challenging, especially in the fast-paced environment. Keeping up the changes. In a DevOps culture, changes occur rapidly and frequently. QA teams must keep up with these changes in both the software being developed and the technology used to develop and test it. This continuous learning and adoption can be demanding. Yeah, so these were the challenges faced by the QA. Moving to next slide. Yeah. So roles and responsibilities of QA in DevOps. So yeah, the quality engineer role is more demanding than a QA was, as it is more fundamentally focused on quality. The QA role demands that you have expertise in all aspect of DevOps, which can directly or indirectly related to product quality, including software testing, automation testing, agile processes, CI/CD, and etc. Apart from this, quality engineering personnel should also have a good knowledge of design techniques, the technology stack, delivery processes, etc. Let's take an example. Let's understand the role of a tester in DevOps through an example. Suppose a software company is working on a mobile application software. The development teams adds new feature constantly and frequently and meets the user demand. Testers are essential in a DevOps section, like participating in project planning and collaborating closely with the product owners and the developers. By this, they understand the mobile application functionality and user needs. Next, the tester develops automated scripts using testing tools, further integrating it with CI/CD pipelines. Also, tester runs different test cases of various mobile conditions to judge the performance of the application on various machines and various environments. Testers even conduct security tests to identify whether there is a data leakage risk or not. So there are some common roles and responsibility that QA should perform in DevOps. Like QA should aim to detect a bug at the earliest point in the cycle and also prevent potential bugs from reappearing in the production environment. QA should not limit their role to only finding and preventing defects, but should also highlight problems in the processes and recommended changes wherever necessary. This practice is only possible if QA takes ownership of the improvement process in DevOps. QA should make sure all environment required for testing should be standardized and deployment should be automated. There is no room for manual testing. Collaborates with developers throughout development phase, contributing ideas and understanding future needs. It helps us to get fast and immediate feedback. This fast feedback loop is essential for determining and resolving issues early in the development phase. So these were some of the roles and responsibilities of QA in DevOps. Now moving to next slide. Yeah, toolchain integration. So, what is toolchain? A toolchain is the collection of tools and technologies that enable development and operation teams to collaborate throughout the entire software phase. DevOps fundamental such as continuous integration, continuous delivery, continuous deployment, automation, and collaboration. Toolchain integration in DevOps and QE is crucial for achieving the seamless automation and collaboration required to support rapid, reliable software releases. A well-integrated toolchain allows for a continuous deployment, development, testings which are the cornerstones of the DevOps philosophy. Here is a detailed look at the importance of toolchain integration. Let's get brief in the importance of toolchain integration. So I have listed some of them: streamlined workflow automation, enhanced collaboration, consistency and standardization, real-time feedback, and the metrics. So starting with the streamlined workflow automation, integration of tools in a DevOps environment helps in creating a seamless workflow for developer, operation teams, and a quality engineer. Each stage of the software development life cycle, from planning and coding to testing, deployments and monitor, can be automated. This automation reduces the manual hands-off between teams, minimizes error, and speed up the process of the software delivery. Enhance collaboration. Toolchain integration facilitate better communication and collaboration among cross-functional teams. Tools such as chatbot integration with a issue tracking system can automate status updates and alerts. This keeps everyone in the loop and make it easier for the team members to react quickly to development or operational issues, ensuring that everyone from the unified platform with access to the real-time data. Consistency and standardization. Integrated tools help standardize processes across the development, testing, and the deployment phases. This standardization is crucial for maintaining consistency in how software is developed, tested, and released, which in turn helps in managing complex systems and reducing the unexpected behavior of discrepancy in a production environment. Real-time feedback. Integrated tools provide continuous feedback and detailed metrics about every aspect of the development lifecycle. For instance, dashboard tools that integrate with CI server, testing frameworks, and deployment tools can provide real-time insight to the into the code quality, test coverage, build history, and deployment frequency. This data is vital for making informed decision about the product and process improvement. For quality engineering, integration of tools like source control, build servers, deployment mechanism, and testing frameworks means they can ensure comprehensive quality checks are performed automatically. This integrated approach helps QV teams to implement advanced testing strategies such as shift left testing, performance testing, and security testing as a part of development pipeline rather than as a afterthoughts rather than as an afterthought. Moving to the next slide. Yeah, the skill required for the testers in DevOps. I know there might be more skills required, but as I know, I listed few of them, like knowledge of software testing, knowledge of DevOps technology, collaboration abilities, understanding of automation testing, and the frameworks. So understanding software testing will enable you to spot and resolve software program problems quickly. Knowledge of DevOps technologies will enable us to organize and automate the software development and the testing processes. One should have collaboration abilities with developers, product owners, or any team members. Understanding how to automate testing and deploy code updates regularly is important. He should know what is CI/CD pipelines and continuous deployment and continuous development phases. It would be a better as a tester to have some knowledge in DevOps. So this was the skills required for the testers. Moving to last slide. Yeah. So basically, this is a conclusion slide and the evolution of the QA. The impact of DevOps on quality assurance testing strategies is transformative. By embracing a culture of collaboration, automation, and continuous testing, organization can achieve the delicate balance between speed and quality in software development. QA teams play a pivotal role in the shift, contributing to the creation of a resilient, reliable, and high quality software is a dynamic DevOps environment. As organization continue to evolve the integration of DevOps principle into QA testing, strategies will be more fundamental to staying competitive in a ever changing landscape of technology. Yeah, so I think this session will be a productive one for as a tester and for a DevOps team as well. And this a tester should try to implement this process in the team also for ensuring the quality of their product. So that's it from my side. So if you have any question, you can come up with me, or you can reach to my you can reach on to me on LinkedIn, so I can connect with you and we can discuss more about that. Yep.
Right, Sagar. That was quick. That was quick, and that's actually great. I really liked on how you covered the entire ecosystem of QA and then also the DevOps. I think it was pretty nicely done. I'm gonna
Yeah.
sit back means so there's a couple of questions coming up, and we still have about what 30 minutes before the next session start. So I think we have
Yeah.
enough time. So there's Deepak. He's been asking, and we have been getting a lot of questions in the our MVP groups too. So I'll pull those questions. So Deepak Devate is asking, what skills or certification should QA professionals have?
Yeah, thanks Deepak for asking this. So there are not any specific certification that a QA should have, but he should have some knowledge how he can find bugs in an application, and
Mhm.
how that application works in the production environment. There we should, as a tester, there shouldn't be any bug missed while testing that. And skills like you should know some automation tools like Selenium, Cypress. You should have some knowledge of basic JavaScript or the Java. You should have some knowledge about testing strategies. What are the testing types, difference between the regression testing and the retesting. So one should have. And if you want to do any certification kind of thing, you can go ahead with ISTQB fundamental levels. That would be easy for understanding the basic of the testing and the testing strategies. So
Mm.
I hope you get your answer. If not, you can reach out to me anytime.
Yeah,
Thanks,
that's a
Deepak.
very well answered. That's very well answered. I think you know everything in and out. So that's very nicely answered, Sagar. So there's another question coming from Akanksha, and I relate to this so much that you're building a project. It's not even into the production, but there are changes in every single sprint, right? Every Monday call, there's so many changes. So Akanksha is asking, how do you
Right.
handle frequent code updates? And then on top of that, you need to test it, right?
Yeah. Thanks, Akasha, for coming up with this. So after each update, we focus on regression testing to check that new code changes have not caused any harm to the existing functionality. For that, we run some automation script that we have configured in the Cypress, and it will be take care that running the regression suite, and it will be finding it. It will be finding any bugs that caused due to a recent fix. And we track all the changes and logs and communicate closely with the development team. We have scrum call if we got any changes or issues. We communicate that to the development team in a scrum, and to understand the implication of each update is followed.
That's interesting, Sagar. I really like all the answers that you're giving in. And since you said you've been working on this for like 5 years, Sagar, so I'm really curious. We'll come to the other question that are coming, right, Sagar? Sagar, I want to know, how did you get into Red Hat? How did you get into testing this QA and DevOps? I want to know a little background about it.
Yeah, sure. So Simon, I will be starting with first. You will be getting shocked as I have done Bachelor of Engineering from mechanical branch.
Wow.
Yeah, so I have worked in a mechanical company for almost 6 months. Then one day my me and my friend were traveling somewhere, and we had some thought in mind, like let's do a computer course. Let's do any course of computer, and we can try our luck in IT industry. So I did some courses. I did some Java course, and I gave interview to the startup companies, but I got rejected from many companies, like 5 6 companies, because in interview the first question was like, you are from a mechanical branch, how would you survive in the IT industry?
Mm-hmm.
So there was one company which called Neutrino Tech System. They gave me chance, and I started working over there. They trained me. I gone through the YouTube courses very well. Did some certification for my understanding, and I almost worked there for 2.5 years. Then I for a better career opportunities and growth, I switched into the Red Hat. And Red Hat is a company which give us freedom to do whatever, like whatever, as in you can learn anything and you can try to implement in your day-to-day task. So the basic of the automation things I learned from the previous company, but I got a chance to implement that in a Red Hat. So they give us a responsibility, like you have to initiate the task, you have to do that, and there is a freedom. So due to that, I grasp new technologies, new strategies. I learned very well, and from the, Red Hat, and our seniors and all the managers are supportive, and they give us very well chance to grasp any new tools and technologies.
This is amazing, Saga. This is a great story. You starting from a mechanical engineer, right, and getting working in mechanical field for like 6 months, then taking a computer course, getting into tech, and now you work at Red Hat. I'm sure it wasn't easy to get into companies like Red Hat. I host many speakers from Red Hat, right?
Yes.
They are one of the best engineers that we have, and you have moved into that. So congratulations, Sagar. You have really worked hard. I can say that. So happy that I could host you. And we have Deepak in the comments. He says, same. I also studied mechanical engineering, and I. So what's up with these mechanical engineering guys? You guys are coming into IT and taking our jobs.
Yeah,
Okay, that's
Deepak.
great. Yeah, that's good. That's really nice. So let's take another question that's coming from the MVPs from CSharpCorner MVPs group, right? So that, you know what, I'm gonna actually copy this and paste it here so that you can also read it. Um, okay, perfect. So the question is, Sagar, how do you see the role of QA evolving in the next 5 to 10 years within the context of DevOps? And Sagar, since you're really good at it, I also want you to share how AI is affecting the world of QA, because AI is literally everywhere.
Yeah, so answering to that question, Simon. So AI and machine learning technologies are increasingly being integrated into testing tools and frameworks to automate test case generation, optimize test coverage, and identify in test data for a more efficient defect detection and resolution. So
Hmm.
there are some AI tools that by using that we can generate test cases. We can get more functionality depth by using that AI tools.
Hmm.
So that will the AI will be not taking our job, but it will making us our job easy. Like for let's say you're testing one functionality and you are covering like 10 to 20 test cases for that. But if you go on AI tool, and AI tool will help us to get more another 5 to 6 test cases that may be edge cases, and that may be cause breakage of the application. So
Hmm.
that is what AI helping with us currently. And answering to this question, like QA, evolving in next 5 to 10 years, I think that it not be necessary, like it will be come up. So testing will be shifting to a left, like testing will be starting from the development phase by using continuous integration deployment processes. And from 5 to 10 years, I think AI will be integrating with the testing tools also, with some project also, that I think.
Yeah, how often do you use ChatGPT in AI in this testing? Writing, do you use it to to make scripts or something? I use ChatGPT to create JSON file a lot in the development when I need to test something, right? I ask ChatGPT, hey, you know what, create me a JSON file to create the sample data. How often do you also use ChatGPT a
Yes, yes,
lot?
yes. So Simon, there is one functionality, like
Hmm.
we are working on the one of the application where we need to test different types of phone numbers from the different countries. So as you know, we have a lot of countries and their country codes, and the depending upon their phone numbers, and even the length is different for each and every countries, as I know.
That's right.
So I have to generate a test data, like for each country I have to generate a phone number. So we can't go on a Google and give us a country code, or give us a phone number which having a 10 length or a 8 digit phone numbers. Though I just go to a chat GPT and I will give a command like let's give me some valid phone numbers of US or any country, and they will be providing me a country phone numbers. So I
Yeah,
can
that's
use that test data while testing to
yeah.
cover the edge case scenarios.
Yeah, that's very smart. I'm gonna do that. I think that's very
Sure,
smart,
sure,
right?
fine.
Right?
Yeah,
Those get those country codes right and sample contact numbers. I think that is very important. Yeah, that's very good. So there's another question coming in, and that is, how can we effectively measure the impact of strong QA practices on overall software delivery and business outcomes? I mean, in fact, I think this question is, how do you actually evaluate, uh, right, the QA?
yeah. So I think the basic user needs should be covered in the application, and the happy path should work, and there should not be after releasing the product or the after releasing the code into the production environment. There
Hmm.
shouldn't be any high severity or high priority bugs should be missed, and we should have a like we can track the we can track we can measure the QA efforts by using a like a code coverage analysis. We can measure the test coverage. By that we can measure how strong QA practices on a business and delivery outcome.
Yeah. So Sagar, how often? First thing first. I mean, you did say moments back that you get on a call with the developers, right? How
Mhm.
often do you think it is good for a QA team to interact with the developer? Should it be once in a week? Should it be Monday calls, or should be it like a daily sprint calls? How often should developer and QA team should connect? Because I know developers sometimes don't really like QA team.
Yeah. So in Red Hat we don't have like this like we have a sprint calls daily, scrum calls on a daily basis. It is just for 15 minutes where each and every one gives an updates, and if we have any issue or we have any doubt, we can reach to the developers and we can discuss that in a scrum. So I think currently we have a 4 day week 4 day call in a week, and we
Hmm.
communicate with the developers. And I think this is the best thing to connect with team every day.
Yeah.
We can share if we got any doubt or blocker. We don't have to ping them on regular basis. Hi XYZ, I have this problem, please connect, we will solve. Instead we
Mm.
have in a team call where every team gets to know what is happening in our team, and which QA or which developer, which functionality is blocker for them as well.
Yeah, I think you covered this. You answered this very nice, and because I'm with you when you say you don't have to get up n number of calls. Because usually what happens is like you face a problem, then you drop a message that in the Slack
Yeah,
or in
yeah.
Teams that, hey, can we get on a quick call? And that quick call is never a quick call. That is a
Right, right,
very
right.
long call. So and there's a lot of back and forth there. So I think that is pretty
Yeah.
nice. So what kind of tool do you use? I mean, I am more familiar with Azure DevOps when it comes. I know some people use Jenkins and all. So which tool do you all use?
Yeah. So currently we are using a GitLab pipeline only for
Okay, GitLab.
and yeah, where we run our sanity or smoke builds on a daily basis. So we have integrated that with a Cypress tool as well. So we write
Hmm.
and run our regression code by using a Cypress tool, and we
Oh,
have integrated that code into the GitLab where we run our pipelines. And we have also a regression test suite where if
mhm.
we got any Jira, if we got any ticket or any new feature, and to make sure that a feature does not break existing functionality, we run that regression code as well, and we run that regression suite before releasing any code into the production as well.
Wow, you guys are working really nicely. Well,
Thanks.
client company, client facing companies are a little different. I mean, consultants are a little different, and product based companies are kind of different. I can definitely see it. Okay, there's another question from Akanksha. She's asking, mobile apps face strict rules from App Store. which is
Yep.
right. How do you adapt your mobile QA and DevOps process to meet these challenges?
Yep. So, let's say application stores has different guidelines based on the operating systems. General process is dev uploads a file on the store. Then there is a automated scans to check malware and functionality issues. Then there is a manual scan to check the usability issues. And after the developers get the status like app is accepted or rejected and the feedback. To avoid challenges in the app store, we should follow application guidelines from scratch of the development product development. Regularly test builds by CI/CD pipelines to address any issues. Implement beta testing to get feedback from the group of the users. Ensure that our application follows the best practices for security, including data encryption, secure authentication mechanism, and protection against common vulnerabilities such as SQL injection and the cross-site scripting. Utilize We can also utilize platform testing frameworks like Apinium, Espresso, which allows us to
Yeah.
run our scripts on multiple operating system. We can also conduct manual testing on real devices to test the functionality and the usability of application using simulators and emulators. So we
Wow,
can
that was a lot
Yep.
of points. You covered a lot of points in just one answer.
Yeah.
That was pretty good. I really liked on how you said in the beginning is follow the requirements from the very beginning. Right, you need to look at what are the requirements and do's and don'ts from the very beginning. We sometimes miss it. We just go ahead
Yes.
and start building it. And what I also really liked, Sagar, is when you said do the beta testing. I don't know
Correct.
how much people do beta testing. Very less. They just build it, they'll get it some testing and all, they do it on their system, and just put it in the production. No one does beta testing with a small group of people, right? So I think that is very well said, and everyone watching, we should take this away that beta testing is something we don't do, but I think it is something we should practice.
Yes,
Okay.
Simon.
Okay, let's say a couple of questions, then I'll let you go. I think we already have we have about what 7 minutes for the next session. And okay, now this is a very interesting question that is coming in. That what are the most common cultural barriers you have encountered when integrating QA into DevOps environment, and how have you overcome them? This is very obvious, right? You have QA in the DevOps. Some guys will not like it, right? They don't have the habit of having QA in the DevOps. So have you faced any kind of problem like this? Guys saying no, this is a good feature, we don't mind, or this okay, this can still go in the production. Any have you faced any kind of problems like that?
Integrated into how you can. So basically, there are some problems like I don't want to say it is a problem, but it should be a challenging one. So
Hmm.
because the DevOps in DevOps we get a frequently changes, and
Hmm.
that changes comes from the user, and we should satisfy the user requirement. And sometimes as a QA we don't take that changes as much. Like let's say we get a different requirement, different changes on the alternate days. So it's a like a burden on a QA as well. But by this we can start by for this we can use a shift left testing. So what happens in left testing? So when developers develop some kind of a code or some kind of feature, we should start testing from development phase only. We don't have to wait that development will be complete that feature totally, and they will be sending the QA. We should start from there only by running our pipelines in the CI/CD. So for that, and how we can overcome that, we should have some automate testing expertise as well. We should have some knowledge about writing, maintaining, and understanding scripts and automation testing as well. So by this we can run our scripts on a daily basis on a CI/CD pipeline, and we can I don't think we can completely overcome from these challenges,
Yeah.
but we can make our product good, and we can satisfy we can get a user satisfaction.
Yeah. That's nice. That's nice, very well answered, Sagar. So I want to know, how big is the team? How many members do you have in your team?
So yeah, so Simon, we have five developers and two QA, and
Hmm.
I'm a software quality engineer, and one is their QE lead. So we were both handle the project on the QE level.
So you're now only on one project. You're not on multiple projects. So your focus is only one project, right?
Yes, 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 yes.
That's good. That's pretty good. Usually I think you they're doing this project first 2 days, then they move into the other one.
No, no, Simon. So this is the best thing about Red Hat. So we get
Yeah.
a chance to focus on one project only, and if we get a chance to work on one thing, we can 100% focus on that thing, and we can work on them.
Yeah, so it's great, Sagar. I know. I think it was really lovely hosting you. One final question I'm going to ask to all the speakers at this conference, and I'm also going to ask you is apart from all this technical stuff, right? What do you do in your free time? What are some of your hobbies? Do you play guitar? Do you dance? Or what do you do?
No, Simon. The both things I don't do. Like I really like to play a guitar, but it didn't happen anyway. So I like to trek mountains, and I
Okay.
like to spend time with my friends and family, just sitting at home and watching any a movie or any series on the Netflix. And
Okay.
I am a big foodie person. Like if I saw anything on Instagram or any reels, like I want to eat that. So I will be schedule any time or take my wife or my friend, and we will be going to eat that.
That's lovely. I mean, yeah, trying new food is also a hobby, not bad at all, especially when you have a wife, right? You can take her out and try a new something every time. Sagar, is there anything else you want to add before we just wrap up your session?
No, Simon, but just want to thank to Code Quality Conference and you for being in touch from the day one when I submitted the talk and my talk that selected. And thanks Code Quality Conference for giving me an opportunity to speak in this and to share some of my knowledge. And I guess and I hope that will be helpful for our audience, and they can reach me anytime, anywhere. I have given my personal email, and my LinkedIn profile also. They can reach anytime.
That's great, Sag. We do a lot of events across the year at CSharpCorner, and we have many of our MEPs from Pune, Mumbai, Nagpur region,
Mhm.
right? We do a lot of conferences. We're going to do one in October. We would love to host you there too. If you have time, I know you're very busy. So,
No,
Sagar,
no.
once so thank you so much, Sagar, once again. It's almost like 5 p.m. at your place. It's time to go out and get a cup of tea, right?
Yeah,
We
sure.
also have India versus England match today in the evening, right
Yeah,
at
yeah.
8 p.m. Right. I'll let you live with that. Thank you so much, Sabar, once again, and I'll see you soon. Bye bye. Take care.
Thanks, Simon. Bye bye.
All right, everyone. That was an absolutely great session by Sagar, and a mechanical engineer getting into QA and now working as an engineer at Red Hat. It couldn't get any better for this code quality conference to start with. As Sagar is an absolutely amazing speaker. I saw it, and there's so much to take away just from this one particular session. Coming up on Code Quality Conference 2024, we have Satya Karki and Rijwan. They both are C Sharp Corner MEPs and Microsoft MEPs too. Um, they are from Nepal, but have lived in Philippines. They were also in Bangladesh. I don't know where they are now. But before we have them on the stage, I'll take a minute break and see you back uh, in a minute because it is a minute break. Alright, everyone, welcome back. That was a minute and 30 seconds break. We still have about 5 minutes to get to the next session, but everyone who is watching in, welcome back to Code Quality Conference 2024. This is the fourth edition, and we have done the first session. The first session was by Sagar. He talked about code quality and in the DevOps, which is really nice. And we've now moved to our next session. And I just wonder, is there any conference, is there any event in the world that does not talk about Copilot? It is so interesting. We have about like 4 minutes to get started. So our next speakers are Satya Karki and Rijon Ansari, and they're going to talk about improve your code quality and performance using AI and GitHub Copilot. It's a very interesting topic. So without any further ado, let's bring them in and let's do some chit chat. Oh my goodness, that was an very different video. I didn't expect those videos to come up. Hi, Rijon, how are you doing
Yeah,
today?
thank you. Actually, I must say thank you for sharing that video. Actually, it recalls lots of memories that we have spent.
Oh, I looked so bad in that picture. I'm gonna hit Rohit. We all, we also have Satya, but she doesn't have her camera switched on. That is why we cannot see what I'm gonna do. I'm gonna add at least an avatar that we can see. Yeah, there you go. So first, tell us, hi Satya, welcome to the Code Quality Conference.
Hi Simon. Hi everyone. Hi Richuan.
All right,
I,
you don't have to say you don't have to say hi to Rijwan, right?
Yeah.
All right, so first tell us where are you all in which part of the world you both are now?
now we both are in Kathmandu.
Oh, that's good. That's good. That's finally you're back, right?
Yeah.
What are your next travel plans?
The next few months we are still here.
Yeah.
Then we will think about it.
I won't be surprised if you both move to Seattle or somewhere. Okay, all right, Rijan and Satya. So today you're going to talk about GitHub Copilot and AI, and you're going to on how you can use that to improve your code quality. Right? Really excited, right? I know there's everyone talks about Copilot, and it's very much needed because there's so much to be learned about this Copilot and the ecosystem. There's still not a lot of content out there, so I really want to thank you and Satya for doing this for us. I'm going to add your screen to the stream now. Everybody else can see it, and next 45 minutes is all yours.
Thank you, Simon, and thank you, CSharpCorner, for giving us this opportunity to share our thought and also share our knowledge on this improving code quality using AI and GitHub Copilot. So, good evening, good afternoon, good morning, wherever you are now. So, welcome to our session on improving your code quality and performance using AI and GitHub Copilot. My name is Rizwan Ansari. I'm currently working as an application development manager at Tech One Global, where I'm deeply involved in software development, leading software development and delivery quality. So we are in the era where it is dominated by AI, and we have been hearing lots of buzzword. I mean, the word has become very common for us, especially like ChatGPT, OpenAI, Copilots. So we find its presence almost every facet of our life, from our daily systems to the tools we use. Irrespective of any domain, like we have the tool available in medical domain, medical services, construction business, marketing, sales, educations, everywhere. So we can sense AI in its sector, and AI has become a silent force and taking all over the manual and repetitive activities. AI has built this algorithm which can learn on the data and do the activities for us. So it's seamlessly integrated with our daily routines, recommending our product services and so on. So breadth of AI applications has expanded and touched virtually every product and service. And we will see in the coming days, or now even we are seeing almost every product is coming with AI features or AI services. Now if you say tech companies are relentless journey, they are exploring the vast potential and incorporating the capabilities of AI into solutions to scale up the user experience. This brings us to the particular exciting prospect, and we'll see the immense impact of AI, especially in software development. No, we might have known like AI has mostly affected or health, we can say. It has significant impact on IT business mostly. No, in fact, AI can become our co-pilot in every phases of development, starting from building, testing, deployment, managing, updating, and we have a GitHub Copilot, which we will see more about it. Now, at the same time, maintaining code quality has become another very important concern in the world of Gen AI, especially in the software development where the AI has impact hugely. At the same time, it is very important for us to maintain the code quality, to maintain the performance, and we will see now in next 30 to 40 minutes. We'll take a closer look on each of these tools and understand their features, explore some of the real use cases. I'll guide you how, even we will guide you how to get started, and whether you are a seasoned developer or just a fresher or a student, we have something for you in this session. We'll deep dive into the use of AI and GitHub Copilot, especially for code quality and performance improvement. So here is the agenda. Today we are going to explore how AI, particularly GitHub Copilot, can be a game changer in the software development process. This session is designed to give you the practical insight, not only the theoretical, and we'll leverage how AI can write a better code, identify the bugs, enhance the software performance, uh, improve the code quality. We'll also dive into the AI-driven code assistant, exploring the capabilities, how GitHub Copilot, and we'll also demonstrate how it can streamline our coding practices. So I'll not take much time. We'll just these are the agenda. Like we will be talking about the impact of AI on software development. Then we will talk about GitHub Copilot and capabilities. We'll do how to get started. We'll do some practical demos. We'll do some hands-on improving the code quality and performance with some real-world examples. So I'm excited to share this journey with you, and I encourage you to think about it, how these tools and techniques can be applied in your daily works. Now, AI and software development. AI has augmented the software development. Throughout my career, I have got privilege to work on the various projects, and I know the importance and criticality of code quality, performance, how it impact the user experience, and how it impact the software business. So I'm really passionate on this field, and this is which I try to explore AI and how we can use it on the improving AI, especially the code quality and performance. Now, AI will impact every phases, as I said earlier, starting from analysis. Like if we have a requirement, we can use AI algorithm, AI tool to analyze the requirement, convert that requirement into the software design. When we can use the AI automations in analyzing code generation, system design, error detection, bug fixing, documentation, testing, deployment, and all these activities are related with the code quality, with the quality and performance. It also helps us to scan the security threat, vulnerabilities, and not only that, we have seen like most of the software which were developed are developed still on the old versions of the code, or even we are many developers which are, when they are writing the code, they will go and search something from the internet which are still on the older version. Now AI can help them to convert those into the latest versions, even different languages. So importance of code quality. Let's talk about why code quality is so crucial in the software development. When we speak about the code quality, we do actually mean essentially the code quality refers to the characteristic that make your code easy, more efficient, and ready to adapt for the future changes. High quality code is typically defined by several key factors. Among them, I can say like readability, maintainability, scalability, testable, efficient. So readability is all about how or even you, after coming several years, how you can understand your code, or how your colleagues or someone else can understand your code. The way you write, the function name, the naming convention, the pattern. Now, when we talk about maintainability, it's say about uh, how easy is to modify those functions or extend without breaking the part of the system. Scalability involves when we are writing the code uh, over the year, or even after the launch, the number of hit can grow, or it can increase the loads. So the software should be ready or should be able to cope with those demand when the application hit goes. And efficiency is all about writing the code that performs your task easily, uh, utilize the resources wisely. And we have known consequences of poor code quality. We have seen a lot of examples, sometime even in the news, like because of some poor code quality, a company has to go through a massive loss in when they launch their software. User experience goes bad, it affect their brand values. And we have known we have enough information how it impact the software, or even if the user who are using it. So such incidents highlights the importance of writing high quality code. It's not just about the making the easier life easier for developers. It's also about the trustworthy about end users. Now these are some factors and attribute. Actually, if we say there is no any special factors or measures for the code quality, but some of the things that attribute we can think about it is clarity and readability. Meaning when we are writing any functions or class or methods, we should make sure that we are following proper naming convention, we are giving the proper name, we are following the proper formatting, we are documenting it well. Maintainability is all about easy to bring the modification changes. It's also talk about the modular design, loosely coupled, uh, easy to extend, reusability. And efficiency and performance is optimize algorithm, data structures, avoid unnecessary loop, um, how we can make the execution faster, also how we can manage the memory. Security is all about validating the input, validating from attacks, securing from attack. Also, when we are giving the information into internet, we should make sure that we are giving proper informations. Confidential informations are secured, or access management is there. Like the information which is required for particular users, they can only view their information, not for other users. And last one, I can say testability. We should write code in such a way that we can easily do the unit test. We should avoid writing complex logic or a big function within one method. It's better to break into a small functions so that we can isolate the testing. Now, understanding the performance. So let's shift our focus another crucial aspect of software development: performance. Performance is not only the technical metrics. It's a key factor that directly impact the user experience and resource efficiency. When we talk about the performance, we refer how quickly or efficiently software respond to the user actions. Also, how fast it performs its tasks. So high performing software ensures that the user can complete their task swiftly without frustrations, which greatly enhance the user experience. We have many of us we sometime uninstall some application from mobile because of only the user experience, poor performance. Even sometime when we are visiting any services or product or even e-commerce site, if the UI response is not effective or fast, we have that bad experience, and we know we will not go back to that website. So this is how it affect the company. Some common pitfall like inefficient algorithm, data structure, poor memory management. uh, when we say poor memory management means memory leak or excess memory allocations, overuse of bandwidth, which means like when we are passing large amount of data over the internet, it is insecure as well as it will give bad experience in terms of performance. Lack of optimization and scalability. So if the user hit goes up, or let's say if the user grows or the demand of the software grows, software should be capable of coping those demand as well. I'd like to give some example like a Night Capital Group incident happened in 2012. It is a trading, they have a trading website, and they lost 440 million just in 45 seconds. All of the sudden the user hit goes up, and their trading algorithm could not execute enormous trade, and within that 45 minute the user could not get proper response, and they make a loss of 440 million just in 45 minutes. Similarly, we have heard about Twitter fail whales. Like a long time, for a long time, Twitter users frequently encountering fail whale. This is due to insufficient server capabilities, and I can also say there may be software design, so which could not handle the user search. So when there was a hike or surge in the user activities, there used to be a downtime. So these are some of the things that impact the brand value as well. So next slide, I like to share about GitHub Copilot. Definitely, almost most of the developers they might have heard about it. Is to start with the conversation about your code base, whether you are hunting down a bug, designing a new feature, you are stuck. GitHub Copilot is there to help you. It's not only about that, it has also improved the productivity of software development, and you can do faster 55% as per the data. And we will see how it will improve the code quality and performance. Now I would like to hand over Satya Kaki. She will be giving insight, and she will be sharing about the GitHub Copilot. Over to you, Satya.
Thank you, Rizwan. Hello, everyone. This is Satya Karki. I'm senior software engineer. With that, I'm Microsoft MVP and CSharpCorner MVP. I have nearly 12 years of professional experience in software development and data. Now let's start what is GitHub Copilot. GitHub Copilot is a tool that uses artificial intelligence to assist developers in suggesting and writing code based on the context in a real time. It was first announced by GitHub on 29th June 2021, and it is powered by OpenAI Codex. GitHub Copilot uses OpenAI's Codex language model, which has been trained on a massive dataset of the public code repositories. It is trained on all languages that appears in a public repositories. For each language, the quality of the suggestions you receive may depend on the volume and diversity of the training data for that language. For example, JavaScript is well represented in public repositories and is one of the GitHub Copilot best supported languages. Languages with a less representation in public repositories may produce fewer or the less robust suggestions, or sometimes it may not be the correct. We have to check ourselves manually. The accuracy of the code suggestions can vary based on the language popularity and the diversity of the examples available during the Copilot's training. For languages with a fewer public available repositories and the usage, Copilot may not provide a precise or the reliable suggestions compared to the more mainstream languages. You can get the Copilot extensions for Visual Studio Code, uh, Vim, NeoVim, and the JetBrains suites for IDEs and Azure Data Studios. It is the world's most widely adopted AI developer tool. Furthermore, GitHub Copilot Chat is a part of the GitHub Copilot, using which we can chat and get a prompt response for our query. GitHub Copilot Voice is another part of the GitHub Copilot, which is very useful for those who have difficulty to type and get the suggestions from the Copilot for their program. So they can just ask the questions and get the response quickly for their program. What GitHub Copilots can do. GitHub Copilot suggests the code completions as a developer's type and turns the natural language prompt into the coding suggestions based on the projects and the context and the style of the conventions they are using. Whatever the type of the languages you are using and the pattern you are following, whatever the style you are using in your program and the context, based on the context of your program, it gives the suggestions for your code, and you can you implement that the suggestions and you can improve, and also you can do the coding fast. It optimizes the code performance, so that it identifies the bug and provides the fixes. If there is any bug in your program, you can ask for a GitHub Copilot for a fixing, so that it will suggest and you can implement that fixing into your program, and you can improve your the coding quality, and also the coding time you can save by save using this AI tool. It can generate the code documentations also. For your the code, we can generate the code documentation using it. It suggests the code, functions, classes, or the entire program. So we can utilize for that purpose. When we ask ask the questions, when we are stuck with the bug or designing the some new features, then it will suggest, and that suggestions we can implement and do our coding fast. Beside this, GitHub Copilot generate the unit test. We can optimize. We can use it to optimize the SQL queries. We can optimize our methods, functions, and the whole program and the whole projects. It explains the code and the program also. If the older developer has done some program and you are new to that project, then you can ask and the GitHub Copilot to explain what does this functions or the method do. Then the GitHub Copilot will answer and explain you. So based on that explanation, you can understand that program if you are new to that project. Many big software firm, enterprise company has their own coding standard, pattern, platform, libraries, templates, and the designs. They have their own guide and the documents. They follow their own coding pattern and standard for their product and application development. So for that purpose, GitHub Copilot Enterprise is there. This is for the enterprise contracts. GitHub Copilot Enterprise is train the model based on your private repositories. So we can personalize the answers that are grounded in your organization's documentations with the inline citations. We can keep the track of work suggestions, descriptions, and the helps reviewers reasons about your changes using the GitHub Copilot Enterprise for the enterprise business and the enterprise companies. Beside this, we can use this for the pull request summaries and so on. This is for enterprise and the big, large organizations to use it for their private repositories and the private software systems. GitHub Copilot Chat is another part of the GitHub Copilot. We can chat, GitHub Copilot Chat is a chat interface that lets you interact with the GitHub Copilot, and we can ask and receive an answer to the coding related questions within the github.com and the supported IDEs. The answers are based on your code context, based on your code and the real time you can get the answers. It's a combination of the natural language processing and the machine learning to understand your questions and provide you with the answers. You can ask the wide range of the questions related with the syntax, programming concept, describe the code, fixing, debugging, test case, unit test, refactor, optimization of the code, validations, and many more other purposes. Meaning we don't need to navigate to the internet for the solutions or the samples for our problem in coding, and the documentations and the code repositories and the other online forum also. We don't need to go and search there. We can directly ask the GitHub Copilot chat inside our favorite IDE or the code editors. It comes with the GitHub Copilot. It's a part of the GitHub Copilot. GitHub Copilot provides the intelligent code completions and suggestions. These are the features and the capabilities of the GitHub Copilot. It has the capabilities of the contextual understanding. It supports the various languages. Extensions for the most popular IDEs and the editors are available. We can generate the unit test cases using it. It explains the code and the suggestions for the improvements also. It provides so that we can improve our code quality using it. If we are following the traditional style of the coding, and if we ask how we can improve or optimize it using the cutting edge of the style and the latest trend and the technologies, then the GitHub Copilot will suggest and provide the code sample. It proposes the code fixes if you need any kind of the fixing for your code. We can use it in answering the coding questions. Additionally, we can use the GitHub Copilot for the code documentations, and it's especially the chat based, so it supports the natural language and it's easy to chat and get the coding related answers within our IDEs. It is accessible for developers of the all levels, so anyone can use it and get the benefit of it and do the coding fast and improve the code quality within their favorite IDEs and the code editors. It can be used in customizations with the own documentations, processes, and the code repositories. So now let's go how we can get started with the GitHub Copilot. We can integrate the GitHub Copilot with our favorite IDEs. As I already mentioned, we can use GitHub Copilot in Visual Studio Code, Neo Vim, JetBrains IDEs, and the Visual Studio. For Visual Studio Code, we have to install the GitHub Copilot extensions to get started it. Once the extension is installed, then we can use it, and we can use it to improve the code, and we can do the coding faster. For Visual Studio, GitHub Copilot is a part of the Visual Studio now. Earlier, we need to install the extensions, but now we can install it as an individual component through the Visual Studio installer, as you can see in my screen. To get started with the GitHub Copilot, first thing is we need to sign into our GitHub account, and that GitHub account should have a Copilot subscription. Then we need to add the GitHub Copilot extensions, or in a Visual Studio we need to install it as an individual component, and then we can use it. So there are some tips to improve the Copilot chat results that helps to improve the code quality with AI assistant that we will demo in today's session later. To improve the chat results, we can use the / commands to quickly specify the command tags like the / explain to get the code explanation, scope the chat to specific files using the references, to review the source used by the Copilot to generate the answer, and we can use the different threads for each of your Copilot chats, so you can maintain the different context in each. So furthermore, so we can use some commands for the common tags such as a /doc for documentations. If we ask the questions to the GitHub Copilot and write the /doc, it gives the documentations for that selected code or the selected method. To get the explanation of the certain course, we have to just select that the certain code, and we need to write the /explain command, and then it will give the explanation of that code. To get the fixing of the code, we can use the /fix commands. To optimize the code, we can use the /optimize, and for a help, we can use /help. We can debug the app with a GitHub Copilot and get the error, exception, stacks, and any other information to correct and fix it as well. Additionally, Copilot provides the detailed information in the CPU usage. Auto Insight, it provides the detailed information and the insights for the specific methods and properties such as string.concat and the many more other methods. With Copilot, you can ask the questions about functions on the identified hot path in your code, which can help you produce the more efficient or the cost-effective code and helps to improve your code quality. Copilot has access to the exceptions, call stack, local variables, and the code. By asking good questions or the good prompt based on the relevant exceptions data that you have and the exception, Copilot chat can provide the useful insight and the fixes for the issue. Then you can accept that the proposing fixes of the code and you can implement into your program. Furthermore, Copilot understands the call stack, frames, variable names, and the values. As a result, you can pose the detailed questions to debug the debugger-aware Copilot. Now we will go for some examples and the demonstrations. So for that, I would like to hand over to the rich one. He will be demonstrating and giving some real-life examples. Thank
Thank you,
you. Over
Satya.
to
Thank you, Satya, for sharing a kind of detailed information about what is GitHub Copilot, its features, how it can help to improve the code, to generate the code. So all these factors, if we consider like it has a ability to write the code, which will help us to write the code faster. It has the capability to do validation, documentation, rectifications, fixing bugs, help us to write the unit test. If you see, these all factors will help us to improve our code quality and performance. How? Now, if we can generate the code faster, we will be able to save our time and we can utilize that time to improve those functions. Validation obviously related with the code quality, documentation, code quality, rectification, performance optimization, fixing bugs, code quality and performance both, unit test, both code quality and performance. So we will see how we can do those things. I'll open my Visual Studio. This is one sample project. You please ignore the folder structure and those things because it is just a sample. Also, how we can generate the code, how we can optimize it, how we can rectify, and how we can improve even the performance. Now, I'll just go here. There is an article model. This article model has already properties. So what I will do, just simply I'll remove it. It was generated just while ago. Now we can write simply a comment like this. Okay, create a class name called article with 10 properties. I'll just click enter. Now it suggested me article model class with 10 properties. Now if I want more property, I can add more, or I can write 10 properties including some necessary properties that I need. But for now, I'll just go with this default value. Now I can see there are some warning which might result into some kind of bugs. So we need to improve it and improve this code. Now what I can do simply, I'll just select it. If someone is having problem with this, I'll just zoom it a while so that we can see it clearly. Yeah. Now what I can do, I can simply select this function and I can ask Copilot. Okay, slash optimize. Please remove warning warnings. Now let's see how it work. Okay, I think it has already suggested something. Let me go. So the provided code is already optimized, doesn't need anything, doesn't contain any warning. Okay, let me go. All right. Sometime because of this Zoom, we might have some issues. So let me go here. Yeah. So it is saying it is already the code is concise, efficient. There is no warning, but still I can see there are some warnings. Even we can use this Github of Copilot chat also. I'll open this chat window. I'll just ask, okay, remove warnings, and I can tag uh, article, which means it will refer to my article. Let's see how this Copilot think about it. So it gave me a code that has no warning. So it is also giving some description. So let me go and let's preview it. So when we will preview, it has included this null factor if it is a code. So that's how we can even ask more question. Instead of null, we can ask Copilot, okay, can you assign a default values like string dot empty or something like that. So this way we can keep on improving our code. So we can ask another questions and we can ask this to improve. For now, I'll not do much thing here because we have another thing to show. So I'll again go back to my solution. Now I'll go into infra. I want to create a application context here, so I'll just write db context, um, and then let me check whether it is suggesting the things that I need. I might need to use it because of zooming. I always get confused. I'll try to make it 100 again. Yeah. So when I click, no, Control Z. So it required some kind of using. I think it's required. Using entity framework by default it should show. Somehow this is not suggesting here in Visual Studio. By default it's suggested when we are having this kind of error. I'll just go up here and I'll do it manually using entity framework core. Now let me check here. Now it is already suggesting what I need for here. Now it also understand I have the model called article. So that's how this works. It works based on the context. So here also article is here. So I should be using this as a using log entities. It's I think it should have only the model. Yeah, that should solve the problem. And generally it should suggest automatically. Somehow Visual Studio sometime it might respond slow. So it is here. Now, if I want to create my CRUD operations, I can simply write here. First, I'll ask my interface. So I have here interface. So I can simply write here. Sometime even we don't need to write it. It will just simply suggest it. So just here. Now, again, let me again try. Okay. Create interface for repo CRUD operation. So it has get all articles, article by ID, article create, then article update, delete article. If I keep on entering, it will suggest me somehow some kind of function. So here also we need reference. I'll add that reference. Generally, it suggests that reference automatically, but here I'm now using it. Model. So that's how I can do. Now let's say I want to implement this repository here. So I'll simply interface I repository. Now if I enter, it should suggest me the entire function. Yeah. So it understand my context. Based on that, it has suggest me all the functions I need for CRUD operations. So what I will do here again, I need to use using uh, a framework core. That's also I need, and another thing I need is using blog mode in this. Now I need also the common services because my interface is in common. So now my CRUD operations is done. Almost I did nothing much. I just my boilerplate code is almost ready. Now what I can do, I can write another. Okay, just for instance, I want to get all articles using edu.net um, with stored procedures. Let me check how it goes. Now it has suggested me the code where I can simply do my I can get the code using stored procedures. Uh, all the things are here. So likewise, we will be able to generate any kind of code, not only related with the entity framework. So I'll just remove this for now. Now I want to show something else. Now this is done. Now let's come to optimization and code improvement. So first thing is we know like code documentation is very most of the developers I have seen like they don't like to do, even I don't like to do it. So it's very easy here. What we can do simply we can select entire function and I can ask just I can right click and ask /doc. That's all I have to do. So it will do entire code documentation for me. I'll accept it. So my all the code documentation is done here. Now what I can do another thing. Mhm. So code documentation is another one factor. Now let's think about optimizing the code. Now this is one error log I have. Uh, I just created this function where I want to capture the log manually in a document text file. So this function contains the layer name, which will be the namespace, class name, method name, and message, and which I can reuse in all the methods. So this function simply what it will do, it will write the information into that file. Now I want to know whether how this code works. So I can simply I can ask it from here as well. Okay, this chat /explain, and also I can give the reference. Okay, I need the my class name is error message log. Yeah, so I can ask to explain it. Now GitHub Copilot will give me a very comprehensive explanation what it is doing, what it has class, and the method what it does. Method is what method is doing. It is creating, appending, and all the details. It will give step by step. It will explain our code. Error handling is there. Performance concern. So this is where I want to highlight more. Now, what it has done, it has not only explained me the code, but it has given me the issues and recommendation. So here is one performance concern. Reading and writing the entire file content is just appending new data is insufficient, especially for large log of file. So in this code, if you see every time what I am doing, if the file is already existing, I'm reading all the line and I'm adding the new line, which is very insufficient. If the file goes larger, performance issue will be there. Exception handling is not there, which is another code quality concern. Data formatting, code quality concern. Resource management, which is related with the uh, performance again. Now, what I can do, let's ask Copilot to optimize it. Okay, optimize, and I'll give the class name, my error log. Okay, and method name also I can give. Okay, let's give ask to optimize the entire class. Now it will optimize this entire file. Let's see how it is optimizing my code. It has used already try and catch, code quality concern. Let's see how it is doing. Now, so it has given me the improved code. That's great. Now it has even given the explanation, okay, what changes he has made and what advantage we are going to get from here. So since this code is already it has optimized, now what it has optimized, how it will impact the performance, and what are the things it has changed. So key optimization and change the data formatting, it has format the data. Path construction, it has optimized that. File writing, replace the manual checker, that's also another concern. Resource management, this is very important when it comes to performance, so it eliminates the need of manual managing the writer, that's another thing. It has also included the error handling, which will help us, code quality. Now this is another way I can simply do, like using chat. So it is a now I like to do in this way mostly. For me, I love just selecting and doing in this way, so I'll just click right, ask. So in that case, I don't need to give the reference because it knows I only want to optimize that particular block. So simply optimize and click here. So it has given me the optimized code. And if you see the optimized version, it has reduced the number of lines. At least 6 lines here it has reduced. Here it has reduced, and lots of reduced. Now my total line of code has reduced significantly, and it has optimized. Now lots of things has been optimized. What I can see, I don't need to rewrite. It has done several things in terms of optimization. Now another advantage of having this is now you can optimize multiple time, like in real world also. When we optimize the functions, we optimize one time. Now once we optimize after a few months, or like even same time, we find another way to optimize it. So again I can ask, okay, can you optimize it again? And for me to optimize it again, I don't need to do lots of research. I don't just need to write another command, okay, optimize it. So again it optimizes, and again it will give me the details of what it has optimized. Okay, instead of checking the directory exists, okay, here it has done, it has checked whether this directory exists or not. We don't need to do that because these functions already do that one. So it has used this. Instead of creating new stream writer, it has done this. So all the details is already here, what are the things it has optimized. And if I want, I can just simply preview it. Preview is another advantage, like okay, it has again reduced some line of code and optimize it. So preview can help us to compare what it has done, the changes. I can accept it. So done. Now it has optimized a lot. So where it was and now where it is, and also the code looks much cleaner, which we can now see code is clean. code is quality and performance is optimized. Now another one thing I can do, like to make it more, I can write doc. Okay, document it, because this will add additional layer on its optimization. I'll accept it. Now code documentation is also done. So this is how we can use it. Now I'll just save this all, and I have created some. There is a utility class. Okay, there are some methods I just randomly created from using ChatGPT, and I asked ChatGPT to create inefficient or like poor quality of method, and I'll check how I can optimize it. So let's go here. Now let's just start with this one. This is one method. What is max? So what it is done, when we will put the list of number, it will calculate the max number. Okay, so I'll just simply select this method. I'll ask it to optimize and refactor with domain. Let's see how it works. Yeah, so what it does, optimize and refactor with proper name, so it understand. Okay, now it has suggested find max. So the name of the method is what is max. It is suggesting better to use find max, which is a, you can say, user friendly and easy to understand. So because of which I can easily, it's readable for me, so I can preview it, and I can accept it. So it will just find max. The function has become much easier, and I can remove this one. Similarly, if I say this line, I'll create a intentionally a buggy solution. I have another function for this one. Okay, factorial. Okay, so what I can do here, I cannot see my mouse. Okay, so I have another method here called factorial. So I can ask it, okay, someone from the test team or user found, okay, it method has a problem. It is giving a wrong factorial. So I can ask it, okay, fix. I don't need to even explain it, or if you have a context, better if you can explain, okay, fix this method having this error. So it will give more accurate answer. So here I will just ask to fix. Let's see how it works. It identify there is a wrong. Factorial means n into n minus 1, and my method was having n into 1, so I was able to find the bug and fix it. It's very easy to fix the bug. Now let me see this method, process file. This is another method. I'm not sure what is the problem here, but what I will do, I'll simply select here, because I randomly select from the internet, find some inefficient functions. So I'll ask it, okay, optimize it. Okay, let's see how, what are the things it is saying. Okay, so it has optimized the method. Still it is writing, I think, some context. Okay, so what it has optimized, the best thing is it has given the explanation. Instead of using a stream reader, we can use this, and it allows the faster file processing, which is we are optimizing. We can directly iterate the overall lines array for loop instead of using read line. This is another way of improving. Instead of checking the length of each word, length of word, we can use this one. So these are the method, like it is suggesting, okay, this is how you will be able to improve. So this optimization will improve the performance of code, reducing unnecessary method calls and also using more efficient read line techniques. So this is how I can improve this method as well, optimize. So I can even improve my code quality. I can optimize it both. So I will accept it and my code is improved. Now another one method is here. Let me see how is this. Yeah, this is one method. It calculates the this one. Now I'm also not sure what was the inefficient of this function. Let me just check my previously generated code. Okay. So you can check like this is how you can select the functions. You can play over it. You can ask to optimize, fix it. Uh, you can generate the code. You can ask to document it. You can ask to explain it. So this is how you can do all these stops, and this will all will help you to improve overall the quality of the code. So that's how you will be able to make the things faster. Now we did this all, and I think I'm already running out of time, maybe. So I'll just quickly do some consideration that. So since this is a co-pilot and this is learning, we should provide a proper feedback and also proper uh, validations, those things, so that we can improve the inaccuracies and those things. Also there are some consideration which we can consider that as well, like it can have some potential risks as well, so do things you need to take up and do those things. So that's how I'd like to conclude my session. And if anybody has any question, I know I am already running out of time, because I when I was showing the demo I could not check my time. So let's see if there is any question. Simon, you can help me with questions.
All right, that was absolutely amazing, right? You are a, a rocket speed. Okay, so there are a few questions in the LinkedIn, right? As I see there are over 300 people watching in, but for some reason we're not able to get comments from LinkedIn inside the StreamYard.
Mm-hmm.
So so I've actually copied it and pasted it. And Pradeep Kumar from LinkedIn, he's a technical lead. He's asking, do we have any option to give some company-defined coding standard optimization? I found this a very cool question. There are many questions, but I found this
Yeah.
one of the best.
So, if you remember earlier, Satya presented like GitHub Copilot Enterprise. So, Enterprise is made for the enterprise organization which have their own standard, they have their own libraries, they have their own code based naming convention. So, what they can do, they can train that GitHub based on their own data, their own documentation, their own coding standard, and optimization as well. So, the copilot will learn from that and it will suggest based on your own standard. So for that you need GitHub Copilot Enterprise.
Okay, that's good. It means there is an option, right? You can do it. Okay,
Yeah.
perfect.
Another one question I can see is the Copilot free?
Oh,
So
yeah.
just a quick answer. None of the Copilot of Microsoft is free. Even this is not free. They are free when they are in
Mm.
preview. When they are in production or generally available, those are not free. You there is a charge and they have a different subscription model.
Perfect. Perfect. Let's take one final question. Deepak says, I really like it. Thanks, Rishwan. Deepak is always there. We have Sophia. She's asking, how do you see AI tools like GitHub Copilot involving in next few years? Not
Yeah.
taking jobs,
So
definitely.
yeah, but I can say one thing. Software work will be taken. A lot of workload will go to the AI, because the way we
Mhm.
were you used to write the code in the past or even now, it will change heavily, because now we don't need to write all the code. We need to write a good command, and we need to just barely validate those things. So I see like there will be huge impact, especially in the software development. But definitely this is not going to replace, but we need to able to cope those AI changes as well. So we need to able to utilize those tools to deliver the faster. That's what I
Yeah,
can say.
that's right. That's very well answered. I would say that's very well answered. We'll take one final one, and this makes sense because this may be helpful for guys. That can we use GitHub Copilot to write unit test cases?
Oh, I missed this line. Actually, in the GitHub Copilot, you have a very easy way to write the unit test case. You just select the function /test. If you entered, it will give you entire test cases required for that method.
Wow.
So we don't need to write any test case. As a developers, I feel very lazy to write the test case. Even I skip most of the time. So for me now, it GitHub Copilot, I just need to write /test. It will write the test case for me.
Wow, that this is really out of this world. And the few more questions coming up. There's Deepak asking his questions. Are the functionality for unit test generation? Yes, you have said it. Yes. That's right. And there
Yes.
are a few other questions. I don't think we have enough bandwidth today. There's a lot of
Mhm.
questions on LinkedIn also coming in. But
Mhm.
Rijwan and Satya, thank you so much for doing this event for us. I know it's evening time. It's usually time when you go out and have some
Mhm.
chia or something.
It's the chia time.
Yeah. So I really want to thank you both. I always enjoy hosting you both and having us in the community. We're gonna do conference in October again in person if possible.
Yes.
Please do show up.
Yes.
Otherwise, I see
Yes,
you all
yeah.
doing many events.
Yeah.
And yeah, thank you so much once again. I'll see you
Yeah,
soon.
thank you, Simon, and
Thank,
thank you,
thank you,
Sisab, for the
Simon.
team.
Thank you. See you soon.
Bye bye. Bye. Take care. All right, that was it. Rijwan and Satya for you coming all the way from Nepal. Absolutely amazing session around GitHub Copilot and AI and all crazy things you can do with AI. Moving on to our next session is by Abhishek Mishra. Well, actually, I should say Dr. Abhishek Mishra, right? Because he has spent good time doing PhD. He was away from community. I literally begged him to come on to this conference. He's a very busy person. Ladies and gentlemen, please put your hands together for none other than a community rock star in the C Sharp Corner community and generally, Dr. Abhishek Mishra. Hi, Abhishek, and welcome to Code Quality Conference.
Hey, hi Simon. Thank you. Thank you for this opportunity, I would say. And it's wonderful talking in this platform always.
We really miss you. And I was looking at those pictures, right? Very old pictures, some great memories. I think
Yeah.
Rohit has done really good job in picking up all those pictures from social media. How's everything at your end? How's life?
Yeah, it's going cool. Life
Yeah.
is always a roller coaster and we need to just ride on it and
Yeah, I bet
keep
you're
moving.
riding it very hard on it.
Yeah.
So, Abhishek, I know we're already some minutes in your session. Please feel free to
Mhm.
go ahead and share screen, and then you can get started.
Yep. Okay.
And for everyone joining in, Abhishek is going to talk about code quality metrics to measure and quantify quality of code. I think this is a super duper important session. Everyone should tune in, and I think there's something to take away from every single one. And if you're dropping your comments in the chats, I see a lot of people are dropping comments. Use the hashtag code quality con, and we're going to do a giveaway towards the end. Abhishek, I see your screen. I've added it to the stream now. Everybody else can see it, and next 40 minutes is all yours.
Thank you. So, hi all. Like today, I bring you an interesting topic like how to measure code quality for the code you write. Definitely, it's important, and our leads keep bugging us like, please write proper code, proper code. But no one tells us like how to quantify the quality. So here we will see some techniques, or rather, some measures that we can use to actually quantify the quality of code. So before I move into the topic, I would like to introduce myself. So I work as a cloud architect and have a little less than 19 years of industry experience. I've designed digital transformations using cloud, AI, and robotics all these years. And I have built enterprise grade solutions for large and complex organizations across the globe. I have published 7 books with like BPB and Appraise on Azure. I'm TOGAP certified, and I am a PhD from Swiss School of Business Management in the field of digital transformation in healthcare. So with this introduction, so let me move ahead. And what I have for you is like we'll start with on a very lighter note. Try to understand why we need to measure code quality in the first place. So what is the role of code quality? So once we understand that, then we will be able to understand or interpret the quality metrics that we have in hand and how we can use these metrics to measure the code quality. So we'll see that, and post that like we are going I'm going to show you. I'll open a project, a live project, and I will show you in like in maybe a 2 to 3 minutes or a 5 minutes activity. So where I will show you like how to measure the code quality for that entire project, and how to interpret it as well. And post that, very important thing, end of the day, everything is a business. We write a code to earn, someone earns or makes some financial benefits out of the code we write. And when we have some financial benefits, we have legal obligations. So what is the impact of bad quality code on business? I have a snip that I'll show you, but we won't be diving much into the business impact of code quality. Okay, to start with, why do we need to measure the quality of code? So why it is needed? So in the very first place, so if you don't write a proper code, we will end up in introducing bug in our code base, right? The delivery will be defective. You will have very fine guys sitting at the other end of the table and charting out very good functional requirements. They will strike up a very nice discussion with the customer, or you yourself, like many times, like developers also get part of the team that does a business analysis. So during the business analysis process, so you will have the requirements crystal clear. You will be able to map all the NFRs, so you'll have everything in place. Then you go and try to translate those requirements into code. So when you translate it, if the translation is not proper, or rather in a hurry, we write a code maybe for various reasons. Many times I see we get a push from the customer that we need the delivery right away, or something we need to do this immediately, or something like that. Due to some kind of pressure, we end up in writing some bad buggy code, and that adds to a defect delivery. And finally, what we deliver to the customer is maybe it meets the requirement, but when the customer plays around with it, then it sees that its functionalities are not working properly as expected or as outlined during the requirement discussion. So that is one of the areas. Then we have performance issues, very challenging. So we all face that. So at least my team faces that. If my team is watching now this video, they can actually correlate what I'm talking about. So normally we do a performance test, but rather if you don't write the code properly, so we are liable to introduce performance issues. So that can bring down your system or make your system slow. Okay. So then we have the technical depth. That is a very important thing. We don't write proper code. Okay. We don't give proper comments. We don't indent it properly. We do all kind of things that should not be done with the code, and we end up creating a code that is a lot of debt. Like what I mean by that is, as a developer on the ground, I write some bad code. Okay. Then I hand over the bad code to my to another developer. I take a release from the project and I move to the next project. So the other developer will not be able to make out much of the things out of the code. Why? Because your code is not having that kind of quality that someone can easily read it and understand it. And that's how you add a technical debt to it. Okay, you are adding a debt to it, and this debt flows into the next thing, that is the maintainability. Okay, so the code won't be maintainable, and you will end up in having writing really bad code, and it's not maintainable. And to whomever you are handling it over, or rather you are on a day leave, your peer comes and takes up your code, he won't be able to make out anything out of the code. He will it's not easy to maintain. And also so you might have scenarios when there are defects, or you want to add some new features to it. Okay, so if when you are adding some new features, if the current code base is not clean, it will be very difficult for it. Like for example, some class you will not be able to easily inherit. Okay, you won't be able to extend some kind of functionality in some other code. So it's very difficult to maintain that. Okay, so if the code quality is not proper, and with all these, you end up introducing a business loss. Okay, because your customer will take this, and whenever any customer signs a contract, they have a penalty clause. Okay, if the delivery is not proper, they can invoke the penalty clause, and you'll get into the legal issues. Okay, the customer will say, okay, okay, whatever it is. So I don't want to go ahead with like, let me just deliver this project. I don't want to go ahead anymore like with you. I'll find some other vendor for my other stuff. Or they can pull out the project and give it to someone else, resulting in business loss. And you'll get into legal tangles, like, because they will invoke the penalty clause, and in turn everything will lead to a reputation loss. Okay, so like next time the customer will not like to uh, get into this, and at the same time they won't be able to like drive this further, or like they won't be able to do a word of mouth to other customers in that region, as a result of which, like in the industry, like you won't have a good reputation, and no one will come and take your code, or take your service to build some product or something. Okay, so with this background, so let's see what are the different code quality metrics we have. The very first two metrics that I show you here is like these are the golden metrics I would call out. Whenever you write any code, so you should actually measure these metrics. Okay, one is the very famous Halstead software metrics. It's a very famous one. And what exactly it is so it goes to the roots of how the programming languages are built. Any of the programming languages, it can be built using either it can be built, or when you write any program, it comprises of tokens. Okay, so what are these tokens? They can be operands or operators. Okay, so these operands and operators can actually define the complexity. Like, for example, you're writing something, a code like int a equals b plus c. Okay, this equal to is your operator, the plus is an operator. Maybe let me show you in draw.io. I'll be able to talk about like what I'm trying to say. Okay, suppose I write a code something like this, int a equal to b plus c. I'll make it big so that it's well visible. Text, I'll make it sorry. Okay, for some reasons my okay, this is good. Okay, I write int a equals b plus c. So equal to and plus are operators, and all these are tokens. Int this variable a, b, c. Okay, your program is nothing but it constitutes of all such tokens that can be either an operator or your these operands. So this since our code consists of only this like operators or operands, so these are the only areas, or these are actually the areas that will add to the complexity of the code. That's what like Halstead software metrics talks about. It's a collection. Any software program is a collection of tokens that can be operands or operators, and tokens define the complexity and volume of a software. Volume, why? Because more the number of lines of code, more hefty is your software. And how do you quantify the volume? By these operands, operators, and all. So how do you see, as per Halstead? It's not me who is saying, it's the Halstead. What Halstead has proposed is any program length can be the total tokens in a program. Okay, that means the number of operands and operators. The program volume is nothing but it's the size of program in memory. Okay, what is volume? Volume is a space that anything takes, right? So your program takes some space in the memory. So the program volume is the size the program takes in the memory, and program levels is the levels of abstraction provided by a program. Okay, so when I say abstraction, go think about the OOPS principle. Okay, in object oriented programming, we abstract classes, right? So that what is there under hood is not visible. We just make it visible what needs to be consumed or to be known by the end consumer, not everything how it functions. Okay, so the number of levels of abstractions we add, that adds to the program level. Okay, so with these three, like program length, program volume, and program level, are very famous software metrics that you should consider while like quantifying your code quality. But these are not the ones. These are not the only ones. There are a lot of other metrics that Halstead has proposed. Just for like we have a very short period, so I can't take this Halstead end to end. So like these are the main ones. The next one is the cyclomatic complexity. Okay, that is nothing but the flow of your code, how your code flows. Okay, for example, let me again go here. Okay, I write if a greater than b. Okay, then console dot write line hello. Okay, 1 minute. Okay, else I write console dot write line hi. So in this piece of code, okay, whatever piece of code I have here, just one moment. So whatever piece of code I have here, so like you can see like one thing like it has two paths, correct? One is this if a is greater than b, then we take this path like console dot write line hello. Okay, if it's the other path, then like else path, then we have console dot write line hi. Okay, so my code has two paths here. Okay, if it would have been for example a while loop, while a less than 10, so my code has 10 path. Okay, there can be nested paths as well, like we can have nested ifs, nested loops. So all these contribute to like cyclomatic complexity. Why it is complex? Because you are opening multiple paths in your code. Okay, your execution can take multiple paths in your code. Okay, so that is why we like introduce cyclomatic complexity, correct? So if you go by cyclomatic complexity here, in this case, my cyclomatic complexity can be calculated as 2 based on the number of path it is taking. Okay. So coming back here, so what is cyclomatic complexity? It is based on your code flow, how your code flows. Okay. More the number of code flows, higher is the complexity, greater is the probability of error. Why? Because if you have 10 paths, like if else like this, you have 10 paths. Okay, so you may not be able to code coverage everything. Okay, then like there are high chances that some piece of code will, some path will get untested, and like there is a chance that if you have done some mistake there is a probability that you are introducing an error. And number of paths the program takes, it is the cyclomatic complexity. So these two are the golden metrics. Apart from it, from Microsoft documentation, you can see few more metrics like maintainability index. Okay, so how well you can maintain your program, this is very important. And whenever you are measuring the maintainability index, make sure your code should be between 20 to 100. See, above 50 is very difficult, but at least 40 to 60 it should, 40 to 50 like it should be ideally. 10 to 20 is considered moderate, but if you are having a low score like 0 to 9, it is very dangerous. And how it is deduced? It is deduced from a formula. I don't have the formula handy here. You can go to the Microsoft site and see that it takes a len of a logarithmic calculation of Halstead volume, cyclomatic complexity, and the number of lines of code your code base has. Okay, based on this, like it calculates an index, and that index is between 0 to 100. 0 is less maintainable, 100 is most maintainable. That is what the maintainability index speaks about. Okay, so what is the importance of this? So when you have a low maintainability index, that clearly says that you can't hand over the code to someone. And if you're handing it over, then like he's going to struggle with understanding the code and taking your code forward. Apart from it, if you introduce a new feature, then if you see a maintainability index score of a is so less, then you should like it's very difficult to add feature and all. And I will give you a very nice example. Like few years back, like we were taking a project from another vendor. Okay, so it was a vendor switch. The very first thing that we did was we calculated the maintainability index. But again, this was not this formula. We never used we used Halstead volume and cyclomatic complexity, but lines of code was not factored in. So we used we calculated the maintainability index, and we saw that the maintainability of the code is very low. So we went back to the customer and said that the code is not maintainable at all. We can't take a KT and get started with it right away. This code requires refactoring. Okay, so what is the next thing that will fall from, or like that will happen from this maintainability index? That is nothing but like refactoring of the code. Okay, if the code is not maintainable, so the maintainable index will be low. So that is where you can decide on to make the code maintainable. I need to refactor and again do it. So for our customer, like the project contracts were changed, and the customer, we could prove the customer that this is the score that comes, and we are not going to take this project as is and maintain it. So we need to refactor it and then take it forward. So it changed the scope of the contract. The SOW got changed. Okay. So another important thing is depth of inheritance. I'll give you an example. Let me again go back to draw.io. Okay. I have a class A. Okay. I have a class A. We have another class B. Okay. We have a third class C. Okay. And we have, say, another class D. I'll give an example. Okay. B inherits from A, C inherits for D, and D inherits again from A. Okay. This is how your inheritance looks like, made by any programming language. These are our classes. A, B, C, and D are classes. So here we have 3 levels of inheritance. Okay. We have 3 levels of inheritance. Suppose B is implementing a function from A. I mean to say, like B is like overriding a function from A. Okay. And D is also overriding the same function. And there is some changes in that function, or overloading. Sorry, let's call it overloading. Okay. So it's both of them are overloading some function from A, and both and A, there is some change in the base class. So what will happen is, the normally like what the developer did was he made some changes in class A based on the requirements of D. Okay, then this B and C goes into toss. Okay, because he did not consider or studied B and C properly. Without studying B and C, he made some changes in the base class based on the requirements from D. So your entire system goes on scoop. Okay, so there your it becomes complex. So the depth of inheritance is very important. For example, like I'll give you another example. So like A makes some changes, B is inheriting it. So the changes are in accordance to B, but C is also inheriting from B, and it can't consume the changes that A has made. Okay, so like again, like we are introducing error in this inheritance. So number of levels of inheritance, that is nothing but your depth of inheritance. In this case, the depth of inheritance is 3. Okay, so let me go here. So all that I said, number of different classes that inherit from one another, and more the inheritance, greater is the chance for introducing error due to modification in base class. Okay, so keep your inheritance minimum, but again, you need to inherit, or else like your code will not be reusable. But you need to strike that balance. So you need to write a proper code, but keep measuring the depth of inheritance. Another important thing is class coupling that we know, right? So what we do when we are writing any code, like we have 2 functions. Okay, so in one function, 2 functions in different class. Okay, like we have we have two functions. uh, we have two different functions. I'll give you an example. Just sorry, just give me one moment. Just give me one moment. Actually, my daughter she woke up. Just give me one. Yep, I'm sorted. So let me give you one more example here in draw.io. In draw.io, suppose I write code something like this. I write a class. Okay, so I write something like class A. Okay, this class A has two variables. Okay, like int A. Okay, maybe there should be properties, but I'm just for to save time, I'm just writing it this way: public int A, public int B. Okay, then I have one more class. Then I have one more class. So in this class, I have a function. I have a function. So this function, what it will do is maybe something like public int, maybe func. I will take A of A. You understand this, right? Sorry. This will be A of A, and I'll have my regular business code here. So what I'm doing is I'm trying to couple this class A in this. Okay, so in this function, so I have this class A. This A object is passed here. So we are introducing some kind of a coupling out here. So, and this adds to complexity, because if there are if something breaks here, okay, if something breaks here in A, okay, then the same thing, it will have an impact on function and it will break here. Okay, so if you go by that, so this also adds to code complexity. Okay, so this is the class coupling impact. So in another class, we are using another class that has a function, and that function takes a class variable, and that class variable, if there are any changes in the class, that can actually have some impact on the code. The very next code quality metrics is the number of lines of source code you have. Okay, it can also include a blank line. So whenever you're calculating the number of source code, because more the bulky your program is, more is the chance that you can introduce an error. Okay, so if the total number of lines in a program is some x amount, so it's proportionately your code is complex by x amount. Okay, then the lines of executable code, that means the number of codes that are actually executing. Okay, it can also include the blank lines. When your control flow is traversing through your code base, it's the number of operations that is actually there in that code base. Then few more metrics that I will call it out. Duplicate code. So when we write any code, it's a maintainability issue actually. So when you write any code, you tend to what to do is you write some duplicate code, we keep repeating the code again and again. Okay, instead we should create a function, have all those code there, and call the function from different places. Okay, that will reduce the code duplication percentage. Then is the code test coverage. Okay, but again, code duplication percent is something that you won't be able to measure using your Visual Studio or VS Code. But IDEs like IDEA, WebStorm, IntelliJ IDEA and WebStorm, they can actually help you detect this. And code coverage, test coverage is a very important parameter. So I can give a nice example. I'll come to that what it means. So when I started my career, so in Microsoft, we used to test Windows operating system. So we used to fix code there and test the Windows XP. So we used to release a code coverage percentage there. Mostly I won't call out the numbers, but based on the percentage, you choose whether to release the product or not. Because if the code coverage percentage is, for example, 40%, the testing is fairly good enough. Your test has tested at least 40% of the code base. Whatever test cases, automated test cases you have executed, it has touched upon 40% of the code base. Okay. Now, suppose you have a code test coverage of 70%. It's very difficult to reach a code test coverage of 70%, like on the grounds. Like, so it's, if 70%, then the code is very good. Whatever test cases, automated test cases you have designed, it has touched upon like the entire code base. Then a very modern kind of thing, it has very recently it has come up, like code smells. Okay, that is use of deprecated APIs. Normally we do it right. We write a code, we write some APIs, and tomorrow we tend to forget it, and it again pops out and haunts us back as deprecated APIs. Okay, this code should be regularly audited and upgraded. So normally, so you should check for the deprecated APIs. You should be regularly auditing the code. If there are any deprecated APIs, you need to take the necessary action, either upgrade it or like go for the next alternative substitute you have. Okay, so these are few of the metrics that I had thought of. So I would present. One is Halstead, cyclomatic, maintainability index, depth of inheritance, class coupling, lines of source code, number of executable code, code duplication, test coverage, and code smells. So these are few of the important ones that I covered. But trust me, these are just maybe few of the metrics that you can think of. There are a lot of other metrics as well, like a lot of more and more metrics. So you can think of, and more you make your code measurable, the quality of code measurable. If you're able to quantify the quality of code, then half of your journey is won actually in producing a good project. Okay, and what are the different tools that can help us in doing code quality metrics? This is a very comprehensive list, at least the ones that I have used and I have seen, but you'll find a lot of good tools around. Like I could think of Visual Studio, VS Code, IntelliJ, SonarQube. SonarQube is very popularly used. DeepScan, like if you're a JavaScript and a TypeScript, you write a lot of Angular program, you should consider doing a DeepScan. Okay, so with this background, like let me do, like it's all, or else it will look all theory. So I thought, like, let me do some Visual Studio activity. So I will show you in Visual Studio how you can actually analyze the code. It's very easy. So here I have a project. Okay, I have a project. So like it's my personal development that I'm like building some stuff. Okay, so it looks there are 5 projects, and in DB scripts also. Okay, it's just a script. Okay, so like and for these 5 projects, let me see what is the complexity. Okay, let me see just for this enterprise startup toolkit, what is the complexity. Okay, I can go to analyze, very easy, calculate code metrics for enterprise startup toolkit. See, for this particular project, it will give me like see, like the program. Okay, like there is some specific class 404 requirement for this class, like maintainable, it's a highly maintainable code. Okay, that means my team has done a good job. Then cyclomatic complexity. Okay, so all these so this green is or else it will show you green, amber, red. Okay, number of lines of code. So all these, like this maintainability index, I told you, right, it is between 0 to 100. So it's calculating those maintainability index. One more thing you can do is, I did it just for a single project. What if I want to measure all the projects in my solution? So how I can do is, go to the analyze, calculate code metrics for enterprise startup toolkit. So wait, sorry, analyze for solution. Okay, when you do it for the solution, for all the project, it will give you your code quality metrics. Okay, since I've written some good code, that's why I see all green. If there would be some issues in the code base, it's a pretty much of a real-time project actually, to be very honest, that I'm building. So like you can see this. Okay, so it's very simple. Analyze, calculate code metrics, and you are sorted. And you should keep track of this daily to see that you are always green here. Okay. Now let me come to the last part of the presentation, that is the business impact, okay, that we can have. So there are instances in industry in India as well as abroad, like in US, in Europe, like where we have written bad quality code, and like there are a lot of like legal tassels and all that has happened. You need it this, like this is from the CIO Dive. Okay, it's a CIO Dive magazine, so it's a excerpt from there. So, and this is the link. I'll like a link for the CIO Drive from where I have taken it. So you can read here: poor software quality cost organizations across all US sectors. Okay, this is like it includes like both like the customers who have taken poor quality code, they have lost 2.08 trillion in 2020, and also includes the integrators or like the developer, the application uh, builders or the developers who have delivered. So like this is the number, like collectively they have lost. And also like the operational software failures. Okay, like is the leading driver of cost. Okay, if there are how will you get software failure when you have not written the right code? Okay, your code has bugs, your code have defects. When the code will have defect, it will introduce software failures. Okay, cost estimates for operational software failures may fall short in context of a surge in cybersecurity failures as well. So it's dangerous. So you include cybersecurity risk. I did not name intentionally any of the companies, but if you Google around, you can find a lot of companies like who have actually suffered because of bad quality from both the sides of the table. So maybe from like on the pretext of a customer or a consumer of the code or the developer of the code. Okay. So with this, like I complete my presentation. So and apologies, we had some interview. Like actually, my daughter I have a small daughter, and like she woke up like when I was giving the session, and her mom was away. So she's 4 years old. So like I had to somehow pacify that. For that, actually, we had to have some disturbances in between. Apologies for that. And with that, I am like open to questions if you have any.
Wow, that was absolutely great, Abhishek. Your sessions are always so good to hear. You come with all this great experience, and it's really nice to hear on your session. So there are a few questions. I'm gonna take it from the comments, and the
Mhm.
first one, it's not, it's a comment. Kajal says, someone please do it for Java. Your session was so
Okay.
good. She said, someone please do it for the Java. I found it very nice. Technologies. Ajit is actually asking how to run code metrics test can done in VS Code. This is more of a tool-based question, but he's asking if we can do all that you have done inside the VS Code.
Okay. In VS Code also, like you can do it. There are plugins. You just need to like maybe I don't have the plugin installed, or I can show you.
Hmm.
But with plugins you can do it. Or else, if you have the best ways, if you have the Visual Studio, right? Normally we use it for enterprise
Yeah,
developments. So I showed you like in analyze and calculate code metrics, you can actually do the calculations. You should do it.
yeah.
You should do it daily before you start your day.
Man, who's gonna do it daily, Abhishek? Let's be honest with each other.
Yeah.
Okay, let's move to the next one. There's a Nitin is asking, how does automation enhance code quality in DevOps environment? I think this is one from the previous session.
Okay.
Perhaps what I can do is, how do you handle conflicts of different opinions, code quality issue within a team of experienced developers? You just get your word out.
I'll be honest here. Like, see, like how it can. I know, like when there are experienced developers, so we fight on code quality. Will normally the pinpointing goes on. So the best way is it's the role of your technical architect in the project to properly study it,
Hmm.
bring up all the standards, keep it documented, because document is something that is always binding. It's like a legal
Yeah,
contract in your team,
that's right.
and everyone has to follow that.
That's very well answered. So there's another one coming from LinkedIn, right? So valid in
Mhm.
here. Uh, Tarun actually says, with extensive experience, I find that interpreting code quality metrics can sometimes lead to analysis paralysis. How do you recommend balancing metric analysis with actionable development work? It does often, right? It is not as easy as it looks. I mean, so, what are your
Yeah,
thoughts on this?
yes, obviously. Like you have actually hit the nail. So I
Hmm.
would say like if you go get in step into the code metrics thing, so there are a lot of metrics that is there in the industry. Okay,
Yeah,
you just need to pull one metrics or other.
that's right.
Okay, so you just need to find the right metrics fitting into your process, your code, and the environment you're working on. But again, like you have to strike a balance at times also, like based on deliverables timelines. We need to like go for a trade-off.
Yeah, that's
The
right. That's
trade-off will
right.
always be there.
Yeah, one shoe size doesn't fit all, right? So
Yes.
you gotta find something that works for you. We have another question from Sophia Len. She's asking, how do you handle situations where code quality metrics reveal issues that are deeply embedded in the code base and require substantial refactoring?
That is what the example I gave. Like so like we have a case like where like we were taking a handover, like it's a 4 to 5 years back. So from a
Mhm.
vendor we were taking a like a handover, and we saw the maintainability index is very low. So but again, we
Yeah,
did not use Halstead index or like cyclomatic. The maintainability index was low, so that means the code itself was very bad, and it's right in depth from the framework level. So what we
hmm,
did was we changed the contract. So we went to the customer and said that, see, we won't be able to maintain it. It was a application maintenance project. So what we did was we did a refactoring of the code base. We changed the contract,
hmm.
and we convinced the customer with all proofs and legalities, and the code was refactored, and then it was taken forward. So if you have a bad code, if you see a bad code, the only thing that you can go ahead is like refactoring.
Yeah. And how long did it take you to convince everything to do the entire process?
Yeah, okay, that one, yeah, it was a pretty much of a challenging
Yeah.
task, because you need to explain your customer with all your data
Hmm.
points. So you need to gather the data points, give them examples.
Yeah, that's right.
That is
Re-
intentionally showed that business impact slide.
That's right. I mean, going and redoing the contract is a big thing, right? You got to
Yes.
convince your customer once again. There are a few more from LinkedIn, but I won't be able to pick it because I think we now have to move to the next session. And I know, Abhishek, it's evening time. You need to give time to your daughter, so I won't take much of your time anyway. I've taken it. Thank you so much, Dr. Abhishek Mishra. We always love hosting you, right? If there's any in-person event, and I will see you there.
Yep, sure.
Until then, take good care of yourself and enjoy your evening.
Yep. Thank you.
Th- Thank you. Bye bye. All right, ladies and gentlemen, that was Abhishek Mishra for you with some absolutely great tips, tricks, and things you can take away for the code quality. We now move to our next session. The next session is nothing less of a superstar on LinkedIn, right? If you post something on, if he posts something on LinkedIn that goes viral, I have seen it. The next speaker we have is Wahid. He's a CEO of Spota, and he's going to talk about cyclomatic complexity in code. To be honest, I have no idea what cyclomatic complexity means, so I am really looking forward to this. So without any further ado, let's welcome Wahid to Code Quality Conference. Hi Wahid, welcome to the Code Quality Conference.
Hello, Simon, and hello to everybody watching us around the globe. I'm so glad to be here today, and of course, this year in Code Quality Conference 2074. And how are you? I really
I'm
miss
doing,
you. I think our last discussion is for around 2 years ago, I think.
yeah, yeah, exactly. I mean,
That's
it's
okay?
been a while. Everything is good. Thank you so much. How are things at your end? Do you last time we got on a call, you had some problem with internet and all that thing. Has it changed or improved?
Of course, no. As you might know, that we have very limited access to internet in Iran. Uh, but this time, I'm connecting to you using the some VPN softwares, so to
Mhm.
assure the connectivity qualities. Of course, I'm very sorry about the last session that we had. Uh,
Oh yeah.
I'm really sorry for you and from all our audiences. Of course, some of the issues are not in my hand. It's related to the
Mm.
governmental internet access. I'm really sorry. I think this
It's okay.
today I can uh, do my better to to cover that shortcomings. Of course.
No problem, Vahid. No problem at all. We have over 380 people watching us right now. And I think we've already crossed more than 10,000 people watching this conference already. So I won't take much of your time. Please feel free to go ahead and share your screen and then you can get started. So people says, welcome,
Okay, let's.
Wahid. And if everyone's watching, you can go ahead and comment your questions in the chats. We're going to take those questions towards the end of the session. And if you use the hashtag CodeQualityConf, we will do a raffle towards the end and you'll have something to take. Wahid, I see you are inside StreamYard now. I can see your screen. Once you move to your presentation or something else, I'll add it to the stream. Yeah, I see you are in the presentation. I'm going to add it. Everybody else can see your screen, and next 45 minutes is all yours.
Thank you. Uh, okay, in this session, we're going to talk about the measuring architecture characteristics. Uh, of course, the software architecture is one of the important parts of software design and development, and we need to have a very good and comprehensive information about the software architecture and how to design it and how to manage it. In this session, we're going to specifically talk about the measuring the architecture characteristics. But before that, my name is Vahid Farahmandi. I'm born in Urmia, Iran, 1989. I have my BSc in Computer Software Engineering from Urmia University and in Medical Informatics MSc degree from Tarbit Madaris University. I'm an international speaker and a book author. Currently, I'm working as the Chief Executive Officer at Previously, I have authored 3 books, Design Patterns in .NET, specifically on geof patterns. The other volume of my book is Design Patterns in .NET, which is focused on enterprise application architecture patterns. Both of these books were authored in Farsi or Persian language. And my third book is about .NET 7 Design Patterns and Depths, which is in English version. You can get access to it using the Amazon. It's published using the BPB publications. So let's start the session. We're going to measure the architecture characteristics. Before focusing on architecture characteristics, let's clarify some concepts. When we're talking about the software architecture, of course, we're talking about 4 different dimensions. First dimension is the architecture used in our software. The today's are microservices or kernel-based architectural styles or the layer or tiered architectural styles. All these samples are architecture style. They are not our architecture. They're just our architecture style in our architecture. We have 3 other dimensions that we need to focus on them and clarify them in order to have good software, which is based on the business requirements and business needs. The second dimension in architecture is architecture characteristics, such as the performance, agility, testability, deployability, scalability, elasticity. All these characteristics needs to be analyzed in a software based on the requirements. We need to measure them. We need to find them and answer this question, why they are important and how they will affect our software. The third dimension is about the architectural decisions, which are our hard going to design the red lines in our architecture, and the fourth dimension is the design principles, which is the soft rules where we can define the variants in our architectures. Okay, with these introductions, specifically, again, I said that in the session, I'm going to talk only about the architecture characteristics, and specifically, again, we're going to talk about measuring the architecture characteristics. So you can now find out that it's very little world of discussions that we're going to focus on it. So there are many more other concepts and discussions. You need to find them, you need to analyze them, you need to have good information about them. About measuring architecture characteristics, we have, of course, many problems while we are interacting with the architecture characteristics. One of the very important problems is the fact that these architecture characteristics are not physics. It means that we cannot touch them. When we cannot touch them, it means that we will not have very rigid information about the software characteristics. Of course, when we do not have any rigid information about it, or when we cannot touch something, there might be some ambiguity about that concept. For example, when we're talking about agility, it's very important to know that how does the architects going through architect design, architect the software for agility. We cannot touch the agility. We have no previous understanding about agility, so we need to describe it, we need to clarify it, and we need to resolve this ambiguity around this concept. The second problem around the definition of architecture characteristics is that there might be a varying of definitions around some concepts. For example, when we're talking about performance, the different roles in our teams might have their own definitions and their own understandings around performance. Software architectures might see performance as something which is totally different from what a software developer sees about performance. So we need to get into common definition. We need to put all our team members or all our stakeholders on the same page to have a common definitions around the concepts. And the third problem is that some characteristics might be too composite. The agility might be composed of different characteristics, such as modularity, deployability, testability, or other characteristics, which means that all these characteristics, when we put all these characteristics together, the agility comes into account and shapes its definition. So there might be some characteristics which are too composite. So we need to, again, clarify them. We need to decompose them and define each them, find a common definition for each of these characteristics. In order to solve these problems, we need to have objective definition. Objective definitions means that we need to find our ubiquitous language in our team. Ubiquitous language in this case means that we need to have transparency in software architecture characteristics definitions. We need to define the characteristics. We need to find a start point of them, the end point of them, how to measure them, how they affect our software. We all need to clarify this definition in our teams, and all team members must have the same information and must have same definitions around this concept. So the transparency in software architecture measuring is really important. That's why we say that viva transparency, because without transparency, of course, our software architecture might be very weak, and it might not be help our overall software design as expected. In order to measure the software architecture characteristics, we have different mechanisms. One of that methods is operational measures. Of course, we can use operational measures only for the characteristics or only for measurements which have obvious direct measurements we have defined for them. For example, we're talking about performance or we're talking about scalability. We have some criteria which we can measure them. We can plus some numbers together. We can use different statistical methods and find a result or find our final measuring result. The main problem while working with the numbers, or main problem when we are working on operational measurements, is the fact of outliers in our data. Of course, when, for example, suppose that we're going to measure the response time of our applications, which might be about measuring the performance and scalability of our applications. When we're working with response time, we might have some data set. For example, you see that we have some data set here. The majority of numbers is around 1, but we have one number which is around 10,000. If we decide to use the average statistical methods to analyze this data, of course, our final result will not be true. True, because the majority of our data is equal to 1, but one of them is equal to 10,000. Okay, we're going to use the average statistical method. Average, what does average means? Average means that the majority of data is around some value. Okay, suppose that we have 3 1 and 1 10,000. The sum of these values is about 10,003. Okay, and then dividing it to 4 will result in a value which is around 10,000. It means that it's around a value which is not equal or which is not near the majority of our data. So the 10,000 here is our outlier data. We need to find that outlier data, omit it from our analysis, and calculate our final result without the outlier data. I mean that we need to ignore the outlier data, of course. We're not going to totally remove the outlier data. The outlier data here is very important to us. But in order to calculate the average, as we assume that we're going to use the average statistical method to analyze our data, we need to ignore the outlier data. But in the further analysis, we need that outlier data, of course. As you see that using that, the same data set, sorry, using the same data set, we calculate the average response time is equal to 1, but we are aware that our minimum response time is equal to 1 and maximum response time is equal to 10,000. So we're not omit that. We're not remove the outlier data. We just ignore it in order to calculate our average data using this mechanism while measuring the characteristics in operational measures. We have our average that's preserved, and we have more data to be aware of, which could be very useful to analysis and to measure. As you see, while we're working with operational measures, we were working with statistical analysis, and we're trying to build our statistical models. While we have our statistical models, of course, in the first stages of creating the statistical models, our model might be failed or it might not be fit very well into our data. The main reasons for failure of our statistical models is based on that the model is incorrect or something is amiss, both which teams likes to know in order to make their statistical models better and to evolve it over time. Of course, after some portion of time, we will have a very good statistical model which can fit into our data and which can gives us a very informative information about our characteristic measure. This is overall, this is what the operational measures work, but not all the software characteristics are. We're not able to, of course, measure all the software characteristics using operational measures. Some of the characteristics are structural measures, which are not so obvious, such as performance, or which are not obvious, which is not obvious as performance. For example, the complexity. When we're talking about the complexity or the code complexity, we have no operational measure to measure, or we cannot design a statistical model to analyze the code complexity. This is where the cyclomatic complexity comes into game. Using the cyclomatic complexity, we can calculate the total complexity of our code, and of course, we can we get into the numbers, we can again do our operational measures or do any other statistical measures. But the problem here is to create that numbers. About the cyclomatic complexity, we all know that the complexity, of course, is a code smells, might have a hardware might be affect our deployability, testability, or other software characteristics. We know that the complexity, of course, is not a good thing in our code. We should prevent the complexity in our code. Before we can prevent the complexity in our code, we need to calculate the complexity in our code. So let's see how we can calculate the cyclomatic complexity in our code. It's not very hard, of course. There's some formula to calculate the cyclomatic complexity in our codes. One of the very well-known formula is the CC is equal to E minus N plus 2 multiplied P. E is our number of the edges in our follow graph, N is our number of nodes, and P is the number of connected components, or let's say that it's number of methods in our code. Without any other descriptions, let's dive into some samples to calculate the code complexity in some sample codes. Before moving forward, there are 2 points to note. That's when we're the exit point is directly connected back to the entry point. Of course, our methods are linear methods. The exit point is directly connected to the entry point. Then we can omit the 2 before P, and our formula can be simplified as E minus N plus P. Or when we are talking about a single method, we are going to calculate the code complexity in a single method. We can omit P, and our formula can be simplified as E minus N plus 2. About calculating the cyclomatic complexity in class, we can use the average complexity between all methods in that class. That's how we can calculate code complexity in a class. Okay, that's okay. And the final point to note is that's the use case of the complex cyclomatic complexity. I mean that where it can help out. One of the obvious use cases for the cyclomatic complexity is that the cyclomatic complexity denotes the number of unit tests required for the code. It's very informative to developers while they need to find out how many tests they should write for their code, and how they should design their unit tests in order to cover the whole code, or in order to cover the whole business. Cyclomatic complexity can help them in that position too. For example, suppose this code, we have a code which is very simple. A is equal to 10, some if condition here. If B is greater than C, then A is equal to B, else A is equal to C, then print A, B, C. Okay, in order to calculate the cyclomatic complexity for this code, one of the methods is to design the flowchart of our code. We have a start point here and end point here. After starting, A is equal to 10. Each of these shapes are our N in the formula, are there our node in the formula which we discussed about it. And each of these arrows is the edge in that formula, okay? We have A is equal to 10, and we have a condition node here, B greater than C. It might go to A is equal to B, or when B is not greater than C, A is equal to C, and then print and finish. Okay, how many nodes do we have here? We have 1, 2, 3, 4, 5, 6, 7 nodes. Okay, and how many edges do we have here? I mean, how many arrow we have in this flow chart? Let's count the arrows. We have 1, 2, 3, 4, 5, 6, and 7 edges here. What was the formula? Formula was E minus N plus 2 multiply P. E is 7, number of edges, and again is the number of nodes, which is again 7. 7 minus 7 is equal to 0 plus 2 multiply 1. Why 1? Because we're going to calculate the cyclomatic complexity in single method. It's the single method that we're going to calculate. The P is equal to 1. The final result, or our CC, or cyclomatic complexity in this code, is equal to 2, which it means that we need 2 unit tests to write in order to cover this code. It's very simple. We need 1 unit test to test that the b is greater than 0, and we need other unit tests to cover the b is not greater than 0. It's very easy to calculate cyclomatic complexity and get many information from the code and the other information. Okay, let's move on to the other example. We have some other code. We have an if condition here, which there's another if nested inside it, and something else. Okay, let's create the flowchart for that code. We have a start and finish point here. A is equal to, there's a condition point. If A is equal to 345, then the B is greater than 0 is activated. Otherwise or else the print A row is activated and the code goes on. Okay, what's the code complexity here? I mean, what's CC is equal in this code? It's very easy. Let's count the nodes: 1, 2, 3, 4, 5, 6, 7. And the number of edges, it's 1, 2, 3, 4, 5, 6, 7, 8, I think. Plus 2 multiply 1. As you see that 8 minus 1 plus 2 is equal to 3. We need 3 unit tests to cover this code. Of course, if the cyclomatic complexity, whenever the cyclomatic complexity rises, it's increasing, it means that there are some depth, there some technical depth inside our codes. The greatest the cyclomatic complexity, the weakest the code structures. It's very important to note that. It's not good point. For example, we have a code with cyclomatic complexity equal to 100, and we say that, yeah, you see, my code is very complex and I'm the superhero of the thing. No, if the code's cyclomatic complexity is equal to 100, it means that the code is super weak code, and there are many technical depths inside that code, and we need to refactor that code. The lowest the cyclomatic complexity, the strongest the structure of codes, and it's very good to have the lower cyclomatic complexity inside the codes. Let's move on to other example to calculating cyclomatic complexity. We have another simplified formula to calculate cyclomatic complexity, which is denoted as CC is equal to P plus 1, where the P is number of predicates nodes contains in the control flow graph. Without drawing the flow chart, counting the nodes, or counting the edges, we can calculate the cyclomatic complexity of our code. Of course, not all our codes are that simple that we can draw the flow charts for that for our codes and then we start counting the nodes and edges. It's not very easy to do this in our codes or in our code evaluation. This formula, CC is equal to P plus 1, is very functional and it's very useful. P is the number of predicates nodes contains in the control flow of code. Okay, we have some codes here. There are many lines of codes here. It's not very important. Let's count the number of predicates lines in our graph. We have one predicate line here, while index is lower than or equal to n minus 1. This is condition node 1. We have another predicate node here. It's not important that the predicate nodes are nested or not. It's not important while using this formula. We're just going to count the predicate nodes without paying attention to the nesting level of them. Okay, we have n person next is equal to 0. It's conditional node again. And we have the third predicate node here, which is index is equal to n. This conditional node number 3. So what's our cyclomatic complexity? Easy, P plus 1. P number of predicates nodes is equal to 3. 3 plus 1 is equal to 4. We need 4 unit tests. We need 4 unit tests to cover this code. Or in other definition, we can say that there are 4 different routes to execute this code. One of the very important definition of cyclomatic complexity is the number of routes to execute that code. Cyclomatic complexity here is 4. It means that we have 4 different and 4 unique routes to execute our codes. Of course, when we have 4 unique routes, it means that we need 4 unit tests. We need to write a unit test we need to write a unit test for each our unique row. It's very easy. Okay, let's go to other example. Oh, we have another code here. Oh my God. There are something in the screen. I'm not going to read the code at all. Let's calculate the cyclomatic complexity here. Oh, we're going to find out another method to calculating cyclomatic complexity. We can put line numbers in our codes, starting from 1 to 15, for example. Of course, the variable declaration lines are not counted. Let's see how this one works. We have line number 1, 2, 3. They're all executed sequentially. There are not predicate nodes here, so it's not important. We put 1, 2, 3 in same shape. After executing 1, 2, 3, we're going to line number 4. In line number 4, we have two options. We can jump into line number 13. We can jump from line number 4 to line number 13 if the index is not lower than or equal to n minus 1. Then we will jump into line number 13. Or if the condition is correct, from line number 4, we will jump into line number 5 and line number 6. And this analysis continues until we reach the end of our method. So how we can use this graph to calculate the code complexity? E minus n plus 2 multiply p. How many edges do we have here? Let's count the arrows. We have 10 arrows in this shape, and how many in this graph? And how many shapes do we have here? We have 8 shapes. 10 minus 8 plus 2 is equal to 4. Without using the graph, we can use the previous formula, p plus 1. How many predicates do we have? We have while, if, another if. We have 3 predicate plus 1 is equal to 4. Our cyclomatic complexity in this code is 4. Again, what does it mean? It means that there are 4 unique rows to execute this code. It means that we need 4 unit tests to cover the all execution rows in this code. Let's see other example. It's very easy to calculate cyclomatic complexity in this code. Of course, this code example is the GATE CS 2004 exams questions. Let's calculate the code complexity in this example. We can draw the graph from line number 1. We have option to jump into line number 6, or we can further the execution to line number 2 or 3. Again, from line number 2 or 3, there's a if condition there. We can jump into line number 5, or we can further to line number 4. We reach the end of our lines. But code complexity here, number of edges minus number of nodes plus 2 multiply p is equal to 3, or p plus 1, number of predicates. How many predicates do we have in the screen? While and if we have 2 predicates plus 1 is equal to 3. Our cyclomatic complexity in this code is equal to 3. Let's see another example where we have a loop here. What's our cyclomatic complexity here? It's not important that we have 4 in our code, or we have if condition in our code, we have switch expression. They're not totally important. The predicate here is the key to calculate the cyclomatic complexity. How many predicates do we have in the screen? Predicate number 1 over 4. Predicate number 2, A is equal to B. It's very important to note that when we're going to combine the if conditions using and or expressions, they will be counted as separate predicates. Okay, predicate number 2, A is equal to B, and predicate number 3, B is equal to C, and the final predicate, else if A is not equal to B. When we have else if in our code, it will be counted as a predicate. But if it was else only, it's not predicate at all, because else predicates is counted in the previous if statement. So here in this code, how many predicates do we have? Predicate number 1 for 4, A is equal to B, B is equal to C, and A is not equal to B. We have 4 predicates in screen. The cyclomatic complexity is equal to 5. Example of calculating cyclomatic complexity. We have some code here. Oh my God. Of course, I'm not going to read this code, but my colleague comes to me and asks me that whether this code is good code or not, whether this code is complex code or not, whether this code is there any technical depth in this code or not? I need to calculate different measures. One of them is cyclomatic complexity. From cyclomatic complexity viewpoint, I can say that this code is complex or not, but I need to quantify this qualification. In order to calculate cyclomatic complexity, P plus 2, one number of predicates for each one, if, 2, and the third if here, 3. We have 3 predicates, 3 plus 1 is equal to 4. So from cyclomatic complexity view of point, I can say that this code is a good code. It's not very complex code. Again, I'd note that from cyclomatic complexity point of view, this code is not complex. We have other measures to consider when we're talking about technical depths. There are many different measures we need to calculate. One of them is cyclomatic complexity. The other one is lines of code, the depths of inheritance, and the other factors we need to calculate and paying attention to them. But from cyclomatic complexity points of view, this code seems to be good code. But from lines of code, if I need to analyze this code from the point of view, of course, this is not good code. Okay, what's good value for cyclomatic complexity? Of course, finding the good value for cyclomatic complexity have direct relation with the problem area we're working on. Sometimes we're working on a problem, on a complex problem, which has only one complex solution. So when we have no other way to solve a problem other than that complex solution, then the high cyclomatic complexity for that solution would be okay, which can have a solution with lower cyclomatic complexity, but we achieve the cyclomatic complexity with the high value. Of course, our final result would not be a good result. But totally, as a rule of thumb, we can say that if the cyclomatic complexity is between 1 and 10, it's a good code. The structure of code and the it's well structured and well written code. The code is high testable and cost and effort is less. It's a rule of thumb. It's a rule of thumb. It might be different from a project to the other project. When the complexity is between 10 to 20, it means that, okay, we have some problems in our code. The testability is going to be affected in a negative manner, or the cost and effort is medium. If it's between 20 and 40, it means that we are facing very complex code. The testability is low, cost and effort are high. And if the cyclomatic complexity is greater than 40, it means that's okay. The code is not at all testable, and we're facing with an electronic garbage. We need to, of course, refactor that code. Again, I'm going to get back to my first expression. The desired range or the desired value for cyclomatic complexity is directly related to the problem and solution area. These numbers, these range, are rule of thumb, are some things to be considered as best practice, for example. They are not hard rules that we should apply them on all projects. No, they're rule of thumb. Their range might be smaller or bigger in different projects. The final method to measure the architecture characteristics is the process measures. Some other architecture characteristics are composed of many other architectural characteristics. For example, as I said, in the agility software architecture, the agility might be composed of testability and deployability. We need to measure testability and deployability in order to measure the agility in the top level. Okay, testability can be measured through the code coverage testing, and we can gather the result from code coverage testing. Okay, but in order to calculate the deployability, again, we might need to calculate some other inner software architecture characteristics, such as the successful or failed deployments. We need to measure the rate of successful or failed deployments in order after measuring deployability and measuring testability, we can finally measure the testability in our software. So we need to measure the whole process in order to measure our architecture. In order to sum up the discussions in the session, we introduced the 3 different measuring methods to measure the software architecture characteristics. The operational measures, for example, performance, which we're going to using the architectural models or architectural methods. Structural measures, for example, using the cyclomatic complexity. There are many formulas and methods to calculating the cyclomatic complexity, and the third method using the process measure to calculating the software architecture characteristics. I hope that this session was be informative for you. In order to contact me, you can use v.farahmandi@jingat.ir in order to send me your emails, or you can find me in GitHub using Vahid Farahmandian. You can find me using v.farahmandian on LinkedIn, Vahid Farahmandian in Instagram _Jingat in Twitter or X. You can read my blog post in jingat.medium.com, and you can watch my videos in YouTube using jingat.net YouTube channel. I hope for you. Okay, Simon, I'm here if there are any questions to answer them. Thank you.
Yeah, those are, wow, I love your last slide. It has thank you written in all the languages. You're so creative.
Yeah, of course, I've copied this the final slides from Microsoft Slides in order to to have the copyright here. This from Microsoft. We need to thanks the Microsoft for designing this very great slide.
Now I'm gonna copy it from you now.
Okay.
But that was great. I really loved Wahid. I could see so much effort that you have put in your presentation. I wasn't expecting a presentation that would have all these numbers, mathematical calculations. And I think this was really interesting. If someone goes back and look at their code and try to do all this mathematical calculation, it would be really nice. I really loved it. And if you have a couple of questions, then we still have about 10 minutes before we move to the next session. Bhaskar says, great and easy formula. I loved it. I wasn't expecting this session. Sophie is asking,
there's
how
an
do you...
important point here, Simon. Sorry.
Go ahead.
There's an important
Go ahead.
point here. One of our formulas was the CC is equal to P plus 1. Using this formula, you can use, for example, .NET Roslyn compiler to write your own code complexity analyzer and attach it to the Visual Studio in order to use it inside your build events. I mean, I'm going to say that using that formula, you can have very good tools which is attached to your build pipeline, and you can prevent the codes with lower quality from deploying to the your staging or production. Important to know how to use that formula. The formula CC is equal to P plus 1 is very informative and very useful in order to write tools using the Roslyn compiler and going to other. Okay.
Wow. Yeah. Yeah. Every time you say something, there's so much to take away. The question coming from Sophie, she's asking, how do you ensure that cyclomatic complexity remains manageable as the code base evolves and grows over time? Yeah, I mean, the example you said was great, right? And this question makes sense because those were for the samples. But how does that work when the code is really big?
That's exactly what I said in my previous expression. You can write your own tool using the Roslyn compiler, attach it to your build pipeline, your CI/CD processes, and you can measure this. You can measure the cyclomatic complexity in your build pipeline, and you can prevent it from going forward. So you can use that in your you can use it in your build pipeline, or even you can use it before build pipeline while analyzing your pull requests in your CI/CD processes. For example, you can attach it to your Sonar Cube to analyze your codes. It will be automatically analyze your code based on the formula you have developed. I think it's very the best methods for ensuring the quality over time is to put it in the CI/CD pipeline.
Wahid, have you written any book on it? Because I think you need to write one.
My book, which I introduced at first of the slides, the Data 7 Design Pattern Depths, the half of that book is related to software architecture, where I've discussed about this kind of this kind of things, and the other half is
Hmm.
about design patterns. I think the last 7 design pattern books would be great. However, I'm going to plan to write one specific book for software architecture. I think it would
Yeah.
be published in the next year, I think.
Yeah, that would be really great. Let's take one question from Ibrahim is asking. So, from your talk about the numbers of predicates, shall we conclude that if we want less complexity, we should use less predicates? Is it true for all the case and logics?
Of course, in developing the complex, in order to solving the complex problems, we need to have multiple predicates.
That's right.
It's important to decompose your large code into small methods and write your codes in small components, or write your codes in small modules. Uh, you can make benefits of the design patterns. It's important to have a well-structured code. We're not going to minimize anything in our code. We're going to well-structurize our code. We're going to well-organize our code. The organization of code is very important when we're talking about architecture, because the well-organized code means that I can maintain the code easily in the future. But if the organization of the codes is weak, or the software suffers from the weak organization of the codes, the maintainability of codes will be negatively affected. So we're not talking about using the limited number of predicates in code. We're talking about well organizing that predicates in our codes. The code should be testable. Okay, if I need to write a code which is well testable, what should
Hmm.
I do? I should have a short method, short cyclomatic complexity, short unique number of rows to execute that code to ensure the higher quality of code. Putting together these small methods will shape the large functionality, which will be move me through the success in our code. That's where David Pine, Microsoft says, my friend David Pine, one day told me that we're going to use the small steps toward success. Here, the small steps is the small methods, which will
Yeah.
help us to get access to the large solution area.
Yeah, I think all the developers listening, right, they'll go back after their session and look at how big are their methods. Usually my methods are very big. Yeah, I'm guilty of that. Uh,
Exceptionally, the very big here is not good. It should be very
yeah, so
small.
thanks for asking the question, Ibrahim. The pastor is asking that, so does that mean that any number that is less than 40 is not at all testable? But what if this is the business need and do we need to continue with the same code base?
Yeah, I told you that the
Hmm.
solution is highly dependent on the problem area. Sometimes we are facing a naturally complex problem area which has only
Hmm.
one complex solution. That's where we agreed and we accept the cyclomatic complexity. But if we're facing a problem area which we can have a solution area with lower number of cyclomatic complexity, we should move through that. Okay, so as a sum up, if there is a business need and we have no other way to solve the problem, for example, we're going to implement a very complex algorithm in our codes. Of course, to solve that, we have only one way. We
Hmm.
accept that cyclomatic complexity and we put it aside. That's where variant comes into game. As I told the first of my slides, when we're talking about architecture, we're talking about 4 dimensions of architecture characteristics, architecture styles, architecture decisions, and design principles. Design principles have very important part, which means variants. Variants means cases where we can ignore all our rules, where we can define exceptional rule. That the variants can help us. Okay, if it's business need, and we should assure that that's the only possible method to solve that problem.
Yeah, I think you need a glass of water after this because you have been speaking very continuously. Okay, so Rohit says amazing session, Wahid. Thanks, Rohit. Of course, Bhaskar really loved it. We have a few more questions. I don't think we have enough time. There's a few questions on LinkedIn. For some reason, they're not coming in. But yeah, 470 people are watching this session, which is absolutely great. Of course, you know her, right? She says, "Thank you very much. That was perfect." All right. All right. All right.
Yeah, she's my
What
wife.
else? Yeah. Yeah, I could get it. I could get it. That's why I said, you know her.
Yeah, she's from our
Ibrahim
team.
says, Ibrahim says, I love your passion as well. Yeah, I mean, I agree with Ibrahim. When you were delivering the session, I could definitely see the passion in your session and the way you were speaking. It was absolutely great. I loved it, Wahid. What time is it at actually your place?
Here is 5:15 p.m. here in
Okay,
Tehran.
that's yeah. Okay, it's time to time to just wrap up your work and go out some walk. Okay, right. So I'm not
Yeah.
gonna take much of your time. Right. Thank you so much once again. I really love hosting you. Right. I really hope that someday we get to meet you. Come to India or you are in Europe or somewhere we'll meet. I'm looking forward for that day. Any final thing you want to plug in before we wrap it up?
Of course, passionately, I'm looking forward to a situation that can come to India. Of course, let's add this to the sessions that's covering the Islams, covering the poor people in the world. Of course, in India and Iran and all around the world, it's our social duty. We should all move forwards to cover our friends, our colleagues, our humankinds in Islam. So I would like to ask all our guests to pay attention to the Islams in their own countries and or in their own regions.
Yeah, that's very beautiful said. I wasn't expecting it. You're very kind, Wahid. Thanks for putting that out. Our heart goes out to whoever are suffering, and we want everyone to have nice life, right? A good life at least. So yeah, everyone just help each other. That's the least we could do at this moment. Thank you so much, Wahid. I'll let you carry on with your evening. Thank you so much once again for this conference, and see you soon. Bye bye.
See you soon. Bye.
All right, that was Wahid for you. Absolutely stunning speaker with great knowledge. It couldn't get any better if someone had to talk about the cyclomatic complexities. So much of maths over there, so much of plus minus. I honestly did not expect a session like that. We now, I think we're almost halfway down to a conference. 1, 2, 3, 4. I think we've done only 4. I think we have about, after a couple of sessions, we'll be halfway down. Our next session is by Paco. He's going to talk about cracking the code review from guesswork to automated guidance. But before we get there, let's take a minute break and come back, and I will see you soon. Where did that go? Yeah, that's the video one. All right, everyone, welcome back to Code Quality Conference. I'm your host, Simon, and this is the 4th edition of Code Quality Conference. We do this every year around the summer. And if you're joining us just now, you are watching this conference along with 471 people, as I see 72. Okay, 70. It goes plus minus 2. About with 470 people watching this conference right now. I know by the end of this conference, we'll end up with like 40, 50,000. It's really crazy. A topic like code quality is loved so much, and no one really talks about it. If you just Google Bingle, or use your favorite search engine and look for a code quality conference, this is the only conference that shows up. There are a few others too, but I think it is the speakers at this conference that make it really successful. We now move to our next speakers, Paco, right? He is a software engineer at HDR. As I said, he's going to talk about cracking the code review from guesswork to automated guidance. It's a really interesting one, and I'm really looking forward to it. So without any further ado, let's bring Paco to the Code Quality Conference. Paco, welcome to the Code Quality Conference.
Thank you. Wow, that was a nice video. You managed to find some pictures that I forgot about. Awesome.
Yeah, those are some. Yeah, you looked very young in those pictures. I can say.
Time can do many things.
Yeah, exactly, Paco. So how are you doing today?
I'm doing well. It's a bit hot here, but it's good to finally have some proper weather.
How hot it is in Delhi? It's 50 degrees Celsius.
Sorry?
In Delhi, it's 50 degrees Celsius. How hot it
Oh.
can get in Europe?
No. And then, but it's, I mean, these are my Dutch roots. I will be complaining about the weather, regardless of the weather.
All right, Paco, I'll let you get started with your session. I'm really looking forward to it. I'm going to add your screen to the stream. Everybody else can see it, and next 45 minutes is all yours.
Cool, thanks. So yes, good morning, afternoon, and evening, since I think we're a nice international live stream, which is really cool to see, and thanks for organizing this. I'm going to be talking about code reviews. I also saw there's another talk in the schedule, which is about not using code reviews. So let's first start with the good side of the story, and then I'm very curious to hear later on what the other presenter has to tell. As I was already told, my name is Paco van Beckhoven. I am from the Netherlands, living in Switzerland, and I've been working for quite some time already in the field now, of which I spent quite some time as a consultant as well for various companies, mostly in the Netherlands, but also companies like Google and Picnic, where I saw a lot of different environments. And from that, I actually learned quite a lot of things. And when I moved and started working for Hexagon, I finally found a place where I can sort of apply all these rules and help the team mature. Which is also the reason why I created this talk, to sort of educate you about all the lessons that I learned, and also because I really like code quality. So my day-to-day job, I work as a software engineer at HXDR, which is it's a cloud-based platform that allows users to create and explore large 3D models from the browser. And there's also quite some other cool things we do, like, sorry, I just got distracted. There was some sound. We have drones that can do 3D scans and all kinds of cool stuff. So it's quite a nice place to work, and they were nice to give me some time to present for you this topic. So without further ado, I'd like to start with a nice, but also not so nice number. So 360 billion was the estimated cost of bugs in 2013, according to research done by Cambridge students. And this included the time of finding and fixing bugs. Now, given that this was in 2013, with all the inflation and all the things that are going on, you could say that by now, 11 years later, this probably has doubled, just like houses. So what can we do about this number? How can we reduce it? Because this is a big bite out of the IT industry. And one that is a fairly classical diagram that is shown is that the cost of fixing a bug increases over time, or depends on the stage of where it is found. So whenever you found something later in production, that means that you need to figure out what's going on. Probably there's some damage that you need to recover, and you need to figure out how to fix it. So there's a lot more time spent than if you do this earlier on. And one of the things that can help here to find a bug earlier is through something called code reviews. These typically take place around the coding and testing phase. Of course, there's a lot of reviewers also early in the project, but I'll be focusing on code reviews. And what is a code review? So I think it consists of 3 important parts. The first one we already mentioned, which is about finding and fixing bugs. So catching bugs early, saving money, frustration, and also reputation. But the other ones are maybe even more important, which is about learning and coaching, helping your teammates grow, learning from each other. And also it's a nice place to mentor new employees or the juniors to give them some guidance. And code quality. You can use this to sort of enforce and improve code quality over time, which I think, because, hey, this is the code quality conference, I really like code quality. Let's give it its own definition. What I like about this is effectively it covers many different things, from the maintainability to how readable it is, efficient, but also what I really a big fan of is coding conventions, consistency, and just following best practices. And this all is something that code reviews can help you with improving this. Now, this sounds all pretty good, right? I'd say. And yet still, you sometimes come across this. And I would like to add here that, yes, there are some nuances. Not everybody and not every team needs code reviews. I probably will like to hear that later on, some other reasons. But suppose you heavily invest in pair programming or mob programming. That means that you're ready to do the review on the go, which you could argue is maybe more efficient, or you're in a small, high-performing team. Of course, there's different things to consider here. Now, with that nuances, the question is how can we efficiently incorporate code reviews into our daily development practices? And that is through something called pull requests. And normally, if I'm at a conference, I would do a show of hands where I would ask whether we should call it a pull request or a merge request. This is a bit harder online, but the reason why I ask this is specifically GitLab really pushes on the term merge request. I work with GitLab, and my co-workers punish me if I use the, they make it clear to me that I shouldn't use the term pull request because we use GitLab. In the end, throughout this whole presentation, whether I use pull request or merge request, I mean the same thing. It's about the request to merge a branch into, say, the main branch. And these pull requests have become sort of an integral part of our software development process. We use this to sort of gatekeep quality. And this is facilitated by most version control systems. I already mentioned GitLab, but there's, of course, a lot more. And these tools are really nice. They help us to create and review pull requests, and they also contain quite some useful integrations and features to improve reviews, which is, I would say, great. I need to double check, yes. So one of the challenging things about doing an online presentation is that you don't know whether you are still connected. I am, so that's good. So these tools help us to create pull requests. However, even though these tools really help us, we often see the less pretty side of pull requests. Just to give you some idea, like one of the things we see are the pull requests that change half of the project. In this case, 55 files with the least amount of descriptive values in there. Like this is awful to review. But there's also the awful comments that people leave. It's not always a happy place. Then there's the fact that nobody really likes to review. So you always get these channels on Slack or Teams. Hey, can somebody review this? Can somebody review this? And last but not least, it's always the curse of the small pull requests, where you see that the small request with 10 lines gets picked up immediately. Everybody is now keen to review, and everybody has some opinion about the 10 lines you changed. So how can we address these issues? And one part of the solution lies in creating good and review-friendly pull requests. So for this, I'm going to assume that all the changes we made are well implemented. They are concise, focused, and tested. We're not doing 3 features at the same time and another bug fix. We should create separate pull requests for that. Now, one thing that I want to keep you in mind is that when people start reviewing, you should just assume that they come in blank, even though maybe the whole team knows what's going on. The whole team doesn't know what was going on a year later when you look back at this pull request, because you try to figure out why was something done in a certain way. So what makes a good pull request? And then I think we should always start with a good title. Now, a good title should be self-explanatory, like a good commit message. And in this case, fix bug, not good enough. Even though maybe the whole team knows, because there's only one bug and everybody knows what's going on there, you might know it now, you don't know it later. And also maybe somebody else from the team doesn't know. So try to add some context, try to be more specific. And actually, as I already mentioned it, a good title is like a good commit message, is you can actually use the same conventions here. Because what we often see is that both commit messages, so either the pull request title becomes the commit message or the subject, and either the commit message or the pull request title usually also end up in the release notes. And with conventional commits, we sort of say we want to follow this convention, which makes it much easier to parse, but also to read commit messages. For example, you have the feed and the fix prefix, which allow you to sort of identify whether it's a major or a minor change. So this can be really helpful. And also don't forget to always include a reference to your issue tracker. For example, in Jira, most VCS tools actually automatically convert this to a clickable link so that you immediately get more of the functional context. Then the next step is description, which is also very important. And I'll just go over the different steps quickly. So I think the first one we should always add is some context. And this would be an extension of the title, maybe anything the reviewer should still know about the feature before you start reviewing. And then a what? A brief overview of the things that changed. So to sort of tell the reviewer what to expect. You made some changes to the DB, added a field to the response, and refactored the login logic. Just to give you a brief overview. Then one that's often forgotten is the why. And then with this, I mean, why did you make certain decisions? Why did you make certain choices? Because at the time when you are implementing your pull request, you go through the mental process. Hey, I can go either left or I can go right. I can either use this framework or that framework, or this query or that query. And unfortunately, this knowledge is usually lost once you commit the pull request. Or sort of once you create a pull request and some time goes by and you don't know what was considered anymore. This is something that the reviewer typically likes to know. So what I always recommend is to, whenever you made some choices or some specific decisions, write them down so that the reviewer doesn't have to ask about it, and you can also know in half a year from now still why certain decisions were made. And last, which I also really like, the examples. This makes adds some visibility to the changes that you made. Like, what did you actually change? And sure, not always makes sense if it's a small bug fix, but suppose you work in the front end, and it's nice to add some screenshots here of the things you built, so that people immediately, from the code, it's sometimes hard to guess how things will look. But also, this doesn't just stay with front end. For the back end, say you add a new API call, or you make some changes to the API, add an example request and response. If you make some changes to the database, add some example queries and results. Given the response example, suppose you added a new date time field, people cannot immediately see which format is used. If you add an example response, you can see which date time format was used, which might be relevant if you have another service that will depend on this and expects a certain date time format, so that you can immediately spot that rather than this becoming a bug later on. And then the biggest challenge is to keep it all concise and readable, because nobody likes to read a wall of text. I think I'm not even able to read a big wall of text without distracting myself at least 20 times. So add some sections, some bullet points, maybe some emojis to keep it readable. And this is also something where ChatGPT can be really helpful. Also, by the way, this is not, of course, for every pull request. Not every pull request justifies such a large description. Maybe just a small bug fix, of course, you have to enter less. This also goes with some sanity in what makes sense. Now, to help you with writing a good description, use templates. These templates make sure that the text is consistent across all your microservices or repositories or teams. Everybody's using the same format, so you know what to expect where in a pull request. And what the best feature about this, I would configure this on a team base, is the use of checklists, because there's always things we forget. And these are sort of the last reminder before something makes it to develop or before the pull request is open. What things should we still do? And an example of this is the architecture diagrams. Suppose you have some Confluence page or some wiki page in which you update the diagrams. This only needs to happen, say, 1 every 10 pull requests, where you actually add a new endpoint or a new dependency, which means that the rest of the time you don't. And that means that you also sort of get it out of your rhythm and you forget that you actually have to do this. Maybe updating documentation or release notes. And the other part that I really like about this is that it's also sort of the voice in the back of your head when it comes to, say, did you add tests? Like the first one, changes are covered by tests. So if you didn't do it, and you know you should do it, then this is the point where you sort of have the choice, okay, do I check it? But then I'd be lying if I didn't. So I should really write tests. It's sort of the second check, which I really like, because it's sometimes you're lazy. People are lazy. And then this is sort of the nice thing to remind them to not be lazy. Now, having created a nice and elaborate pull request, we need to do one more thing. And that is what we also have to forget, is to review our own code. Don't just throw it over the fence. Oh, it works. It's done. No, have a look at it. And especially if you look at it from a VCS tool like GitLab or any other, instead you see your diff in a different perspective. You can now immediately easily see, oh, hey, I made a change to this file, but actually I don't even need to be there. Let's undo that line break because it only adds noise to the pull request. Or you see, oh, wait, this name, maybe I should improve the name, or maybe there you chose 2 different approaches, and then there are some leftovers from the previous approach. But it's also useful to use commands to add some context. In this example here on the right, I actually removed the file, and because I wanted to make sure that it was not used, and also out of curiosity, I was looking since when this actually should have been removed. And because I did that research, I immediately just wrote it down. And now the next person doesn't have to figure this out for themselves. So it's immediately clear. It's again about, hey, you took the time and effort. Just take that tiny little bit of time. I mean, how much time does it take to write this? A couple of 30 seconds, maybe? And you save some time of the people that are reviewing it. It makes it for them much more easier to see that you did your due diligence and trust on that. And you can also use it to highlight important parts. So suppose you did a bug fix in a file, but you also had to rename some fields, or maybe you had to format it and the formatting was off. And now you have 20 lines changed, even though there's only one relevant part. And then it might be helpful to add a comment on that one line saying, hey, this is the core fix. The rest is just formatting and style. And the last one that I also like is you can use this to ask specific questions to both about your own code. Hey, you're uncertain about a certain part, but also if you're integrating with another team, like, hey, can the API team have another look at this? Because I'm not sure whether it's done correctly. Then immediately they have the context, like it's in that class, rather than that they get the full pull request and have to figure out where their relevant changes are. Now we did do the proper pull request. We did review it. We already fixed some things again. At least for me, I always find things when I review it myself where I was like, hey, that saves me already 3 more comments. Now we need to get people to review it. And in an ideal world, you wouldn't have to ask for reviews. Either teams proactively check for pull requests, or you can round robin assign people in your version control system, and people actually use that. However, in practice, we see that people are not very keen on reviewing. It takes them time away from their current task, which means they have to switch context. Maybe they think they can't find anything, so they're like, oh, why should I spend time on this? So people are not really tempted to respond to these messages. And this is because what I used to call the diffusion of responsibility, or shared responsibility is no responsibility when it comes to things people don't like. If you have 20 people and 20 people don't want to do it, then usually if you just ask it in a void, nobody does it, especially in something as anonymous as a team chat. Now, the best way to address this is by targeting specific people. Don't just say, hey, can anybody? Hey, teammate A or team member B, can you please have a look at it? If you tag the wrong one, they are most likely willing to tell you who's the right person, so you at least have some response and you know where to go. Also, what helps is to add some context. What is this PR pull request about? Because if I'm maybe coincidentally working on the same service on the same issue or a similar area, then for me it's much easier to pick it up. So it's already much clearer what this is about. And the deadline, add some sense of urgency, just so that people know whether it needs to happen right away or whether they can do it tomorrow morning. And something like that it would look something like this. So in this case, we tag some specific people. Maybe we add some team in the loop so that they can see whether there's actually being picked up. And we add some context. And the chances that we get a reply on this is much higher than on the first one, because probably we need to send out a reminder 2 or 3 times. And this actually is not just about asking for reviews. This is asking about for anything. If you are in Teams or in Slack and you need some information from another team or some help, it can be good to tag specific people, add context, add some urgency, and then people are more likely to help you. But this is, of course, this won't always work, and people are still going to forget. And it's good to keep that in mind. We all forget things. If I get a message while I'm also looking at this presentation, then maybe I've seen the message, but it's now marked as read and I'm distracted and now I forgot about it. It's okay to remind people and be patient with that. But of course, at some point, it's also okay to try to fix this. Now, we finally get some people to look at a pull request. How do we deal with the feedback that we get? Because not all feedback goes as expected. And it's good to keep in mind that this is not necessarily done with bad intentions. And there are people that simply lack the social skills, are not very aware of their social environment. And what you also often see is that there might be cultural differences at play. So take me, for example. I'm from the Netherlands. The Netherlands are known to be quite direct. So when we think of something, we'll tell you that. When we don't like something, you'll know. That's why we're so good at complaining. Which also means that when I work in an international team, it's good for me to maybe add some fluff to the messages I'm sending to make it look less harsh. But it's also good for the rest of the team to know that, hey, this is my normal way of communication. It's not because I don't like you. It's just because I don't know any better. In the end, it's mostly important to not take these things personal. If you want to be a real professional, then you have to be above all the office drama. You have to be patient and just be the bigger person and maybe help the other people by giving them feedback in a correct way to tell them, hey, the way you communicate sounds a bit harsh. Maybe you can improve. Because that's in the end what a professional is being about, and about being senior. It's about helping the team forward rather than ending in petty fights. What you also see is the fake feedback. And what you now can do when you get feedback like this is go into sort of trial and error approach, trying to figure out what this person meant with this and how it should be improved. It would save yourself a lot of time to just ask for clarification or suggestions. That's okay. Especially if somebody just doesn't like it, that's so vague, then you can don't waste your time trying to figure out what is meant here. Just ask for clarification instead. And the same also goes for the, speaking of saving time, the endless discussions. Please pick your battles. Not every space has to be a tab or the other way around, or it's at least not that important. But there might be things that are very important where you think, okay, if this makes it all the way through production, we have a serious issue. Then, and you're already in the 6th or 7th or 8th reply in your thread, maybe that's a good moment to not continue in the thread. It's nice to have these async communication tools and means, but it gets really distracting and it takes a lot of time for such a discussion to take place. It's much better to then at that point just take it offline or online, going through a synchronous discussion where you talk to each other and then come to a conclusion. And then what's really important and often forgotten is that people don't report back the results of the discussion. What was decided and why? And these are two very valuable things. Again, half a year from now, I have a similar problem. I look on Slack for this problem, and I now find that people had a discussion, but I don't know what the answer was, and they probably also forgot. And the same goes for pull requests or any open source discussion you sometimes see. Always report back. And it's just a one-liner. Again, it's 30 seconds, and it's so helpful. The future you will be very grateful for that. While speaking of being grateful, not all the feedback will be bad. There will also be lots of useful feedback. You will learn new things, or you will write better code and introduce less bugs. And it's important to also be grateful about this, because people took the time and effort to go over your changes, even though they might not like it. Rather than always saying fixed, done, ok. Maybe show some appreciation of the things that you actually learned about the new API call or something like that. Because a friendly message goes a long way, which also improves the culture of the company. People are more friendly, especially if you do a lot of remote work, then there's not a lot it's easy to get annoyed and you don't really speak to each other. People tend to get frustrated. Also show some things. It also adds confidence. Suppose the junior is reviewing for the first time, finally found something, then it can be really empowering to sort of tell them, oh, hey, that's a great question. Oh, hey, that's a really good suggestion. I actually learned something new. Because that empowers them, and it will also help them progress in their careers. And in the end, also will help you again. Now, enough about the review side. We're going to switch to the reviewers seat. So we're now going to give reviews. And there's two important things that I want to start with. The first one is don't wait too long. Review in a timely manner, because the longer it takes, the more time is lost on merge conflicts and switching context. What I actually liked, I saw a presentation on this topic as well, where they said, ideally, whatever work you do is on a backlog, which is prioritized by some product owner, which means that the first task is being picked up has the highest priority. Which also means that whenever you're going to pick up a new task and there's still work that needs to be reviewed, that work has a higher priority than your work, which means you should review that first before you start picking up new work. And I kind of think this makes sense. Another thing that you can do is when you start the day, you are fresh. You don't have to switch context. You can just spend the first hour of your day reviewing pull requests, just to get that rid of, and then you can have some focus time, and maybe at the end of the day do some more pull requests so that you don't have to switch context, but also keep up with it. And the other thing that's really important is taking responsibility. You often see the 500-line change, and people comment within 5 minutes, doing a 500-line review, saying looks good to me, and then click the approve button, and you know already that there was no proper review done there. Whenever you click the approve button, that means that you become the co-owner of the change, and which also means you are accountable. So whenever, say, something goes wrong, it turns out there's a serious bug in there, and the person who wrote is on holiday, you should be the next one in line to be able to answer the questions. Which means it's in your best interest to do a proper review rather than, yeah, I don't feel like it, but hey, at least it looks like I did something. And when we start reviewing, it's important to start with getting some context. We just spent quite some time creating a nice pull request description, so it would be a waste if we don't read it. Because often that's already where quite some answers to our questions are, especially if described well. And I've been in the seat of this picture as well, and where I dive straight into the code, and I'm like, what is going on? What is going on? And then at some point, before I start typing questions, I first want to go back to the description, and then there's my answer already. So save yourself some time and read the description first. It makes it much easier to review. But it's also, this goes two ways, because that means if there is no description at all, it's also okay to just push back on the review, the code review and the pull request, and say, hey, please add some description, because I can start guessing and reverse engineering from your change what you're actually doing, but this is not very efficient. And again, in the future, this will also not be very helpful. So don't waste somebody's time there. Goes two ways again. The same, also have a look at the existing comments. Don't go into the wild, because you don't want to ask the same questions that somebody else already did. It's kind of inefficient. Maybe it has already been discussed. Then we start looking at the code. And even though it's always very tempting to go straight into the code and in the code style issues, because that's what we know best, start from the top. And the main reason from that is that any feedback you have on the top that needs to be changed will trickle down. If the design is wrong, then probably all the codes or the tests need to be written anyway. So no use in looking at the tests or looking at code style if it might be rewritten. So we start with the high-level overview, whether the functionality, the high-level overview, if the functionality is in the right place. And then we go a step further. We see, is the functionality implemented correctly? Are certain scenarios missed? And then we start looking at the code, whether the complexity is okay. Well, we just learned about the cyclomatic complexity, but is there, of course, more? Is it readable? Can it be implemented in maybe a more efficient way? And then, and this is why I added in bold, the tests. Tests often get the least amount of love, not only and attention during implementation, but also during reviewing, which means that this is a double the issue, because tests are really important. Tests give us confidence in the sense that I'm talking, for example, about unit tests, whether we don't break something by accident. And what you see is that even I do it sometimes when I'm reviewing and I finally review through the 60 files of production code that changed. I still have to look at 20 more tests that are also changed, which are usually written slightly less efficient. But it's so important to look at whether the assertions are done right and whether the code is actually correctly covered. If it's not, in the end, a bad test suite will also affect you, because you might be introducing bugs because somebody else didn't do their work correctly. So what can help here is to go for the tool-assisted reviews. What can help here is some tools like the VCS tools. In the left, what you see here is GitLab allows you to show code coverage in the diffs if you supply it with Cobertura code coverage. And I think there's some other VCS tools that allow you as well. So you immediately see if something is covered or not. Sonar can also integrate often with your tools and already give you some hints. But in the end, the best tool to use is your own editor. And I know I have to give a small disclaimer here, because this is Java code on a .NET conference. I'm very sorry, but actually I am secretly a Java developer. I did do some things with .NET, but the example still holds. What you see here is I made some small changes. I introduced an extra if statement, just like an early exit, and I replaced some constant. And now in the GitLab, this kind of looks okay. But if I now look in my editor, your editor usually gives you much broader context, because you can now see the entire file. And now I can see that, hey, this constant is not unused, or hey, my editor actually has a suggestion to improve this. Or if I've run the test, which you can also do with Rider, and I think also with Visual Studio, you can run the tests, measure the code coverage, and have it inlined there. So now I can see this red means that, hey, this return statement is not tested. And one of the things that I see the least is that people actually look at the code coverage when reviewing. And it's so important, because this means that somebody should just write an extra test here to improve coverage. And the last is also that you have some extra context in the latest versions of at least IntelliJ, and I think also Rider, where you can see which files or lines were changed within if you open a certain branch. Now there's also some AI-powered tools, because with the rise of AI, we also have a rise of AI review tools. I haven't taken a look at them yet, also because it's often a bit complicated to just go around in your company with a new AI tool that may or may not use your data. But I would definitely recommend to have a look at them and see how they can help you, because also they can help you save time on reviews. Now, we also need to write some good commands. And whenever we give feedback, what I often see is, and what I don't like to see is the word you and bold statement. So if you look at this example here, this is quite a bold statement. And it doesn't sound very friendly. It actually sounds quite harsh. However, and that's also the problem. If you use you, it can be interpreted as a direct attack, which makes people defensive and less likely to cooperate. Whereas we is about collective ownership. It's about collaboration. So you're already, hey, we made a weird choice, even though, of course, implicit, it's the person who made the changes. You didn't make the changes, but it's about the collective. And the same goes for bold statements. If I make a bold statement, there's also a chance that I'm wrong, because nobody's perfect. Everybody makes mistakes, and I personally don't like to be wrong. And I also don't like it when other people are making bold statements and are wrong. It makes them look like a fool. Use questions instead. The nice thing about asking a question that you also allow the other person to explain why they make a certain decision and or come to the same conclusion that you might want to give them themselves. Instead, you chose the wrong framework. Why did we choose Y? I understood X is more actively maintained. This is so much more friendly and so much more likely to get a positive response rather than a defensive response. And this, again, also improves the reason that people will listen to your the likeliness that people will listen to your suggestions. Another thing is to stay away from vague comments. Can you improve this? I don't like this. I don't like it. Can we do this different? It's vague. It only adds vagueness, and it can be interpreted in multiple ways. Try to stay away from these words like this or it. And it's a small effort to just write down what you meant, and it reduces the chances of miscommunication, which again reduces time wasted on figuring out what is meant as well. And the best way to do this, what I usually do, and this also goes further than just pull requests, always reread whatever email, Slack message, Teams message, or command you've written, whether there are not multiple interpretations possible. Because miscommunication is really a source of possible bugs and issues. Always try, and also when you say you don't like something, try to provide an alternative solution as well. Don't be like, I don't like it. Try to think along with the person rather than just telling them it's wrong. That's also, again, much more cooperative. Another good feature, the use of suggestions. Most VCS tools have this. For GitLab, it's the second button where you can immediately already propose a change, and that person can then use a button to immediately apply that change. And this has two advantages. The first one is that the person who has to make the changes doesn't have to go in the code, figure out where it is, make the change. And the reviewer doesn't have to go look at the pull request again and see whether the change was done correctly. So you save time on two sides, which is very useful. There's one caveat, though, that you don't want to. You should at least make sure that if somebody suggests to rename a variable, there will always also be usages. And this is, of course, not a smart refactoring, which means that you might want to point out, oh, don't forget to rename its usages. Now, I was at a conference recently, and there was somebody named Wojtek who also mentioned something called conventional commands, which there's commits, but there's also commands. And it helps to structure pull request commands. And what I specifically like about this is indicating whether a command you made is important or whether it's just a very minor style issue, which, I mean, it's okay if it's not implemented, because it helps the reviewer again. Okay, I don't need to have a discussion about this. Okay, it's a nitpick, sure, whatever, versus, oh, this is blocking, I really need to fix this. And the nice thing about this is, again, consistency, which is always great. Besides that, pull requests are not happy. Are not always very happy. You're always telling about things that went wrong. It's important to also tell what went right. Try to find something positive. And that can be anything. Maybe you're happy about the feature they implemented. Maybe the pull request is nice and concise. Maybe you learned about a new API call, or maybe you learned a new way to write things. Maybe you're just happy that somebody did something that you really didn't want to do. And then anything more than just looks good to me was really helpful here. Show some appreciation, because in the end, first it adds a layer of friendliness, which also means people are more likely to listen to all the other things you suggested. And what's also really important, it really boosts their confidence, people's confidence, especially in a time where you see a lot of imposter syndrome and people being uncertain. It really helps them to get, again, more confidence, which helps you on the long way as well. So having covered pull requests, there's one more thing that I want to cover, which is bike shedding. And I'll be quick because I see I'm running a bit close on time. Bike shedding, also known as the law of triviality, is about the fact that people give a disproportionate amount of time on trivial issues. The story comes from a bike shed or a company board meeting where they spend more time discussing the bike shed of the company rather than the power plant project that they should be discussing. Because it's easier to discuss something that you know will affect you, which are things like, hey, is equals an empty string or is empty, which are exactly the same, they do the same, and it just, in the end, it doesn't really matter which you choose, as long as you're consistent. And all these commands add a lot of noise. So one of the things to reduce this noise is to automate parts of this. For example, through enforcing formatting. Now I learned that actually, so that I must admit, in .NET or in C Sharp, the editor and the Roslyn compiler and everything around it already have so much in there that help you write proper code and write consistent code. That was really impressive. So I had a lot less tools to add here. Try to stay as close to industry standards and enforce it. I learned that you can do it with editor config and something like .NET format. Add this to the build as well and make sure that it fails when it's not formatted, just so that everybody, the code is always formatted. Then you also don't need to spend time on this during reviews, which again saves time in the long run. The other one that I briefly wanted to mention is Arch Unit. This is both for Java and .NET available, and it allows you to test your architecture. So in .NET, it looks a bit like this, where you can define packages. So say there's the namespace service and there's the namespace controller. And typically you always say you cannot talk from the service to the web. It's always from web to service. It's an architecture. And you can enforce this in a unit. That's by saying, hey, any types that are defined in the service layer should not depend on any types that are defined in the web layer. And this way you can sort of create more consistently, which saves time in reviews again, because you don't have to pay attention to this. Same for naming conventions. Again, the nice thing in .NET is quite widely the convention to start with an I, whereas in Java, you have 4 more ways to define interfaces, and every company uses a different one. If you only have one, then there's no room for discussion. So whenever you start introducing these tools, it still is good to involve the team. Add some example pull requests to discuss the rule sets and things you like or not, so that everybody's on board. And then to sort of conclude, I think it's important to write descriptive pull requests and also to review them yourself to catch already the first mistakes. Be specific in your communication, but also be friendly. Try to find the positive things. Show your gratitude. Show your appreciation to the people around you. Then use the features of your editor and your VCS to help you review. Don't forget to check the code coverage and check if the tests are also properly reviewed. And then at the end, stop bike shedding, stop having petty discussions about tiny things, automate it away. If you can, automate it, then you cannot have the discussion. And that's it. Thanks a lot. Some useful links here still, if you need any. I'm thinking Simon would join me at this point.
That's right. I'm gonna join you. That was a great session, Paco. I think the best part about your session was that it just wasn't technical, but you would also talk about some of the ethics, like be thankful. This is how you should give the feedbacks, right? These kind of things I wasn't expecting in the session, so I really loved it. And I think everyone, since we live in the world of open source, right? Anyone who wants to contribute into the open source, or maybe to look into the project, your session is one-stop session. I say these 40 minutes, everyone should watch and learn on how they can contribute on these projects. I really loved it. You covered so many these tools and all. You can use it, the readme md, and how you can do the pull requests, templates, and all. I really loved it, and I think there was so much to take away from your session, plus all those hilarious um, those arts that you had in your session. So we have few sessions questions that there.
Yeah, thanks a
from
lot
your
for the nice words, by the way, kind words.
And I really loved it. I was just sitting back and I was like, yeah, this session is more for like Gen Z, millennials, kind of the new kind of developers, right?
But we work a lot of people work remotely, and then it's
Yeah.
really important to keep the team vibe up and keep people a bit happy, because you get a nasty work environment, and that's not good for the team. It's not good for the people. Keep it
Yeah.
positive. It's
Yeah,
so
that's
easy.
right. Yeah, that's
Smile.
so well said, and I could really connect from one of your slide that said vague feedbacks. That is so common in the GitHub repository. People saying this needs improvement. A pure vague feedback. There's no details about what could be done and what's missing and anything like that. So I think that happens a lot in the repository. I've seen it these days. But yeah, great. Let's take a few questions
Yes.
from the comments. Someone says. I agree. It seems like some of our team does all its fixes when you show that number in your first slide. That was hilarious. Gaurav Kumar is saying, what metrics or indicators do you track to ensure that code review process is contributing positively to overall quality of the code base?
That's an interesting question, and I think it's also a
Mhm.
good question to ask actually when you start doing code reviews.
Yeah.
I don't think I don't have a metric. You could argue whether one of the metrics could be, if you want to measure it, you could say I'm gonna run some tool or analysis tool on whatever defines quality in a measure before and after the pull request comments have been processed. But
Hmm.
other than that, I think I don't have a straight answer for this one right now. Other than that, and that's maybe the worst answer is just do
Yeah.
it. Uh,
Yeah. Just do it
but
if
it
it
is
works
how
for
it
you.
is.
If it works for you, right? If it doesn't work, try
It really
something else.
depends on the team, really, because
Yeah.
some teams don't do pull requests or don't do code reviews, and that's fine if that works for them. But if it then turns out in the long run that it's not, then yeah.
Perfect. When you had that Java slide up, right? Drew, who's one of the speakers, he says, "No apologies, polygons welcome."
Thank you. Yeah, I
So
must say I
hilarious.
had quite a hard time. I work on a MacBook, for example, and I was trying to
Uh-huh.
find my way in .NET. With Visual Studio, that wasn't the easiest thing, and I had some libraries that I wanted to open, and there were DLLs there. So,
Yeah,
but
yeah.
I talked to some .NET developers. They helped me. It was
It's painful sometimes. Yeah. So there's another question from Atul. He's asking, how do you balance providing constructive feedback without coming across as overly critical or passive aggressive, especially in remote or distributed team setting? I think you did cover briefly in your presentation about this.
yeah. So try to also balance it with positive parts, and
Hmm.
you cannot do it all. And also here, I would say try to balance it out a bit. If there is
Yeah.
100 things that are wrong, you could also argue whether are those last 30 things, whether they use the right capitalization on a field that is not exposed to the outside world. Maybe leave those 30 commands for a next iteration. Don't go
Yeah.
all out. And passive aggressive is, of course, uh, not what a professional should do, even though I would definitely understand that you get frustrated at some point.
Yeah,
People
exactly.
talk to each other anyway.
Yeah.
If you, yeah, sorry,
Yeah,
one
go
more.
ahead. Go ahead.
What could really help if you had a lot of commands on this pull request, maybe more than you would have liked, to also have a chat with that person right after and to go over the commands with them, just so that you can explain and they can add some friendliness.
Yeah, that's right. Sometimes I see that all these open source projects, we feel like, okay, this is some of the feedback you would like to give. Many open source projects have very clearly mentioned on their project that this is what our timeline looks like. This is what we are going to build, right? So if you just spend a moment looking at that tab and see what they're building now, what they will be building next. So perhaps the feedback that you're giving, right, it is there in their pipeline. So you could also go ahead and check that, and very nicely said by you, Paiko. The Deepak says, really nice session here. I think community
Thank you.
really loves it. Bhaskar says, should we use any automated tool? I think the answer is yes, looking from your last slide. How do you ensure that automated tools complement the code review process without overwhelming developers with too many suggestions or alert? I
Yeah,
think
so
this, yeah.
that is a good one.
Mm.
And just like when you start introducing a very opinionated formatter, or let's take the example, you move from company A to company B and they have a different code style. You'll be
Yeah.
frustrated because you liked the previous code style, and then after a month, you'll be frustrated at the next team's code style because you're used to this one now. And I think it's important to realize that people, in the end, have to bite the bullet and get used to it. So when introducing new tools, there will be some learning curve. So whenever you introduce a tool that actually has quite some suggestions, first of all, I would suggest to make sure that when introducing this, you have a good baseline. So not just edit and now the next person has 200 things they have to fix, rather fix those 200 things while introducing it. And then from here on, try to do it. And yes, if there are too many suggestions or alerts, invest time on fine-tuning them. If you as a team don't find half of the suggestions that you get relevant, remove them. Because then people are more likely to actually look at them. It's the same thing with Sonar. If you don't configure Sonar properly, you will get so much feedback that people don't really look at it anymore, because half of them is, I don't care about it.
Yeah, that's very right. That usually happens, right? Too many feedbacks can really be overwhelming.
Yes.
So yeah, I get that. Peko, I think that was an absolutely great session, right? I really loved it. I'm asking this question to every speaker, so I'm going to ask this one final question to you. That other than all this technical stuff, this great presentation, what do you do? What are some of your hobbies? You play guitar, you dance, you love beer. What is it?
Sorry?
What are some of your hobbies other than all the tech stuff that you do?
I like to go out for a run a lot. I mean, I moved to Switzerland a year. I like nature, and I am really in a nice place for that. So I'm really enjoying the outdoors, both in the winter, skiing, and in the summer, swimming.
All right. So I think it's evening time at your place. I won't take much of your time, Paco. Thank you so much for accepting the invitation. I really loved hosting you. I think it's our first time. I hope we get back to connect once again. And yeah, have a nice evening and hope to see you soon.
So yeah, thanks a lot, and have a nice evening day.
You too. All right, everyone. So that was Paco for you with all those great suggestions and tips and tricks that you can go ahead and use in any of your other projects that you're building. We now move to our next session. I know we're only 1 minute in, so I won't take any more time. But I encourage everyone. I think we have reached more than 500 people are watching now. Before this session was about 450. It's 525 now. Please go ahead and drop your question in the comments. And while you do it, use the hashtag CodeQualityConf. And towards the end of the session, we're going to do a raffle and do the giveaways. Okay, we now move to our next session. Adam Thornhill. He is the founder and CTO of CodeSense, and today he's going to talk about code quality advantages, how imperial data shatters the speed and quality myth. Quite an interesting session title, isn't it? So without any further ado, let's bring Adam to the conference. Hi, Adam. Welcome to the Code Quality Conference.
Hello. Really good to be here, and thanks for the nice intro video.
I'm glad you liked it. My team member Rohit has done a really good job, really stalking you on the social medias and getting those pictures. So Adam, first thing, thanks for accepting the invitation. I really appreciate it. I know you're a very busy person, so I won't take much of your time. Please feel free to go ahead and share your screen. I'll then add it to the stream, and then you can get started.
Sure. So let me share the screen and let me know when you can see my slides, and then I take it from there.
Jen, I see your slides, and yeah, we're not able to stream on LinkedIn now. There has been a problem with LinkedIn since the morning. The comments were not coming in, and now there's a problem with LinkedIn. You can see the notification actually up there, but we're streaming on Twitter, Facebook, Twitch, and YouTube. Adam, I see your stream. I see your slides. Everybody else can see your slides. And next 45 minutes is all yours.
Thank you very much. And welcome everyone to this session on the code quality advantage. So the reason I want to do this session is because I've been spending 30 years in the software industry, been writing a lot of code, worked with lots of different companies and stakeholders. And one common theme that I noticed is that people during these 30 years have been telling me, no, we don't have time to refactor. No, we don't have time to automate tests. No, we don't have time to rethink our architecture. So we have this misconception in the industry that there is some kind of trade-off between speed and quality, right? That we need to sacrifice one to get the other. And what I want to show you today is that this is a myth. There is no such trade-off. In fact, we need both to go really, really quick. And we're going to cover a lot of ground over the next 40 minutes. And I like to approach this from the perspective of technical debt. So technical debt is something that you probably are all familiar with. You have probably heard the term before. What I think is so interesting is that technical debt has multiple root causes. We take it on for multiple reasons. And the typical case is that we try to sacrifice quality in order to move a little bit faster with a feature, right? So we cut some corners, we get a feature out in production, and everyone is happy in the short term. However, there are other reasons too that we take on technical debt. And one of the reasons might be that we actually do the right thing. We design our software properly, but then our understanding of the problem we're trying to solve changes, perhaps due to user feedback or our own experience. And this is what we typically call requirements change, right? And now our design is no longer a good fit. Or maybe, and of course, highly hypothetical in your case, maybe our design just wasn't a good fit to start with, right? No matter the root cause, the outcome is the same. We end up with code that is more expensive to maintain than it should be. And this is the definition of technical debt that I'm going to run with throughout this presentation. Now, during the past 4 to 5 years, we have learned a lot about the industry cost of bad code and technical debt in general. And there are multiple papers you can look at. I'm going to reference a few of them here. But at the end of the day, it doesn't matter which paper you read, because they have one thing in common. They all paint a pretty depressing view of our industry. Did you know that as developers, we waste somewhere between 23 to 42% of our work week dealing with the consequences of technical debt and bad code in general? 42% waste. What does that even mean? Let's do a small thought experiment together. So let's pretend that you have a company with 100 engineers. That means you need to pay the salaries for 100 people. With a 42% waste, it means you pay the salaries for 100 people, but you get the equivalent output of just 58 people. Does that sound like a good deal to you? No, of course not. It's horrible. And of course, there are other factors too. Because I like to claim that if you could actually build something with 58 people as opposed to 100, then doing it with a smaller team is always going to be more efficient. Because with a larger team, you have additional coordination costs, communication costs, and management overhead. So I actually think that the real waste from technical debt is significantly larger. I think these numbers are overly optimistic. Of course, technical debt and bad code is not only about financial impact. It's also about vulnerabilities. So another line of research has established that there is a strong correlation between software vulnerabilities and technical debt in the shape of various code smells that we're going to see throughout this presentation. So now, where does this leave us? Well, if we have something, technical debt, bad code, that has a massive financial impact, wastes 42% of our time, and causes security vulnerabilities, we would expect technical debt to be at the very top of any decision maker's agenda. Is that what's happening? Well, probably not. Because what we see in the research field is that we do a horrible job as an industry. In fact, what researchers find is that we developers are frequently forced to introduce even more technical debt because companies just keep trading code quality for short-term gains like the next big feature. Now, I've been thinking about this for a long time, for at least the past 10 years. Why do we do this trade-off? Why do we sacrifice code quality over and over again to ship features? And I think I have an idea on one of the root causes. So let me show an example to you. I didn't bring any C# code in this slide. I decided to go a little bit more old school and present a piece of C++. But it doesn't really matter, right? Because I think as C# developers, you're familiar with the structure. And I'd like to ask you a question. Looking at that code, can anyone tell me if this code is correct? Can anyone tell me what this code does? I have to admit that after all these years coding, and I even spent 10 years doing C++, I have absolutely no idea what this piece of code does, and I cannot tell if it's correct or not without spending a lot of time on it. Now, what I want to point out is that if we as developers struggle to understand code, we have to keep in mind that what you see on screen is just 19 lines of code. A modern system has hundreds of thousands, million lines of code that looks like just like that. And if we as developers struggle with understanding small pieces of code, imagine a non-technical stakeholder like a product person, a technical manager, or VP of engineering, or business manager. How should they understand if our code is good or bad, if there is technical debt, or where the waste is? Software is largely a black box to many, many people. So what I like us to do today is to see, can we shine a light into this black box? Can we shine a light on technical debt and make it relevant to the business? In order to do this, I would like us to start to visualize technical debt and code quality. And to visualize something, we need to know what to visualize. So we need to know how to measure code quality. And this has been a notoriously hard problem. There have been multiple attempts throughout the decades, and you might have heard about approaches like cyclomatic complexity, Halstead's volume metrics, and so on. And what all of these metrics have in common is that they are pretty poor predictors of complexity. In fact, there's no real correlation between what these metrics find and something that's meaningful to the business. So one thing that me and my team have been working on for the past 6 to 7 years is to see, can we develop a better proxy for code quality? And we decided to call the concept code health. So code health is both a concept and a specific software metric that you can use. And it's a metric that's based on 25 different factors. Why 25 factors? Well, the reason is simple. It's very hard to agree on what makes good code good, right? It's very hard to define quality. But it's very easy to define what bad code is. So what we did is that we simply researched and came up with a list of 25 factors that we know are indicators of bad code. So the way this works is that you have a piece of code, might be C#, might be Java or something else, and you parse that code. And then you analyze that code for these different code smells. And I'm not going to show you the full list of the 25 factors. You're free to check it out via the links, but I'm going to show you the most important ones. So at the top level, we look for module level smells. So these are like class design issues. And to give you a typical example of a class design issue or code smell at that level, that's low cohesion. So you might be familiar with low cohesion. It basically means that you have stuffed too many business responsibilities into the same class. So now this class has many, many reasons to change. And this is problematic because as a developer trying to understand that code, I now need to understand all these different business rules in order to make sense of the code. It also opens up the risk for things like unexpected feature interactions, which are some of the worst bugs you can have. You know, you tweak some code over here and a completely unrelated feature breaks. That's usually caused by low cohesion. So low cohesion is a very serious smell. It obviously doesn't mean that we cannot make it even worse, because what we can do is we can take a class with low cohesion and let it grow really, really large and let it include at least a brain method. I'm going to talk about that soon. What we have done now is that we created a brain class. So that's another module level smell. And brain methods are a function level smell. It's something you might also know under its alias, GUD functions. What brain methods and GUD functions are simply large functions. They're always large. And they tend to contain a lot of logic. And the reason they contain a lot of logic is because, again, they do too many things. They're, again, low on cohesion. So what this means to me as a developer is that the moment I want to modify anything inside this particular area of the code, I end up in the brain method. And each time I work on it, it becomes more and more complicated. So brain methods is a pretty severe code smell. Then finally, at the implementation level, we look for various complexity patterns. And To mention a pattern with really high predictive power, I like to point out deep nested logic. So deep nested logic is something all of you have seen. It's when you have an if statement inside an if statement inside an if statement, and maybe a loop for good measure. The reason that code is problematic is because there is some very good research that shows that roughly 20% of all programming mistakes are due to things like deep nested logic. And once we know about this, it's pretty easy to avoid, right? So these are just some high-level examples on the 25 factors that you look for in code health. So you basically look for the presence of any of these factors in the code. And then we have algorithms that can score, aggregate, and categorize every single piece of code as being in one of 3 categories. The code can either be green, that's healthy code with low risk. That's where you want to be with the majority of your source code. And then you have the next category, yellow code. That's problematic code, where you have started to take on technical debt. And unless you're really careful, you might end up in the red category, which is unhealthy code. That's the type of code you never, ever want to work with, right? That's what typically called spaghetti code. It's code that's really hard to understand and very fragile, as we will soon see. So now that we know how we can use code health as a proxy for code quality, we can start to visualize code quality in large code bases. And I want to show how this can look on a real code base. So what you see on screen here is a code quality visualization of Ethereum. And there's really nothing special about Ethereum. It's just a good example of a mid-sized code base. And Ethereum, for those of you who might not know it, is an open source blockchain implementation. The interesting thing with this visualization is that it's based on code written in 50 different Git repositories. So it's a multi-repo project. And you see that each one of these circles with a name, the ones I'm hovering over right now, they correspond to code in a specific Git repository. If this was a monorepo, then the top-level circles would correspond to the top-level folders in your repositories. We're going to see some examples on that soon as well. Anyway, by using this visualization, I can quickly zoom in on the area I'm interested in, typical an area where I do a lot of work or I might have an additional technical responsibility. So let's zoom in on research here. So when I zoom in on research, what I see is that it's a hierarchical structure. So we have the various subfolders inside that part of the code. And once I get to the lowest level of detail, I see that each file with source code is visualized as a circle. And you also see that these circles, they have different size. Some are big, some are much smaller. So the size of a circle just reflects the number of lines of code in that class. The important, that's just to know how big a potential problem is, right? The interesting thing here is the color, which indicates the code health. So we see that on the top, we have one big red blob with red problematic code, and below it, we have 2 healthy pieces of code. So this makes it really, really easy to pinpoint the unhealthy problematic parts of your code. Now, I'm going to come back to what that means, but before I do that, I want to show you a few additional examples, because I'm a big, big, big fan of visualizations. Because visualizations, they kind of tap into this amazing power detector that we carry around in our head, our visual brain, right? So by visualizing code, we can, within a few seconds, we can start to draw conclusions and compare various code bases. And I want to show you an example. So to the left here, let's start with that one. That's a visualization of the code quality in React from Facebook. And React is a UI library that's super popular these days. Most of you are probably using it in one capacity or another. And when I look at React, I immediately see that the React reconciler, the part of the code that I've highlighted, seems to have some code quality problems. There's lots of yellow and red code inside it. So if this is a code base that I'm responsible for, then this is super important info to me, because as we will soon see, red and yellow code is going to constrain what we can do with the code base and its roadmap going forward. However, I can contrast React to the code base on the right. And this is a Microsoft code base. This is Core CLR. This is the runtime that you all use for .NET. And what's interesting with the Core CLR is that it's a massive, massive code base. What you see on screen is more than 8.5 million lines of code. So the reason I like this case study is because it kind of indicates that this visualization approach scales really well to large systems. So what can we say about the code quality? Well, we can immediately see that, all the automated tests in the bottom left corner seem to be very healthy, right, with very few exceptions. But in the actual application code, we seem to have some really complicated pieces of code. You see this band of red code, right? It's like a Petri dish gone mad almost, right? And the question is, of course, what do I do with this information? How do I act upon this? And that's something I want to cover towards the end of the session. But before we do that, we need to connect this to some kind of business objective. Because if we use a code quality score and we don't connect it to something that's meaningful to the business, then code quality is always going to be a second priority, right? To really, really make it the business advantage it deserves to be, we need to be able to explain gains in code quality to business people. So 2 years ago, me and my research colleague, Dr. Marcus Borg, we set out to try to quantify the business impact of code quality. And we choose to do this on proprietary code bases because we wanted to make sure that this is data that's representative of what businesses work with. And we did this by connecting to 39 companies that wanted to participate in the study. Each one of them had many, many different code products and code bases. These were large enterprises. And we made sure to include companies from many different industry segments because we wanted to make sure that whatever we find is general to the software industry as a whole. It's not something that's specific to one domain or one type of business. And for the same reason, we also made sure to include code in many different programming languages because we wanted to make sure that whatever we find is something that applies no matter what programming language you use. Because products today are typically built in a polyglot fashion, right? So we had code written in CSharp, of course, Java, C++, JavaScript, Python, and so on. And what I want to say before I show you the findings is that everything I'm going to show you is statistically significant, meaning that it's very unlikely that our results are due to a fluke. There's probably a real effect behind it. And to guarantee that, we had our data published and peer-reviewed and presented at academic conferences. So what did we find? Is code quality important to a business? Well, let's see. I'm going to talk a bit about how we collected the data first. So the first thing we did was to measure the time in development. And we wanted to compare that across the code of categories. So how do we know the time in development? Well, code quality is easy. We simply asked the companies that participated to run the tooling, which gave us a code health score for every single file in their code bases, right? So we had a massive table with that. But time in development is more tricky. What we didn't want to do was to force developers to self-report via some time spent field in Jira or something like that, because if they would do that, two things would happen. First, they would hate us for having them do that, and that we didn't want. Second, it would be inaccurate because they would basically just, at the end of the week, we put in whatever we think in those fields. So we decided to automate it. So we connected to tools like Azure DevOps and Jira and fetched information about the tickets when they started to work on them, when they were completed, and then we connected that to version control data. So we can trace it down, the time spent at the file level. So we basically calculated the cycle time for implementing features or fixing bug at the file level. So we now had a massive table with a known code health score and a known time in development. And that's what made it possible to calculate these statistics. So what do they tell us? Well, they tell us that if I have green code, I can move more than twice as quick compared to someone that has red code. Is this important to a business? Well, let's say that my company would have red code. And let's say that we need to implement a new capability, and it takes us 2.5 months to do that. A competitor with green code can get the same thing in less than a month. It's going to be impossible to keep up. So green code is very clearly a productivity benefit to a business. You can get more things done than your competitors with poorer code health. However, What we also noticed in that study, we are well aware that averages can be a little bit misleading and the actual impact might be even larger. So to study that, we decided to look at the variation in task completion times. And what we found here was very dramatic. What we found was that the maximum time to implementing a ticket, be it a new feature or a bug fix, could vary up to 9 times longer, 10 times longer for red code compared to green code. Because when we look at the actual numbers behind this, we see that the maximum time it takes to implement a ticket in green code is very, very close to the average. And that simply means that green code is predictable, right? It takes roughly the same time each time I work on it. There are no nasty surprises in the code. Whereas I can see that for red code, that relationship no longer holds true, right? It can take 9 times longer. Is this relevant to a business? I would like to think so, because what this represents is uncertainty. And if there's one thing I've learned through all these years in software, it's that uncertainty is something that no one is comfortable with. So imagine you're a business manager promising something to key stakeholders, maybe the company owners, maybe to the board, or maybe even to a customer, that, yeah, we are building this feature now, we're going to launch it in 1 month. If they have red code, they can make no such promises, because as we've seen the data, it can equally well take 9 or 10 months, and they're going to look really, really bad. Also, if I put on my developer hat, I'm also not a big fan of uncertainty, because uncertainty is what's keeping me up late due to deadlines, missed deadlines, overtime, and stress. So red code is disastrous on so many levels. Finally, what we also did in this study was that we had, as we had access to Azure DevOps and Jira data, we could also figure out if the code was modified due to a new feature, some rework, or due to a bug fix. And that made it possible to calculate defect densities. So what do you think? How do you think defects differ across green, yellow, and red code? Well, let's have a look. And this is quite dramatic, isn't it? It turns out that red code has on average 15 times more defects than green code. So let me ask the obvious question. Is this relevant to a business? I definitely think so, because if we, having red code, would ship 15 times as many defects as someone having green code, then that would definitely impact the customer satisfaction and the product maturity experience. And for us as developers, red code is extremely stressful, because all these defects that we ship into production, they are going to come back in the shape of unplanned work where we have to context switch, right? So red code is really, really dangerous. Now, if we have this data and visualizations like this, how can we use them in our daily work? Well, let me share the things I have seen work really, really well and the things that I tend to do with this data. The first thing that I think is super useful is that if we have a visualization like this, we can use it to create situational awareness in our organization. And what I mean by that is that we can make sure that all stakeholders, be it engineers, developers, or product people, or managers, we can share the same understanding, the same view of where the strong and weak parts are in a code base. And that's a really, really good foundation, because it helps us fight risk, right? Because let's take an example here. Let's say that the code base here to the right that I visualized, let's say that it's our code base, right? So maybe we sit down in a sprint planning meeting. Our product owner is attending. And our product owner tells us that she has planned 5 major features in the React reconciler part. Now, given what we know about red and yellow code, we know that this is a massive risk. There's a large risk that we're going to need much more time than we planned for, and that we are going to deliver with poor quality, many defects. So using this data, we can have a conversation. Would it make sense to first refactor the code so that we can safely implement all these features? And that brings me to the last use case, my personal favorite. And perhaps what I like the most about this type of data is that it makes it possible to finally build a business case for improvements and large-scale refactorings, because these can now come with a business expectation. So based on the data, we can we can give guarantees that if we have code like in the React reconciler, if we take that red code, refactor it and make it healthy, then everything that we have planned in the roadmap for that particular component, we can now say that on average, we're going to be twice as quick with implementing those features. And we're going to significantly reduce the risk. We're going to have 15 times fewer defects on average. And that's a very, very quantifiable win. Now, I still have a couple of minutes before taking questions. So I wanted to take on one more related challenge. How do we prioritize remediations to large amounts of red code? So let's travel back to core CLR as an example. 8.5 million lines of code in total. If we just sum up the red code, we probably end up with 2.5 million lines of code. How long would it take us to refactor 2.5 million lines of code? 5 years? 10 years? I don't know, but it's very clear that we would be long out of business before we even get there, right? Because as a business, we always need to balance improvements to existing code versus adding new features, right? It's a continuously changing space. So how can we do this? Well, this is where our set of techniques known as behavioral code analysis can help. So for those of you who aren't familiar with behavioral code analysis, the key idea here is that in our behavioral code analysis, the code is important. It's really, really important to know if the code is healthy or not, right? So that's like the foundation. Once we have that, it's even more important to understand how we, as developers, interact with the system we're building. That's the behavioral part of it. So it's an intersection between code and people. And to do a behavioral code analysis, we obviously need some behavioral data on how we as developers work with the code. How can we possibly get such a thing? The good news are you all already have all the data you need. We might just not be used to think about it that way. What I'm referring to is version control data, Git. It turns out that Git is something we have used for years, more or less as an overly complicated backup system, occasionally maybe as a collaboration tool. But when doing so, we have built up this wonderful data source over how we, as engineers, have interacted with the code we're building. And there are many, many analyses we can do from Git. I write about lots of them in my book. But one of my favorites, particularly when it comes to technical debt, is that Git data gives us a time dimension into our code. We can basically tell the story of how the system evolved, where we worked, how frequently we worked in various parts, and what happened over time. And this is something we can use to prioritize technical debt. So instead of showing you a video recording, I wanted to do a quick demo on how it can look on a real code base. And then I'm going to wrap up the presentation and take questions after that. So let's see, it's always interesting to do a live demo. You should be able to see my web browser now. And the system I'm analyzing is React from Facebook that we looked at before. And we can easily see that there are parts of the code that are unhealthy. I see like two modules, right? There's a pattern here. So to the left, I have something called benchmarks, where there is plenty of unhealthy code. And to the right, I have the React reconciler with unhealthy code. The question is, where do I start if I want to pay down technical debt and improve? The interesting thing here is that if we look at version control data, we can visualize that using a concept called hotspots. And I'm going to explain what that is. So if I click here on hotspots, what I do now is that I go to version control and I simply calculate how many commits have we done to every single piece of code here over the past year. And what I see now is that the more red it is, the higher the development frequency, right? The more commits we have done in that part of the code, the more relevant the code is. And what I see now might be surprising. I see that this benchmarks package, where I had this red code, is very stable. We haven't worked on it for years. So starting to fix some code down there won't have any big payoff, right? However, I see that there's a lot of development activity in the React reconciler. So I would definitely zoom in here and see if these hotspots are unhealthy. So let me click on a hotspot, and I immediately see that this is indeed unhealthy code. So what I have identified now is code that lacks in quality, poor quality code, that is also worked on all the time. And that's like the definition of technical debt with a high interest rate. So I want to show you how behavioral code analysis techniques like a hotspot can help you separate the technical debt that you have to fix from the technical debt you can live with. And I want to clarify that with a slide because it's so important. So technical debt has two components. One is the actual loan you have taken on. And this is something you can measure by code quality, right? Red or green code. But the other is the interest. And if we look at this visualization, I have a slightly different view of this code base. So on the x-axis, you have each file with source code, and they are sorted according to the change frequency. That is how many commits have I done to each piece of code. That's what I see on the y-axis. And if I look at this visualization, I see that it forms a power law shape. And this is something I've seen in every single code base I've ever analyzed. And I probably analyzed 300-400 code bases by now. So this seems to be the way software evolves. And this is important to us. And it's actually good news. Because what this means is that most of our code is going to be in the long tail. So this is code that's rarely, if ever, touched. And if we have some yellow or red code down there, then that's technical debt. We want to be aware of it, but we can probably live with it because the interest is so low. On the other hand, we see that most development activity is at the head of this power law curve. So that means that in a hotspot, we cannot afford any technical debt at all. That's the code we really, really need to keep green, because if we fail to do so, the cost of that technical debt are going to explode due to the high development frequency of the code, right? It's a very high interest on that technical debt. And what I see in our research is that the hotspots tend to make up a very small part of the code base, maybe just 2, 3, 4%, but attract an unproportionally large part of the development activity. So starting to pay down technical debt in a hotspot is likely to give you a very big short-term benefit as well. And with that, I've come to the end of my presentation. What I want to show you today is that to really make code quality a competitive advantage, you need to have two different dimensions. One is the quality dimension that you can measure with code health, where you see if the code is good or bad. And the other is the relevance dimension that you can measure with hotspots. So that is how you know the impact and priorities of any code quality findings. And I started out saying that there seems to be this conception in the industry that there is a trade-off between speed and quality. But what we see in our research, in our data, is that the opposite seems to be true. And I like to think that with 15 times fewer defects, twice the development speed, and 9 times lower uncertainty and completion times for tasks, the business advantage of code quality should be really, really clear. And if you want to know more about this, then I have a number of resources for you here. The links will take you to a white paper that summarizes the key code health findings that I talked about, the business impact. There's also an actual research paper behind it. So if you want to go into all the details and figure out that, hey, how did they measure this, or how did they control for this bias, then the research paper is your friend. And to do the actual research and to visualize it, I'm using the CodeSyn tool where I work. So if you're interested in trying this out on your own code base, then I highly encourage you to give it a shot. I think you will find it interesting to see what your code looks like. And you can go to codesyn.com and just test it out for free. And finally, if you want to dive deeper into behavioral code analysis, then you could probably do worse than reading the second edition of Your Code is Crime Scene. It's a brand new second edition that goes into code quality, hotspots, and many, many other things around successful software. With that said, I'd like to thank you a lot for listening to me, and I'm very much looking forward to the questions. So thank you very much.
Thank you so much, Adam. That was really great. And if I look at the current slides that you have, your code as a crime that you said, that is
Your
so
code
that
as
is
a crime scene.
as a crime scene. That is so interesting. You know, I've never seen a book with that title, and I really loved your session. I think there was a lot of research that you put in, right? With especially the one that you showed with the Ethereum repository and React. I really liked it, and I see it in the comments. Let's take a few questions, right? Let's take
Yep.
one with the Bhaskar. He's asking, how do you ensure that the data you collect on code quality is accurate and relevant to the business context?
So how do we do that? Well,
Yeah.
we do this by, first of all, we when we do this analysis, we only include code that's under active development, and this is pretty easy because we have access to the Git data. So we
Okay.
exclude all stable code because we cannot really tell anything about it. But the code that's being actively developed, the way we ensure that it's relevant to the business context is because otherwise you wouldn't spend time developing it, right? So it's almost like a circular thing. And what we then do is that we establish these two objectives that we think it's a business advantage to be able to implement things faster with higher quality. So these are like the two indicators we are looking for. And that's how we develop the code quality metric to ensure it has this predictive power that if you invest in code quality, improving code, then you should be able to develop things faster and reduce the defects. So I hope I managed to clarify that. And the research paper has a lot of detail around this.
Yeah, and I also liked your last slide. It has a lot to take away, all the resources that is shared in the last slide. I would encourage everyone to go back to that frame and take a screenshot of that video frame and go to that links. Atul says, nice session. Thanks for joining in, Atul. Oh, Bhaskar was very quick to reply. Wow, you explained well, Adam. So yeah, your answer did help him. Uh, so there's another question coming from Gaurav. He's asking, how do you link code quality metrics to key business drivers such as customer retention, revenue growth, and market competitiveness?
So the short answer is I don't. I simply don't because I mean, what we do in our research is that we're on a long journey, and we want to continue to kind of learn as much as we can on how code quality impacts our business. That said, I think there are some obvious possible links to at least customer retention and market competitiveness. There are many other factors too, right? It doesn't matter if we build a perfect product if it's the wrong product, right? So there are so many other factors that are important. But customer retention, for example, it's very clear that if we ship 15 times as many defects as we should, it's very clear that that's going to impact retention. It's going to be super frustrating for users, right?
Yeah. That's well answered. Yeah. I mean, if you're shipping 15 times, there's definitely something wrong you're doing. Okay, that's it. Let's see. We have another question coming up from the community. It is, how do you effectively quantify code quality in a way that resonates with non-technical stakeholders? Are they even involved? They are, right?
I think they need to be. I actually think, and this might be controversial, but I think that we as technical people, we have a responsibility. We have a responsibility to make code quality relevant to non-technical stakeholders because they want to understand, right? So this is why I'm such a fan of the visualizations, because they tend to be very accessible. And I've been sitting down with CEOs that have never seen a line of code in their whole life. And I've been sitting down with these maps and I have walked them through their technical depth and tried to explain what it means to them. So what I do is I typically oversimplify a bit. So I never go into the specific code smells. That's for us as engineers. What I try to explain very clearly are the 3 different categories. So that's what I lead with. And what I do is I start from the research paper and I show them that, if you have a green code, you can be twice as quick as someone that has red code. So I kind of explain these different categories and the impact. And then I show them the map. And now it suddenly means something to them. Because quite often they are able to, with our help, map a particular directory or subsystem to some kind of business area. And to give you one example, one of my most interesting conversations was with the CEO of a large company. And after sitting down and walking through doing this exercise, the CEO said to me that, now I know why my CTO quit. That's of course sad, but on the other hand, it's also kind of a proof to how powerful these techniques can be when we use them to coordinate and communicate with non-technical stakeholders.
A very good answer, Adam. Very good answer. I mean, yeah, the non-technical people should be involved in code quality, and really like your idea on not telling them actually, but visualizing it, right? Hey, this is how the code should work, but this is how it is. The red map, green map, I really like that idea. When people see things, they can relate it to more. You cannot go and explain them the code, but I like your idea on making things more visual so that people can understand it. So thanks for that answer. I am sure the person who has asked will be very happy with this. Gaurav says thanks for your answering. Thanks for answering that question. Adam, I think that was a great session. I'm really going to go back and suggest some of my friends to go and rewatch your session. We're going to break it down the entire conference to each session. I'm going to send it the recording to you so that you can also share it with your connection. Anything else, Adam, you want to add before we move to the next session?
No, I just want to thank you for putting together a great conference
Mhm.
like this, and it's an honor to be invited here. And I hope that you all get at least one new thing out of this talk. Then I'm
Oh,
happy.
definitely. Oh, yeah. We could take away so much from there. Thank you so much, Adam. Have a nice evening or day where you're joining, and hope to see you soon.
Thank you. Take care.
Thank you so
Bye.
much. Bye bye. All right, that was Adam for you. So much to take away from one session. So much research. I think every session is very unique, and this session had so much research in it, and every slide had numbers, statistics, those graphs. Really different session, and I really personally loved it. We now move to our next session, and that tells me that we are almost halfway down this code quality conference. For some of you don't know, we are streaming this conference for 10 hours, and I think more than 10 hours. And thanks to the C Sharp Corner community who's organizing this event. And thanks to C Sharp TV for bringing this all together. We also have a sponsor, Sharp Token, and all that. We're going to talk about it later in this conference. But we now move to our next session. Actually, we now move uh, to Nigeria. We have a friend joining us, David. David is joining us for the very first time. I'm so excited. I've never hosted him. David is a group program manager, a business system and solution architect and engineering. Definitely a big deal guy. And what is he going to talk about? He's going to talk about best practices of writing clean code and maintainable code. And I think this session is for everyone. At least I write bad codes and it's unmaintainable. So I should be sitting back and watching this session. Everyone, let's welcome David to the Code Quality Conference. Hi, David. Welcome to the Code Quality Conference.
Hi, Simon. I'm glad to be here. Thank you so much for having me.
Oh, David, David, you're joining from Nigeria. What time is it there?
It's 16:28.
16:28. So,
yeah.
Are you at work?
Yes, I am actually. I'm actually working. I have to step away from work to get to speak to the people.
So thanks, David, for doing this for us. I'm really excited and looking forward to your session. I know you already prepared. You've shared your screen. I'm going to add it to the stream now. Everybody else can say it. And next 45 minutes is all yours.
All right. Thank you. So glad to be here, everyone. My name is David, and I'm from Nigeria. And I'm going to be talking or speaking to this community about best practices for writing clean and maintainable codes. All right. So a quick overview of the presentation. First, I would be looking at the importance of clean and maintainable code, and then followed by definition of what code smell is and listing of common code smells or issues, as it were, and then the next item would be refactoring or looking at refactoring concept and techniques to fixing code smells. Next by that, I will quickly touch on team culture and influence on practices that could aid clean and maintainable code. And finally, key principles. I'll be looking at key principles for writing clean and maintainable code to help developers across the world to improve or deliver or write clean and maintainable code. All right, quick one. So why are clean and maintainable codes crucial? First, and just basically, I'd like to deep dive into the key nuggets. Then the first thing is that clean and maintainable codes are crucial because it makes debugging and enhancement of codes very, very easy. I mean, easier to read, easy to understand, making it simpler to identify and fix bugs. Also, in that same line, it also helps reduce the time and effort required to debug and enhance codes. And secondly, it's quicker. I mean, it aids faster development cycles or makes development cycles very fast. It also makes or contributes to faster resolution of issues. Typically, you run into bugs and you imagine that someone else needs to join in reviewing that code in order to quickly fix the bugs. The issues, a clean and maintainable code is a sure foundation to ensuring that bugs or issues are easy to resolve and fast to resolve. Thirdly, it improves team collaboration. By team collaboration, I mean it helps teams to easily understand each other's work. And also, as a result of that, it facilitates contribution or insight. It also enables more effective peer programming and code reviews. Fourth item is it contributes to scalability and adaptability, meaning that it makes it easier to scale and adapt to new requirements as fast as possible. And the last one that I like to touch on regarding the importance of clean and maintainable code is that clean and maintainable codes adds the code quality and reliability, which is one of the essence or reason why we are here. Okay, so what is code smell? Code smells are indicators of potential problems in the code that, say for instance, while not necessarily bugs in and of themselves, but they suggest deeper issues that could hinder readability, maintainability, scalability, and some of those benefits or importance that I shared earlier on in the previous slide. And so basically, they are not necessarily bugs, but they could hinder readability, maintainability, and scalability of software. So code smell. Some of the code smells or common code smells, for instance, comment, that is, too much comment may indicate that the code in itself is not quite clear enough, which typically leads to, say, for example, having to, excessively hard comment in order to help whoever is going to read or rewrite or refactor at a later time, or even improving by the same person to understand what has been written. Secondly, code smells or common type of code smell. The next one is duplicated code. This is identical or very similar code that exists in more than one place within a code base. The problem with this is that it increases maintenance effort because changes needed oftentimes needs to be made to multiple places where the codes have been duplicated. The third common code smell is long method, meaning methods that are excessively long and they try to do too much at once or packed together. The problem with this long method is that it's harder to understand and it's harder to maintain and also test. The fourth item or the fourth common code smell is large class, right? You have too many responsibilities and contains too much code in the class. And this, I mean, as written here, the problem is that this violates the single responsibility principle, making the class harder to manage. The fifth common code smell here is refused request. That is a subclass that doesn't use all of the inherited methods and properties. And the problem with this is that, for instance, or the way you could identify this is that it's possibly going to indicate a possible incorrect inheritance relationship type. There are some other code smells or type or common code smells. Others are, for instance, divergent change, shotgun surgery, speculative generality, and so on. You could potentially, look some of these other ones up to gain more insight into them. Next is identifying and analyzing code smells. So, for example, in order to basically understand or identify code smells in a code base, one of the things that you could potentially use, because it could be quite challenging, as you may have seen in the previous slide, it could be quite challenging to spot. And so the way to, or one easy way to particularly approach this would be to use automated tools, for example, static code analyzers, and some other tools like that that could help identify common code smells. Some of these tools are like, for instance, Reshaper, even PyLint could help facilitate automation of identification of an analysis of code smells. And then code review, particularly or majorly manually, being done manually through peer review. For instance, you have a colleague or a more senior engineer on the team who is taking a look at the code, could potentially spot some of those smelly code, and without necessarily using a tool, or that the tool might actually miss in itself. All right, so the next is, I haven't understood what code smells are, or the issues that could impact the ability to, or delivery of, or writing of clean and maintainable code. The next would be, how do we now refactor? Haven't understood how to identify those. And the approach is basically refactoring, which is the process of restructuring existing code without changing its external behavior. That is not necessarily modifying the functionality that the code was built to perform. And so, so what are the refactoring techniques? We have, for instance, extract method. That is the breaking down of a long method into smaller, more focused methods. I wish if this was a workshop section, I possibly would have been able to deep dive into practical showcasing some of these techniques. However, we could take some of this insight up and in various teams look them up or consider them and see how they work in real life. So the next one is the move method, that is moving a method of field to a more appropriate class. This is possibly something that we subtly do or knowingly do, or sometimes do, or that some people already do. Basically, moving a method or field to a more appropriate class could particularly help, remove smelly codes or fix smelly codes, particularly related to, say, for example, long method and all of those. Third technique here is renaming variables, basically changing variable names to more meaningful ones. So this particularly, helps to, say, for example, fix or reduce or could potentially impact, say, for instance, the number of comments that needs to be made or put into a code base. And then the fourth item here is introducing parameter object, that is replacing long parameter with a single object parameter by basically using classes. The next item here is team culture and practices and understanding how they could impact, for example, the writing of clean and maintainable code. And the first item that I have here for consideration is encouragement of best practices, meaning that is, it's imperative for us product engineering teams or software engineering teams to have a culture to ensure that there is a culture that emphasizes the importance of best practices. For example, whether during stand-up meetings or during reviews, code review sessions or whatever time, but it has to be inbuilt into the culture right from the onboarding of a new team member, such that the person coming in to join the team understands the emphasis or the characteristics, the quality or the values that the team precisely holds in terms of, say, for example, writing clean and maintainable code. Also, in addition to that, I have peer programming and continuous integration that leads to higher code quality. So encouraging best practices potentially helps improve code reviews, peer programming, continuous integration, and potentially could lead to higher code quality. Next is the collaboration and communication. That is, this could potentially facilitate open and effective communication within the team and potentially foster collaboration, allowing the team to share knowledge, identify issues early, and work together to fix or to find the best solutions to an issue. Third item here is accountability and ownership, basically encouraging the team to take ownership of their code. And this in itself can potentially make individuals more likely to care about its quality right from the get-go. And the fourth item here is adoption, which is somewhat similar to the first item that I have listed here, but basically emphasizing that there is need for adherence to coding standards. So whatever standards are adopted within a team, which forms part of the best practices for the team, it's imperative to ensure that there is monitoring and adherence to that coding. So engineering managers need to take particular responsibility for ensuring that some of the things that are identified as best practices are being monitored and being done according to the coding standards adopted. All right, so the next item here is the key principles for writing clean and maintainable code. And the first here is, like I mentioned, this could form like part of the best practices or things to put into the best practices or code for best practices. And the first thing that I have here is the keep it simple, stupid, right? It's an acronym. Excuse me, it's the acronym is KISS, right? And it basically means that we need to ensure that we strive for simplicity in our coding by avoiding unnecessary complexity in the coding. And the benefit of this is that it simplifies the coding process in itself. It helps to deliver simple code that is easier to read, easier to understand, and easier to maintain. And also, in addition to those, it also helps to avoid over-engineering solutions and implement straightforward logic. This is like an umbrella principle that every team needs to ensure that it's in the toolbox, along with some other set of principles for that could go into the best practices that will be adopted. The next item here is dry, which means don't repeat yourself. Basically focuses on avoiding duplication of codes, whether it's a method or whether it's a function, maybe not necessarily a function, but method, and also okay, and functions themselves, basically to avoid excuse me. This could help avoid duplicating code by abstracting out common functionality into reusable components. And it also helps to reduce redundancy, making the code base easier to maintain and less prone to error. For instance, you have the same block of code that is used in multiple places. Refactoring it into a single method or function that can be called from different locations could help fix or could help align the team with don't repeat yourself or avoid duplication of code. Then the next item or next key principle here is YAGNI. That is, if you aren't going to need it, don't add it. Really. So this principle basically, teaches or helps or could help team to avoid adding unnecessary functionality to a code base, except and until when it is actually necessary. And basically, just implement features and functionalities that are necessary at the moment of deployment, and not those that we think might be needed in future. This is particularly important because, for instance, when you are doing, let's say, traceability of requirement or validation of requirement, this could potentially impact that ability to validate or say, for example, go into developing test cases appropriate for validating that specific requirements have been met. Next is the solid principles, which has quite a number of subsets. And on that list of the subset of solid principles is that first, single responsibility principle, which states that a class should have only one reason to change, meaning it should have only one job or responsibility, nothing more, nothing less. Next is open and closed principle, and it basically states that the software entities should be open for extension, but closed for modification. List curve substitution principle. This states that objects in a program should be replaceable with instances of their subtypes without altering the correctness of the program. Next is the interface segregation principle. Basically states that clients should not be forced to depend on interfaces they do not use. And lastly, on this list is the last item on this list is dependency inversion principle. And this basically states that high-level modules should not depend on low-level modules, meaning both should depend on their respective abstractions, right? Some other key principles are modularity, which is breaking down the code into smaller, self-contained modules, making the code base more manageable, reusable, and easier to test. Other key principles that could be adopted are encapsulation and testability possibly or potentially some that we currently already have in our tool set and that has formed part of what we use in our everyday practice. But these are some of the key principles that I think could significantly impact and improve writing of clean and maintainable code. So this leads me potentially to the end of the focus on this presentation. So quick takeaway, we've looked at the importance of clean and maintainable code. We're seeing that it could potentially impact or help us improve debugging and enhancement of code, particularly making it easier to read and understand. Also touch on the ability to make it simpler to identify and fix bugs. Also worthy of note is that it could potentially reduce the time and effort required to debug and enhance the code. Also, it has potential to increase the development, speed up the development cycle, and increase resolution of faster or leads to faster resolution of issues. Importance also, I mean, one of the key things that is also important to take away is that it improves the team collaboration, particularly helping team to easily understand each other's work, and particularly aiding the ability to, have colleagues or peer review, contribute to the code review through peer review or during peer review. Finally, it also could, aid scalability and maintainability, which is also critical to ensuring that we are able to deliver clean and maintainable code. I also touched on code smell, defined what code smell is, listed common code smells. But I don't want to go into all of those. We could, watch the video later on to deep dive into some of the concept already taught, particularly regarding the types of common code smells and how to identify all of those. I also touch on refactoring, which is basically how to improve, identify and improve code smells. And I also touch on team culture and influence on practices. And finally, which was the last slide, before I move to this, the key principles for writing clean and maintainable code. And this leads me to the end of my presentation. Thank you.
All right, David, that was pretty quick and very insightful. I still like your session title, that is Kiss. Very interesting. Right, let's take some of the questions, right? And we still have about 25 minutes until we move to the next session.
All right.
Let's see. We have one question coming from Bhaskar. He says, "I like these case, try, and Yagni. These are very helpful. I like this terminology. It's very easy to remember."
Yeah.
Gaurav is asking, "Can you share a systematic approach or checklist you use when refactoring complex code bases, or any like 3-4 things that you do?" Most of it you did cover in your presentation anyway. I did
Yes,
see that.
yeah. I think if you look at the key principles, I think those set out a very, very systematic approach in and of themselves. For example, I believe that you're looking at, okay, what are the things that you need to do, or how do you want to approach the refactoring of complex codes? Basically, all that is needed is I think the key principle, just before I go off that, or before I forget, the key principle here is to ensure that right from the get-go, some of these principles are imbibed, particularly, say, for example, ensuring that you avoid um, long code or long
Mm-hmm.
methods, rather. Once you are able to avoid long methods, one of the key things that advantage that that could give you is that you are able to, particularly go to each of the methods or each of the functions, and then, look at what each of the functions are designed to do, and then look at whether you could identify any code smell within that particular section. I think breaking a very complex code base down into uh, whether it's methods or classes or even the function itself would be critically helpful in approaching or having a systematic approach to
Yeah, that's well
refactoring.
answered. Yeah, that's well answered, and I 100% agree to whatever you're saying. It definitely makes sense. And if God, if you just go back to what David just had in his refactoring slides, right? I think that is one thing you can also have a look at it and view it once again. David, I see there are a few more questions. I'll get to it because we have enough time. We can do chit chat. David, how does your day-to-day work life look like? I mean, how do you spend your day?
So typically, once I wake up my own time, the first thing is I check calendars, see if I have meeting lined up. When is the first meeting starting? When is the last meeting for the
Mm-hmm.
day? Um, and then I go to emails to first also take a look at what emails do I need to quickly respond to,
Yeah.
and then go to, say, for example, our communications channel or communication channels with various teams, product teams and engineering teams, and then look at to check out if I have any message requiring that I quickly give a guidance or response to. Typically, I often, have a very, very long day that actually stretches beyond my, the typical normal 9 to 5. I
Mm-hmm.
mean, for my main region, because I tend to work with different people from across different regions, the
I see.
US, the Asia. So sometimes early, sometimes late, or sometimes early and late together at the same time.
Yeah. Yeah, that's good. I mean, even at my place, it is 9:30 p.m. So yeah, I
I can
understand, right? When you
imagine.
work, when you have global team, right? The time zone is sometimes a challenging, but
Yeah.
nice. I mean, I see that you're very much organized. You get up, you check your calendar, look at the emails. What platform do you use for all the communication, like Slack, Telegram, Microsoft Teams? What do you use?
Yeah. So we use Click by Zoho.
ClickUp,
Um, Click, Zoho Click.
Zoho
uh,
Click.
for communications,
Oh, I see.
whether internal call or messaging and all of those. Incidentally, one of the things I did when I first came on board was to also streamline project management tool, which is also from Zoho, that is Zoho
Mm-hmm.
Project, to ensure that we can have notifications, for instance, due date for a particular deliverable, to be sent into the click to
Mm-hmm.
notify the assignee, um, or the owner of the task or deliverable, so that teams don't, miss the set due dates for each of the deliverables. So combining the whole project, Zoho Click has particularly enabled seamless collaboration and communication within, even across the group of our complaints within those media group.
Yeah, that's good. That's very good to know. I mean, that you use Zoho. Zoho has a lot of products. In fact, If I'm not
Yeah.
wrong, Zoho is an Indian company. They do annually. They also do their conference. Have you ever been to India?
No, I haven't been to India.
Mhm.
I'm hoping that one of these days, when maybe when I take a leave and I'm taking a tour,
Yeah,
I could visit and
yeah.
say hello to the team over there.
Yeah, I mean, even we at C Sharp Corner, we do annual conference. We're gonna do one in October. I think that in
Oh,
the second or third week of October. We do it every year, and it is one of the biggest in this part of the region. And we would love to have you there. I mean, and then we can take you
sure.
places. We should have a good time.
Sure. I would definitely consider October 2nd and 3rd.
October second and third week. That's where
Oh,
the time is. We are also putting up a big hackathon. We would love to have you as one of the judges and speaker there. It would be really
all right,
nice.
great, great.
Okay, let's take a question then. Bhaskar Das has been asking. Bhaskar has been very consistent. Thanks, Bhaskar, for all these questions. Bhaskar is asking, how should one handle legacy code that wasn't written with maintainability in mind? Delete it. No, I'm kidding.
I think that that also somewhat aligns with what I initially mentioned
Hmm.
about looking at, for example, just looking at what the code or functions within a code base is meant to do, right? And then just breaking them down into, say for example, the methods,
Hmm.
say for example whether it's easier to do whether it's easier to even look at them from function level, just looking at the function, and then begin to do your code reviews. I think automated tools could be helpful,
Yeah.
uh, particularly to at least get you off the ground with legacy code. It could particularly aid, at least help you first identify basic and common code smells within your code base. And that could potentially improve, uh, at least give you a hedge to then conduct maybe peer review, or I mean manual peer review, and go further from there. Um, I think that's what comes
Uh-huh.
to mind. Except if there is a further information on the case and context, that could possibly and potentially help me to give something maybe much more specific. But assessing the current state would be a critical step. What do you have in your code? Conducting a thorough review of the existing code base to identify major issues,
Yeah.
even like technical depth that previous speaker talked about, and potential areas of improvement. But I believe that static analysis tools like Reshaper, Pipeline, and all of those could help you get off the ground easily and get going with the review or refactoring of legacy code.
Yeah, that's nice. That's nice. That's very well answered. Uh, um, if I was given a legacy code, what I would do, I would use GitHub Copilot. I would just run GitHub Copilot and get some suggestion right up there, put up in a document and send it to my manager. Like, hey, you know what? These are things that I found, and I would not give it very instantly. I would take like 2 3 hours, sit back and relax, get myself a coffee.
Yeah.
That is what I would do. I think that's a good way to start. And for everyone's watching, we did have a session today later in the evening by Rijwan and Satya Karki. They did show a very nice demo on how you can refactor your code with GitHub Copilot. And the best part about GitHub Copilot that it has been trained with all the GitHub repositories, right? All the open source code that is available. So GitHub Copilot is good in almost all the programming languages, and especially good
Yeah.
with C Sharp, Java. They who have been existing in this ecosystem for so long. So thanks for us answering that question, David. Deepak says, nice, David. Thanks, Deepak, for tuning in. Let's take
Thank
one.
you.
Let's take one from, let's see, Atul is asking. Yeah, Atul is asking, what tools do you recommend for automating code quality checks and ensuring compliance with best practices? What tools do you use, David, in your day-to-day life?
Um, so, for example, Reshaper pipelines. You could
Mm-hmm.
also do Sonar Cube, Code Climate. Even like Simon mentioned, I think Copilot could strategically aid uh,
Yeah.
code quality checks and help you
Mm-hmm.
identify where you could particularly improve and ensure compliance with best practices. Incidentally, for example, you could even develop an interface that could go, say, for example, integrate with OpenAI. I
Mm-hmm.
think that could, and then give basic rules to help you guide, particularly identify best practices and then check your code against those best practices. And that could be one way to go. I mean, if you don't want to go with, say, for example, some of these tools that were already mentioned, but I mean, I think AI is going to be a game changer for the development teams. I mean, increasing capability to fine tune codes and ensure that teams are building products and following best practices as much as possible.
That's right. That's right. That's thanks for answering that question. We still have about 10 minutes. Having said that, I'll follow up on what you said. That I was again a couple of sessions back. We had Abhishek Mishra, right? Even he suggested some of the tools that you said, and he gave an example for Visual Studio, like tools like
Yeah.
Visual Studio, right? JetBrains. They have these tools inbuilt where you can actually go and automate your all these tasks.
Mhm.
Pretty neat demo up there. You can Atul actually go ahead and rewind this conference like 4 hours back. And we've been streaming from last what 5.5 or 6 hours. We still have
Yeah.
about 4 hours to go. Uh, so yeah, you can also look up to that. So someone says, well, it's his daughter. Don't get confused. Maheshan is the founder of C Sharp Corner. He says, David, you should definitely come to India for C Sharp Corner conference, especially for
All
the
right.
MVP day, right? So you
I
get
will
invitation
consider that.
right
Thanks
from
for
the
inviting
founder.
me. Thank you so much. I will definitely consider that.
Yeah, I got confused right in the beginning with that profile picture. Never mind. Okay, let's see. Bhaskar says thanks for answering that question, and right, thanks Simon for taking my question. Right, and you bribed me. Never mind. Let's look at the next question. It's by Rohit. He's asking, what are some of the best practices of writing tests that are both effective and easy to maintain?
Hmm. Um, so I think that
I have a very good answer to that.
okay.
And yeah, and I have only one answer because I'm no expert, right? So if you use Git, I'll go back to again GitHub Copilot, right? Because I don't know a lot of code. If you go to GitHub Copilot and you just write test, you put a slash and you write test, it will create test cases for you. So I think there
Yeah,
is it. That there you have it. It's pretty easy, right? You don't have to
yeah,
spend a lot of time for every method or function that you have. It's gonna write it for you. So that is pretty helpful. I'm not an expert, but that is one way to do it. But yeah, if you look at other sessions, you may find some of answers over there. Okay.
Uh,
There,
I also
yeah.
think that just before we go there, go
Mhm.
away from that, I also think that some of the insights previous speaker shared, I mean,
Mhm.
or just in addition to what he has shared, I think key principle are just keeping tests small, just in addition to, I think what, first of all, Simon has shared one, the easiest approach to it, which
Yeah.
is which is the simplest way. And in addition to that, just keep tests and I mean small and quite focused. That could particularly like help you help each test case or test that you want to write cover a single behavior and aspect of code that you want to write. I mean, if you want to do a manual approach to that.
Yeah, yeah, that's right. That's right. By the way, that reminds me, we also have one more speakers from Nigeria. Do you by any chance know Aleru Divine?
Um, I have seen a profile,
Yeah.
a software engineer as well. Yeah, I think I saw a profile
Uh,
some
yeah.
weeks ago.
She's also from Nigeria. I mean, I think we have about 11, 12 speakers, and we're covering about 8 to 10 different countries. It is so exciting, right? We have speakers from
Yeah,
all over the world.
yeah.
For some reason, she couldn't make it for this conference. She had something urgent, but so happy to have so many speakers from Nigeria, Kenya. We get a lot of speakers from there. What are some of the conferences, David, do you attend in your city or in your country? What are some of the popular conferences you like to go?
So two things. I go for say conferences involving developers, development,
Hmm.
improvement, and all of those things. I also go do, for example, program or technical program managers or technical project managers or product managers conference. For
Hmm.
instance, I have another conference, I think next week. It's a physical conference. It's for Python developers. And then another one maybe next month or so that I have been scheduled to speak over there.
Wow, that's good. You're on the roll, right?
Yeah.
Okay. Okay, David, right before we move to the next session, one question that I'm asking from everyone, and this question is actually from another David. I run show for him, and he asked this question to everyone. So I just stole this question from him, and I'm asking everyone that from apart from all this sessions, technical stuff, what do you do in your free time? What are some of your hobbies?
Apart from that, okay, so I do music too. I mean, I play musical instrument, though I
Wow.
haven't had time in a while to
Mhm.
actually train over. But once in a while, when I stumble on an instrument, I just do that. I also used to
Mhm.
play football. What else? I
Which
also like
instrument do you play?
say that again.
Which instrument do you like to play?
Oh,
I'm
okay.
guessing guitar.
Guitar. I play bass guitar and piano.
Okay, that's good. That's good. That's nice. That's good. Football music, I couldn't get any better. Uh, uh,
Yeah.
all right, David. Is there anything else you want to say before we move to the next session? Is there any final words?
All right. Well, I just want to say thank you to you and to Chand. Did I pronounce that
Yeah, that's right.
correctly?
That's right. You got it right.
Thank you for having me. It's a pleasure to be at this year's Code Quality Conference. I'm
Oh.
hoping to be able to share some other time with you as soon as possible.
Yeah, I mean, David, thanks for accepting the invitation. I know it's getting late at your place. Remember at C Sharp TV and actually at C Sharp Corner, we do a lot of virtual conference and in fact many live events, live shows. We do it. We would love to have you there and definitely in India. So let's stay in touch. Thank you so much once again, and
Thank
I'll
you.
let you get back to your work. I know you're still at the office, and have a nice evening. See ya. Bye bye.
Thank you very much. Bye bye.
All right, ladies and gentlemen, that was David for you. And for some of you who may have noticed, or if you're watching, if you have been consistent with this code quality conference, this conference was actually started by David McCarter. He got a little busy this year. He has some other things going on, so he couldn't host this year's conference. But this conference was actually started by David McCarter. So shout out to him. It was his idea to do the code quality conference. If you search on the internet, you may find a couple of more code quality conference, but he has made this conference really nice. We have had around 70, 80 speakers in last 3, 4 years. So thanks, David. I don't know if this will reach to you, but thank you so much for putting this all together. I hope we get to see you next year. Having said that, we now move to our next session. But before we do that, I've been telling everyone that please go ahead and use the hashtag code quality conf while you ask your questions. I'm quickly going to share my screen, and let's do the first round of giveaway. And for those who's asking me what they're gonna win, I have no idea. That is also a secret. What are you gonna win? I have no idea. Okay, so I'm gonna click on this draw. Okay, this is the first draw. We're gonna do one towards the end. Okay, we still have about 5-6 minutes before it gets started. Let's click on draw. We should do some drum rolls. There's no music. I always forget to add some music there. Oh wow, Techno Guruji Ajit. Congratulations, Ajit. You win. What you win, I don't know, but you'll definitely get something. DM me on Twitter, that is Code with Simon, or CSharp TV, CSharp.tv, any of these two accounts, and we'll make sure that we get you your swag or prize. Okay. The competition is still on. You all can go ahead and write Code Quality Conf whenever you comment. Let's take a minute break, and I'll see you in a minute. Oops. There you go. Hi everyone, and welcome back to Code Quality Conference once again. I'm your host Simon, and this is the 4th edition of Code Quality Conference we are doing. At this instance, as I speak, we have about 568 people tuning in from different platforms: Facebook, Twitter, YouTube, LinkedIn. Actually, not LinkedIn, and Twitch. There's some problem with LinkedIn. Great conference already. I think we have already crossed around 20,000 people watching in, and I'm pretty sure we're gonna break previous year record. Before we move to the next session, I quickly want to talk about our other conference that's coming up. The next conference we have is the React and Chill conference. If you are someone who builds applications using React, this conference is for you. The registrations have not started yet, but you can actually go and see that we have about 8 to 10 speakers already listed on the website. Speakers are from Red Hat, Microsoft, Google, and the best part, the speaker that you see, where did that speaker go? Miran. Miran used to work at Meta, and he has been using React since 2016. He now has his own startup, but you should definitely check out his session. I used to work at Meta along with the React team, and I think this is very exciting to have someone like him. We have Faris, we have Benzi, we have Akhmos, we have David. This is just first 8 to 10 speakers. We have more speakers lined up. I'm going to talk about more upcoming conference later on, but I think it is now time to go ahead and invite our next speaker, who is none other than the founder of CSharpCorner. He is actually the keynote speaker for the day, and he's going to talk about, no surprises, he's going to talk about AI. He's covering power of AI, code quality, and performance. Ladies and gentlemen, put your hands together for the man, the myth, and the legend, the founder of CSharpCorner, Mahesh Chand.
Hey Simon, how are you?
I'm doing great. Thanks for asking me. You're the first one to ask me. It's usually the other way around. How are you doing today?
Good, all good, all good. Looks like it's been what 5, 6 hours already, and things are going good. I've been watching this on and off.
Hmm.
Yeah, amazing, great, good
Yeah,
work.
it's been 6 hours already, and great team effort from behind the scenes. I really appreciate everyone from the team who's helping me. It's just not me, but thanks to everyone who's helping me out. So Mahesh, I know you're gonna talk about power of AI in code quality and performance. I see you've shared your screen. I'm gonna add it to the stream. Everybody else can see it, and next 45 minutes is all yours.
All right, thank you. See you soon. So everybody, good morning, good evening, good afternoon, wherever you're joining us from, and also again, I think Simon just mentioned shout out to David MacArthur. David MacArthur is one of our MVPs and prominent speaker. He's the one who came up with this idea for code doing a conference just focused on code quality. So if you know a little bit about David MacArthur, he has a weekly show on Sharp TV. Um, and he's always fascinated with the code quality and he loves it. And that's his idea. This year, he was a little bit, I guess, busy. Hopefully, as Simon said, we will see him next year. So, all right, let's get back to the keynote. Everybody, welcome. My name is Mahesh Chand, founder of CSharpCorner, and my keynote today is all about AI and Copilot, how we can benefit from AI in improving our code quality. But before that, I've been watching this conference for the last 5, 6 hours, and I must say, amazing speakers, amazing speakers. I saw Sagar covered code quality in DevOps, and then Wahid came and Satya talked about Copilot, refactoring your code. Amazing, amazing. And then Abhishek talked about, how we should look at the matrices when looking for Copilot, and then we saw some good numbers on technical debt and details on other topics from Paco and Adam. And David just talked about, writing clean code. So clean code has always been my, one of the first thing is like, listen, if you're writing code, it has to be clean. So that said, thank you everybody, all the speakers before me and after me. This is going great. You guys are amazing. Let's get back to this GitHub Copilot. I'm sure most of you have already heard of GitHub Copilot. If you have not, I highly recommend you check it out. GitHub Copilot is your AI assistant. It is your code reviewer. It is your peer code reviewer. It could also help you answer your questions. So many of you, when you go to Google and search for some quick questions, answers, code simple, you don't need to do anymore. You're already there. You can do everything in GitHub Copilot. It is available through most of the popular IDEs, especially from Microsoft. Microsoft Visual Studio has it, VS Code, JetBrains, and other IDEs. So Visual Studio, the latest version, already has Copilot integrated in it. But some other IDs you may have to download a plugin or something extra for that. It supports major programming languages, right? C, C++, C Sharp, Java, Python. Any majority of them are already supported. It also actually supports the JavaScript and JavaScript framework. So you can ask Copilot to write something in React or Angular. It will write that for you. And the results say that Copilot is increase the productivity of developers big time. So I highly recommend you check out Copilot. Oops, what's going on here? Okay, so let's talk about code quality. In today's session, I'm just going to focus on code quality and how you can use GitHub Copilot for improving code quality. So when you think of code quality, look for these 5 things. Readable. Is your code readable? Can somebody just join your team? They can, look at the code and they find it very easy to understand. That's easy, the first one. Reusable. Can you writing the code that can be reused, including like classes, libraries, whatever functions? So can they be reused, right? You don't have to duplicate the code. Is it concise? You don't want to, especially if there's latest versions of the language coming, especially, I work with C Sharp. And if you look at the code written in C Sharp 3 versus 12, it's a big difference. Are you using maintainable? Are you building a maintainable code? Is the code maintainable, right? Clear transparency, and then resilient, right? You have error handling, logging, notifications. What happens if something crashes in my code? So these are the 5 major things, we need, when you think of code quality, think of these features in your code. These are some numbers from GitHub Copilot, and I care about the first number only, that 85% of developers are actually happy and felt that they have a better code when they use Copilot when it comes to code quality. So definitely check it out. And you probably know what GitHub Copilot does is, as everybody said multiple times in this conference, is that GitHub Copilot is just using AI, and it is using GitHub code repositories, using also online websites. It also uses Microsoft has a lot of code as well through its own documentation. So it's using all that and try to give you the best code possible. However, it doesn't mean that all code written by GitHub Copilot or any chat GPT or any of these generative AI tools is correct. It's also, you can't be sure that it's the latest version. You can also be sure that it has best quality. So that's your job to verify that, and something we can try to do this using the tool. So I'm going to cover these 7 things. How are you going to use Copilot to explain your existing code? Right. Let's say I'm going to do is I'm going to share my screen. Let's see if I can do share my screen. I'm going to show you live how to do these. Share screen. Let me try that. Okay. I'm going to share my window. You know what? I'm going to share my entire screen, right?
Perfect.
Okay. Simon,
I see your screen. You're inside StreamYard. Once you move away, I'll add it to the stream.
Okay. Tell me when you see my screen.
Yeah, I see a Visual Studio. I've added it to the stream.
Great. So this is some of my existing code, and funny thing is I wrote this whole code using Copilot. I didn't write a single line of code. But this is not where I'm going to show you today. Imagine you already have the code, or you're writing already code. So first thing we will start with is that the code comments, right? That's where first you want to start. Right now this code has no comments. And I'm sure you already know there's multiple ways you can access GitHub Copilot. One is you can go from here and open the chat window, right? Open chat window here, and you can start chatting and asking this, questions or code. You can put your code there and ask whatever. So that's really not what I'm going to do. You can also do is right click on this here. You say ask Copilot, or you can use shortcut here, Alt plus slash here. That's what I use all the time. So I say okay. So I open here. So you can put this cursor, depends on where you put your cursor. So I'll just put right here. So what I'm going to do is I'm going to ask Copilot to do some work for me. Hey, can you comment this program? And again, if you're not familiar with how generative AI works, prompts are the key. Prompts means how do you ask questions. And there's a prompt engineering, and there are how do you ask and write prompts. On CSharpCorner, I have written a great big long article on how prompt is broken down into different components. So if you don't know how to write AI prompts, definitely highly recommended check that out, because your answer can be much better by writing more detailed prompts. All right, but this Copilot in the code editor is simple. It only cares about the code, and it knows what your code you are in. So that's the easy part. You can straightforward just ask questions. So I'll say, hey, can you comment this program? So let's see what it does here. I'll show you right now. It's working now. It's probably reading my code. That's what it does first. What this code is simply, let's look at here, right? So what it does is, as you can see, that it has written in the right side here, it's showing me the recommendations, how it's, so if you go through that, if you like the code, you can accept it, and if you don't like, you can ask him again. You can even give more details. You can cancel it and say, I want to the detail. Let me show you quickly. Can you document this code with detailed explanation? Whatever, explanation, right? So you can do that. It can probably write more details now. So more you give, more you tell him, like you can even say, so now this is a little bit different, it's writing on top of each line a little bit more. So say, okay, I say accept. So as soon as you accept, you can see that your code is commented here. And again, just because code is commented, it just Copilot try to do its job, but you can always go back and read it, make sure it's done right. You always want to verify the code written by Copilot or text or anything comments, right? So this didn't comment on this. So because I said program only, now I'm going to say, can you comment author class? So now I'm going to comment that, right? So this is going to add comments to my author class here. So you can see right here. So you get the idea. You can go and, whatever, you can ask for, add more things, and that's all. So that's one thing you can think about when it comes to code quality is as commenting the code. Now, second is explain existing code. I missed that. So I'm going to explain, how many of you write code and say, you know what, I'm going to write a documentation on that code. And how boring is that? We know developers, we just like to write our code. We just try to solve the problems. We want to just launch the program and run and test it. We don't have time to write articles and blogs and documents on that. So I'm going to simply say, okay, can you write a detailed blog about this entire application? So let's see what Copilot does, right? Look at that. So here we go. It has quickly written in a blog already. This title is building a file processing application in C#. So I didn't tell Copilot anything. I didn't tell it like what it is. So it already goes, reads my application, try to understand what it is. It's building a file processing application in C#. And there's introduction here. It also explains step by step. There's author class, and then there's main method using a stream reader, split method. So whatever you would usually write, it's all there. So if you want to document your code, this is first to start with. It's like 80% of your work is already done, and maybe 90, right? Sometimes you may say, oh, this is enough for me or for my team. Now you can just go and add a little bit more to it, and that's your documentation. Now, third thing I'm going to cover is talk about error handling. Right now, right now it's fine. Right now, there's a little bit error handling is already added here, but you can expand more on that. So you say, you know what, error is great, but I'm going to do is, can you add a logging functionality to this program and save log errors in a text file name. You can even give detailed instructions. What do you want your log file to be? Where do you want it to be stored? You can even have different types of formats. You can say, I want you to store all these errors in a database. Then you can go way beyond and build the entire application here without just typing this. You don't have to write a single line of code. So let's see what it does, right? And again, just because it's typing the code, it's going to write majority of the code. You still have to test the code for accuracy, performance, make sure it's doing the working right. You have to do tests. Just don't assume that everything is written by this is 100% correct. Still writing, looks like. There you go. So here we go, right? You can compare here. You will see that, okay, so this has added a log error method here, as you can see. Log error method just below the catch statement, catch block here. And then I think at the bottom you will see the log error. So log is a static method. It's added to our class. See, it's also our text file, which is error log, which is stored in ctemp errors. The reason it's adding to ctemp is because I'm already creating another file in ctemp at the top. So now every time an exception comes, it's going to write to this log file. So how cool is that, right? So far, I have not typed a single line of code here so far. That makes sense? So let's go back to my list here. So our point here is really, guys, is that a Copilot can save you a lot of time and do some of the work you really don't like to do, the boring work like typing and writing comments and all. So update code to the latest feature. Same thing you can do is you can, if you have an old code, right? You have code. I have a lot of old code. I was looking at CSharpCorner, my code I wrote 10 years ago. It's for C# 2.0 or 3.0 or whatever number. Now it's C# 12. You can literally ask I'll go and I think this one is latest code, so it will be hard and we don't have time to show you, but I can just go here and say, let me see this. Can you update this below this program, because this whole program is to C#. Well, right. I don't know what version it's written. Probably it's in a little older version. So let's see what it does. You can also be specific that can you write, certain functions, certain method, more detail you do, it's going to try to help you write your code, what you want to do anyway. So look at this. So in left side, we were using a statement, right? We are using use statement. That means clearly it's a old version of C# and also using this parenthesis. In new C#, we don't need anymore, right? New C# you just go and call direct. So same thing with the while statement right here, right? Is not. This one is using is not. That's a new feature in C# 12. Things like that. And look at this is also a new feature here. So now out of sudden, we don't use plus anymore in string concatenation, right? That's the old way to write. This is a old way to write when you want to concatenate strings in C#. Now this is the new way to write in C# 12. And boom, guess what? My code is now, even look at the new, when you're creating a new object, author class here, you don't have to specifically call the name, you just call the constructor this way. So now I can say except, and this, my code is now updated to C# 12. How cool is that, right? So I just wrote comments. I just commented my entire code. I just also created a documentation. I just updated also that to C# 12 in literally few minutes. And how cool is that? Next thing is test cases, right? How many of you really love writing test cases? Not too many. I don't. And let's, same thing. We'll go back to our, same thing. I'll just say, hey, Copilot, can you write unit tests for this program? It sometimes takes a little time because it's working, thinking, it's reading your code. But while it's doing that, it's going to come and write the whole unit test. Look at this. So there's class program test, right? Just scroll the whole thing. It's just as you can go through this, out of sudden your whole unit test is created in it. So now, except you can then go back again and read, make sure that all the whatever you want to do is doing the right thing. You can change that manually now. You can test it. That's up to you. But guess what? Majority of the work is already done for you. And so how cool is that? It's making, I would say, 88% productivity sounds really good, because more you learn, more you learn about what it can do, how you can use different tricks, and also you can train your Copilot on your existing project. So let's say you have a old legacy project. But you just join, and it happens all the time. When you join a large company, big company, sometimes you will get put into this big large project where sometimes it takes you like days and weeks just to understand the code and reference and what DLL it is and libraries, all that. So out of sudden, first of all, you can say, hey, can you just explain me this code? It's going to go and read. Larger the code base is, it's going to take a little more time, but eventually once it's learned, it's going to explain you that code for you. It can write comments for you. It can error handling. You can say, oh, I want to use certain kind of formatting in this code. It can rewrite the whole code for you. Same thing with the performance and security. You can, if you search, there is also, I think there was already session or not coming up. We already had this, but you can also say, can you check my code for performance? Can you check my code for security? If there is a security, something you're doing around security. For example, you may be calling an API, or there may be some kind of, login thing going on for the API, all that. So it's a, potential is limitless here, unlimited. You just learn more and start using it. So with that said, let me invite, I think good thing is I saw a session already on code refactoring, but I'm going to cover this anyway. So let me invite Sean here. He's the rockstar developer. He's going to show us code refactoring feature of Copilot. Sean. Hey, Sean.
Hey, can you hear me? How's my audio?
Yeah. Audio is great. You're looking
Good.
sharp. Look, I like the t-shirt.
Thank you. Thanks.
Yeah.
So how do I share my screen here? Present.
Right. Yep. There's a right here, present and share screen.
Okay. All right. Should be my desktop. Cool. All right. All right. Thank you. I'm just gonna start here. Yeah. So for me, when it comes to AI, one of my favorite superpowers you get as a developer is saving keystrokes. I'm someone who's been programming for a long time, 17 years of hacking away at a keyboard. I've struggled with carpal tunnel syndrome and other injuries related to software programming. I use a fancy ergonomic keyboard and do everything I can to reduce injury. But AI-guided autocomplete and generative programming can save an enormous amount of keystrokes, which has been very pleasant for my wrists. But enough about that. I think there are many practical applications of AI in programming, but one of my favorite uses is for understanding and working on legacy code bases. It's common as developers that we find ourselves working on existing code bases with a lot of history. And these code bases can be hard to understand, especially if there hasn't been a consistent standard enforced throughout the years. But AI tools can be pretty helpful here. If I have to work on an old part of a code base, one of my first things that I do is apply some basic refactoring to the code I'm working in. And I'm talking basic down-to-earth refactoring that doesn't make sweeping changes to the code base, because of course, if we're going to do that, make sweeping changes, then we're going to want to plan that with the team to make sure that we can test it properly. I mean, traditionally for refactoring, we use tools like ReSharper or the built-in refactoring in the IDE. But I find that AI tools, especially Copilot, being integrated directly to the IDE, works pretty well as a refactoring tool, turning a sentence of natural language into practical refactoring steps. It's pretty powerful. And of course, there's a big difference of how AI handles refactoring versus traditional refactoring tools. And thus it can get code wrong. Since we know it can get code wrong, we can review those changes it tries to make. And in the process of reviewing those changes, we actually do the work of understanding the code, which is crucial in a legacy code base. So you're understanding the code while you're improving it slightly, which is a nice little combination of things. Let me see if I'm sharing the correct code here. All right, so what we're looking at here is a snippet of code. It's some legacy code from CSharpCorner. And you know, I come into this code and I need to work on this. This isn't bad. This isn't too bad. it takes a couple of minutes to maybe parse through these if statements, and I noticed that there's some repeated code here, like repeated logic. So I think we can just make some improvements to this to make it a little bit easier to work on. So as Mahesh demonstrated, we can use this inline Copilot. So if I select some code and bring Ask Copilot, you can see that when it comes up here, that there's some this pink line on the left side that surrounds the code. This is actually showing what code is in context to your prompt. So when you're asking something in the prompt here, this is in the context of this code here. So first thing I can just say, maybe change this code to use var instead of explicit types. Because I mean, nowadays we want to do that, so that's just like, something basic. All right, then we can see the diff here. We're just going to compare real quick. We're using var, var, var. That's good. That's fine. I'll accept that. This is an error. It's an int. So this one specifically, we have to use the type because we're using that as an out var here. Yeah. All right, so that's fine. The variable names, they don't look great, so I'm just gonna select Ask Copilot. We have capital letters here in the local variables, which isn't, a best practice. Bear with me, I have a lot of stuff running on my PC here, so it might be a little bit slow here and there. So I'm just gonna say, can we simplify this further? Let's use the now we can just try basic natural language prompts like this. It doesn't always have to be very technical. The prompts, it can understand English pretty well. So yeah, just based on its huge amount of code that it has online to reference, it's just gonna, fix this for us. And this is, maybe fine. Maybe this is part of the style guideline for the code base. That this is a an out variable, so maybe it just has a little name there to make that easy to know. But yeah, I like this. It changed the variable names. And we don't have to just keep doing this individual steps, but I'm doing this to demonstrate step by step these refactoring steps that we can make. So I can say, like, I'd like to reduce the number of if-else statements. I'll just say branches. I like branches better. I don't like how the response.redirect to page not found is repeated. We'll see what it does here. All right, now for something like this, we definitely have to do some checking here. So when we make a change like this, this could potentially break existing logic. I mean, I don't know what it's doing here. This is not what I wanted here. So let's try this again. Yeah, part of learning to use Copilot is learning to get the prompts correctly. So let me say, can we simplify this? I'll cheat here. I actually have this prompt already copied, so I'm gonna see. And yeah, see, you have to be careful here that the selected context that we're using is what I want to operate on. I'm not operating on any code besides this section here, because this is where I'm working in. So I'm gonna type this prompt. All right, so this looks a little bit more reasonable. It's applying early returns, which is, in my opinion, a good practice for reducing the amount of branching that we have in the code base. So we have some early returns here. And yeah, at the very end, it's going to do this page not found redirect. So that's kind of what I was looking for. Yeah, it looks like it added some code there at the end. All right, so this is a little bit cleaner. We don't have as many branches to look for. We can kind of just like look at this top to bottom and decide, what's happening, and then the by default, it's just going to redirect to a page not found. So if it gets to that point, then it hasn't found any information. I mean, one thing that I can do for this, just to make this even better, is to just break it out to a helper method. So we're not making major sweeping refactoring changes here. So like breaking some code out into a helper method can be a good way to just make some code a little bit cleaner without having to think about it too much. So I'll say create a helper method for this code. Place the early returns with return true. This method should return false by default. And I'm saying it like this because I know that I want to do the check for this helper method before I redirect. So it's actually just inserting the code right here in place, but that's no problem. We can just pop it out here into a separate method. And then what we're going to do is we're going to say if process query string. You know what, let's do if not process query string. That would. All right, and so now that we've broken it out into a separate helper method, now whoever, when a developer comes through here to this method to work on it, they can see this is much easier, saying, okay, we're going to redirect to a page not found whenever this fails. What is this? All right, so now we can look at it, and if we care, we can dig deep into the logic. So yeah, this has been just a couple of steps, practical steps, down to earth. This isn't anything crazy or fancy. It's just something you might have already done, but without me having to do all the in-place editing. It still takes keystrokes to type a prompt, but with practice, you can get the prompts reduced to something that's efficient and doesn't hurt your hand as much as just typing huge amounts of code. Yep. And so hopefully that's helpful. And if there's any questions about using Copilot in Visual Studio, you can ask a question in the comments. Hopefully I...
Okay, that was great, Sean. Thank you. Appreciate it. That was good.
No problem.
Yeah, you can also do a high level commands prompt saying, hey, can you suggest me refactoring this code? And maybe it will cover a lot of those things. You are really giving it very basic instructions like I would do to my daughter, sit here, eat this.
Yeah, I'm giving
So
it
it's up
very
to
specific instructions. Yeah.
Yeah. So you can,
at least for, sorry, go ahead.
yeah, so Copilot can be used however the way you like. You want to tell it to do a certain specific things the way you like, that's fine. You say, can you do it yourself and show me what you can do? Depends on everybody's choice, right?
Yes, for sure. If I didn't know what I wanted, I would ask it higher level questions and have it decide for me. But in this case, this is something I do all the time, so maybe I'm experienced with this type of process, but I know what I want from it, and I'm going to force it to do what I want in this case.
Right. That's good. All right. Thank you so much, Sean. I appreciate it.
Yeah, not a problem. It's great to be here.
All right. So you just saw multiple use cases of, let me go back to my screen again, my slides. So we just saw how to explain your code. If you have an existing code, you can use Copilot to explain it. Also, maybe write a blog or article, or even create a documentation for your team in your company, right? Documentation is always a time-consuming process. You can always ask it to write comments within your code, error handling, exception handling. You can update code with the latest features. In unit testing and code refactoring and performance, this always takes time. And I know how many times I have asked team to, hey, create unit test cases, make sure they run before the project is being, even deployed and test, all that. So you can do all that using Copilot and more. This was just about code quality. So that covers my keynote today. We already covered that. So what are some of the challenges? So Copilot is still early stage. It's learning. It's being developed. It's not perfect. So there are certain things you need to always keep in mind. That number one, Copilot it's a trained on public data. So all generative AI works on the data, and they use these big LLMs, right? So Copilot is trained on GitHub code and some Microsoft code and some websites code. So the code it's learning from If the code is bad, means the data is old or obsolete, and that's the only data it's learning from, that means the code it's going to give you is also maybe bad. So you have to always make sure that the code is accurate, and also it's the way you like it. It's doing exactly what you want it to do. You cannot just automatically assume that. That's your job. So I would say majority of code it can write for you, but you still have to do the final review and rewrite and fix things however you like it. You can also, as I said, if C Sharp language just came out, let's say C Sharp 15 just come out then last week, and you are building a new project on C Sharp 15, there's no way Copilot will have those features right away. It might take it time. So that means any code you will see from Copilot is not in code for your project. So you have to be careful with that side. And plus, if you're working on an older project, let's say you have an existing project that was written in .NET 5 and C Sharp 10. I'm just giving an example. You have to make sure that the code generated is also .NET 5 and C Sharp 10, because if you generate code in .NET 8, there may be something, may break something in your existing code. So that's really your decision. If you are leading a team or you are an architect of a project, that's where you have to set up these guidelines, that what specific instructions you want to give it to Copilot so the code is generating is matching your existing project. You can definitely, I highly recommend. So how many developers, I'll ask this to everybody here, how many developers really focus on code security and performance when they write their code? I bet not too many. Some architects and some teams have already security and performance guidelines set up, but not everybody, especially if team is a younger team, new team, they're working on a new project and they are behind these deadlines. They have to release certain features. So what happens if they don't have enough time to just think about security, about performance, about best practices? So that's where Copilot can also help you that. Other concern is that, so when you say ask Copilot to write the secure code, it may not be secure, because remember, it's learning from public data. So if somebody wrote a code publicly, it's available, and Copilot is in that code, it has a bug or flaw, now that will come to your code as well. So that's where you have to make sure that the code you're using, especially for security, is really tested. And I mean, security side, I would probably stay away from Copilot. I would not use Copilot to write some kind of security for me, because that could create a big issue and then some kind of leak in my code in future. IP is another problem, intellectual property, right? Because Copilot is trained on public data, it may be using some of the data that's you're not supposed to use, because the author of that code has not given permissions to use the code. Also, if you're building this for a company or yourself as a product and you're selling the product, that could also create some problems and challenges in coming time. So those are some of the major things you have to keep in mind when you're using Copilot. With that said, let's take some questions. Again, we are launching a Copilot series on CSharp.tv. It's coming, so it's probably going to have 10 or 12 episodes where we are going to break down each feature in one episode with very detailed. So if you don't know what C Sharp TV is, check it out, CSharp.tv. It's our CSharpCorner's live streaming where experts come and show. We have different shows hosted by different experts. That's where we're also doing live streaming this conference as well. So check it out. Make sure you tell everybody about your friends what we're doing about these conferences. I think Simon already mentioned there's more conference coming up. We have a React conference coming up. We have a leadership conference coming up. We have architecture, software architecture, which is my favorite, by the way. Software architecture conference coming up. And there's a lot more. So with that said, Simon, I think I'm done here. And thank you, everybody. Thank you so much for everybody. All the speakers, they're doing an amazing job. I watched some sessions. They're great sessions. I didn't know certain things. So with that, thank you, everybody. And let's take some questions.
All right, that was great with you and Sean coming up with the nice demos. Let's take a few questions. I'm going to change the stream layout and come back. And Gaurav did say during the session, yeah, sometimes my co-pilot gives irrelevant code and it doesn't work.
Yes, that's possible. Remember, it's just going outside and thinking about. So it's better to train it before. So Copilot is think of it like this assistant. You have to more information you give it to, better results you will get. You cannot just say, "Oh, fix this thing in my code." So you have to explain the detail what your code does, what it's doing, train it on your code sometimes. So prompt engineering is something you want to master. You want to learn more about prompt engineering. There's a GitHub command. GitHub Copilot has its own specific command. So for example, if your code has, certain using certain libraries, you have to kind of Copilot has to know all that. Otherwise, it's just gonna give you the ideas. Then code may not work. Yes, it's possible. So you have to figure out the right way, and especially if you have an existing project, then you can get in really serious issues around there.
Okay, perfect. I did see you've also shared your article link in the chat, so everyone can click on it and read that article. This question by Rohit is he dropped and says, "Are there any specific AI-driven techniques for handling large-scale refactoring projects?"
Okay, I think I need to refactor this question first.
Oh, I didn't see that coming. Well, let's take maybe another question. We don't have time to refactor the question itself. Mohammad Asif, thanks for joining. Mohammad is asking, what about old DLL as we use NuGet packages? How to avoid DDL hell issues?
Yeah, so that's a challenge. That's a major challenge. I think new version of .NET has fixed that challenge, and I'm not sure, to be honest, how Copilot can help with the DLL because it doesn't know the code, right?
Mhm.
Copilot is just a content writer. It's just not a. It's not a tool that can do a lot more. All it's you just giving some command. It's just going to the internet and these models and learning from there, and just saying, "Oh, this is the code you should be writing." All that's what it's doing. It's not, it doesn't have its own much brain. So that's up to you. So I don't think in case of DLL hell it will help much. I think GitHub DevOps and all that, they can help you on that side, but not Copilot.
Mhm.
Copilot is just like generative AI tool. It just generates content for you.
Thanks for asking that question. Mohammed, there's a question coming from Bhaskar is saying, Copilot helps a lot, but how do you demonstrate the ROI of investing in AI tools for code quality and performance improvement to stakeholders? How much does it
Well,
cost? I don't know.
what is ROI? Yeah, it's very simple. It's not. It doesn't cost much. It's like what, $7 a month. Copilot is
Yeah.
$7 a month. That's nothing. You just saw me wrote that whole application in 2 minutes without writing any code. So out of
Mm.
sudden, you saved me 2 days, and I can write a lot of code. I can comment a lot of code. I can do refactoring. I can do all those. When you combine all that, I think hundreds of dollars per month even worth using that tool.
Okay. This is your answer, Bhaskar. Gaurav says, thank you. I'm taking reference of prompts from this article. Yeah, I think there should be a course on C Sharp Corner on how to write better prompt.
Yes, I agree. I think
Yeah.
prompt writing prompt is a new programming. And good thing is that, Simon, you don't need to be a programmer to build applications in C Sharp now.
Wow.
Yeah, it's coming. So you can write, no, I can just go and tell my, Copilot, say, can you take my C Sharp code and write in, Angular? If it's
Yeah.
a ESP.NET in front end, it can do anything. You can even just take a code and say, oh, this is my C Sharp code, generate this in Java. It will take and generate in Java, same code. So how cool is that?
Yeah, it's pretty cool until you don't, until you lose your job.
This is a warning for every developer here, and
Oh,
I've been
wow.
saying this already, that a lot of programmers will lose jobs um, if they don't learn new things. Okay, so if you are still writing old ways, because in coming time more and more teams learn. If right now I need 10 people to do my one project, in future I may need only 4, so 6 people will lose the job.
Yeah.
So everybody should be very careful if you are not learning new technologies. So how do you fix that? Well, you got to continue learning newer things. You got to be on top of new things. If a company has 10 employees, 10 programmers, and they only need 6 or 4, they will keep the one who are using Copilot. They will fire the one who are not using Copilot. They all, if you're moving slow, why would I want you? So you just saw the numbers that developers produce so much bugs that 40% of our team's time goes fixing those bugs. So you have to learn all these things, like how do we not produce bugs, how to write better code, how to write high performance code. Also, this part will lose some jobs, but there's going to be new jobs in newer technologies. So you also continue to learn that. So jobs will shift. Back in the day when I was in India, a young Simon, your age, then
No, when you reach my age, you are in US. I'm getting old, sir. The Simon you hired is old now.
so there was a debate in parliament that, Rajiv Gandhi was trying to introduce these computers. They're like, if computers comes, a lot of people lose jobs. That is true, but computers are created more jobs than the losing jobs. So people who are still in pen and paper, they probably lost jobs, but it created more jobs in computers, right? Same thing now. We may lose jobs in programming, but in just writing code, but we may get more jobs in AI, blockchain, Web3, all those new technologies coming out. And Copilot doesn't know anything about it because these are new technologies. Copilot only knows based on old data, right? So there are always the jobs are always there, but you have to continue evolving. If you're just stuck in old ways and just writing same way, then yes, time is coming that you may not have a job.
Well, I gotta pull up my socks then. Ivan says that is important because developers need to learn to use prompts and these new technologies to stay relevant and competitive. How
Yeah,
about this?
that's
20
very
years down the lane, people look at us and they're like, okay, these guys were learning how to write prompts just the way we would think people were learning how to Google, right?
yes, exactly. So Google is, you can type simple, or you can be smart, right? Then
Yeah,
when more smarter question you ask, prompt, better answer you will get.
that's
That's how.
right.
Yeah, so prompting is new programming language for basic programming.
Yeah, that's
uh,
right. We'll take one final comment from Mohammed. He says, I use ChatGPT for creating project from scratch. It could be used also in place of Copilot if you want free code. Yeah, I think
yeah,
I'm the same.
that is true. The only challenge is that Copilot is more up to date. I think
Okay.
Microsoft updated, even though it's using some of the open AIs. But ChatGPT, on the other hand, you have to be just careful that what version of that language or framework or library ChatGPT is using. You can also confirm that, right? So you always want to make sure that if it's generating code, it's at least not too old code, right?
Mm-hmm.
um, it's think like Google. If you go to Google and search something, how do I build a or format a concatenated string, you'll get all these 20 articles. You have to make sure which one article is really latest and good for you, rather than just picking the first one. So this part is a little bit, you have to make sure those things. And it's up to you, like what project you're working on, and when you get the code, make sure that this code is also matching your guidelines and your style and your naming conventions and all that what Sean just showed you. Yeah.
Mm-hmm.
Mhm.
All right, that is it. So I think Sean from behind the scenes says the more knowledge you have, the better AI gets as a tool. That's right.
Yep. All
All
right,
right,
guys,
with that,
thank you. Yeah. Thank you
yeah, thank you
everybody
so much.
for
Yeah.
having me. Thank you, Simon, appreciate it. This is good. I will still be watching and looking forward to see the upcoming speakers.
All right, thank you so much, Mahesh, and have a nice day ahead.
Thank you.
All right, ladies and gentlemen, that was your keynote session, both by Mahesh and Sean. Mahesh did had a nice demo, followed by Sean, both on the GitHub Copilot. We now move to our next session, which is by Matt. He's the founder and CEO of SEMA, and today he's going to talk about Gen AI. We cannot get over from AI. I think this is the fourth, fifth session about AI. Everybody loves AI. He's going to talk about Gen AI code transparency, why it is important to know how much Gen AI code coders are using. Very interesting session title. Ladies and gentlemen, let's welcome for the very first time Matt to the Code Quality Conference. Hi, Matt. Welcome to the Code Quality Conference.
Thank you so much for having me. Is my audio quality okay? Do I sound all right?
Yeah, you are loud and clear, right? No problem with that. Your video feed is perfectly fine. I'm a little curious about the poster that you have on your side. Is that a car? Is that a radiator? What is it?
Oh, it's great. It's a very inspirational. So this is a car's radiator, and it says, it's a quote from Henry Ford. If I had asked people what they wanted, they would have said faster horses.
Ooh,
Yeah, it gives me
very deep. That's
goosebumps.
very
Yeah,
deep.
like you
Yeah.
can't, to be a good product, to be a good innovator or product leader, you have to really think about the problem to be solved, not how do they solve the problem today. It's a non-obvious one.
Wow, that's a great way to start your session, Matt. I'm already really excited. Matt, I won't take much of your time. Please feel free to go ahead and share your screen. At the bottom of your screen, you'll find a button that says present. If you click on it, it will say share screen, and then you can
Just
click
regular
on
share
entire screen at the top and select the screen and then click share.
Entire screen. All right. Let's do this. So I don't see where it's letting me. Oh, here we go. Entire screen. Here we go.
Yeah, I see your
Is my screen
yes.
visible now?
Yeah, and Matt, maybe you would like to click on that hide link.
Perfect.
Yeah. Perfect.
Okay.
Everybody else can see your screen, Matt, and next 45 minutes is all yours.
Wonderful. And just a quick housekeeping. The way all I see on my screen is the presentation. Is there a way for me to see? Are there going to be? If there's going to be questions, I would really encourage you to just shout them out to me, and I'll handle them. Right now, I'm just going to see my screen itself.
Copy that. Sure.
Wonderful. Well, I am so honored and delighted to speak with you today on a topic that is very near and dear to me. And if I heard it correctly, we're just talking about we're all talking these days about using generative AI both to advantage ourselves as coders, but also to help organizations. I'm here today to share a little bit about really the organizational view of how major organizations around the world are thinking about the use of generative AI code. And in particular, what they're looking to do is to understand how much Gen AI code is used. And so that's what I mean when I talk about Gen AI code transparency. It's knowing how much Gen AI is used, where in the code and how much, because there's some benefits and some risks depending on how it's used. So we'll go through this presentation, really looking forward to hearing your questions at the end. But again, please feel free to jump in and Simon will share them with me. A little bit about me. Some of you have at least heard of the programming language BASIC, which is what I learned a long time ago on a very, very, very slow computer, although it was fast at the time. I've had the great pleasure of serving governments, investors, and operating companies over the last 25 years on technology and strategy. For the last 7 years, I've led the company I founded, SEMA, which is built to make tech understandable to non-technical audiences. We saw a real gap. Technologists understand the code and can talk to each other, but when it comes to chief executive officers who are not technical or boards of directors, it's really important, I'd say, for individual careers, as well as you go up the career ladder to be able to explain tech to those non-technical audiences. We started working on understanding Gen AI code composition about a year ago when two major clients of ours from our first product asked us to start building it. We're talking about product market fit. It's really an honor when your current clients ask you to build something new. But it also gives us a grounding in why this matters to them and what is it that matters to organizations about Gen AI code transparency. And finally, a little about me. I have 3 great kids. We're a very arts and craftsy family. In the bottom right, this is a picture. You all know what sushi is, a tradition we've done for more than the last decade. We make candy sushi out of marshmallow peeps. They're really disgusting. I would not recommend eating them, but they're a lot of fun when marshmallow peeps are around. So let's jump in. We're going to talk about 3 questions today and answer them for you. So hopefully by the end of this, you could do a pretty good job explaining the answers to these 3 questions to anybody, technical or not technical. Question number 1, what is Gen AI code transparency? We talked a little bit about it already, but I want to give you some nuance. Question number 2, why should I, as an engineer, care about Gen AI code transparency? And then question number 3, how does it work? I bet many of you are already thinking about that, and you've seen discussions of the accuracy or lack thereof of detecting Gen AI human writing versus Gen AI human language writing versus human language writing. Thankfully, it's a little bit easier on the code side, but we're engineers here, so we'll talk about the how. Simon, just a quick check because I can't see you. Is this the right pace? Am I still sounding okay?
Perfect, and your pace is all right.
Perfect. Well, let's get in. Part 1. Even before I do that, part 0, I want to make it incredibly clear how supportive Gen AI SEMA is of using Gen AI coding tools, whether it's ChatGPT or Copilot. Some tiers of those tools are better in certain circumstances. If you're using it in a corporate setting, you really want to make sure you're using an enterprise grade level of it. But basically, we think there are two categories of reasons why we like Gen AI code usage. One is it's good for developers. The second is it's good for overall engineering productivity. So for the organization benefits as well. And I know almost all of you have tried it. If not, I really encourage you immediately to start playing with it because it is the future of coding. And not just for that sake, but as folks who use it, they will tell you it helps avoid mundane work. It helps experiment faster. It enables you to have a real-time code reviewer who's not always going to be right, but at least there with you as you are coding. So the overall satisfaction is that it's much higher for coders using Gen AI than without. It also substantially increases engineering productivity. We estimate there's probably a 40 times return on relative to the cost of buying a license to the benefits for the organization. So if you're working in an organization and they have not bought you an enterprise license, please send them this presentation because it is really good for the business, and the business should want you to be using a really high grade tool, maybe even more than one tool. Some companies buy licenses for more than one product so that developers can use them in different circumstances. So we are big fans of Gen AI coding tools, and I wanted to be very clear about that. We have become experts in this newer field of AI code transparency. So what do we mean by that? There's really 2 parts. Number 1, it's distinguishing code that originated with Gen AI tools. They could be generic like ChatGPT or specific to coding like GitHub Copilot versus originated not Gen AI. So everything else that didn't come as a result of a prompt is not Gen AI. It could be written by the team. It could be open source code. It could be auto-generated code that came from a scaffolding or other framework code that wasn't human written, but it didn't come out of a prompt. And the real question that is on people's minds is, did it come out of a prompt or not? Which is why it's Gen AI or not Gen AI. I'll come back and talk about auto-generated at the end, because that's one of the things that makes it hard to detect easily. Second part is, once we've decided it's Gen AI, we want to distinguish between Gen AI that was unmodified, that came straight from the prompt. We call that pure Gen AI, or did it get modified by developers after the fact? And we call that blended. And as we're going to see through this presentation, blended code is much safer than pure Gen AI code. I'm going to pause for a second. You've probably almost all of you have tried generative AI coding tools. I hope you have. Maybe some of you are skeptical, and maybe some of you are skeptical because you're wondering if you really are a real developer if you're using a tool like this. We've certainly heard that as we've interviewed coders around the world. I don't know, am I cheating if I do this or not? And when people think that, there's nothing wrong with that, and frankly, it's to wonder about that. And we applaud you thinking about what does it mean to really respect your craft. I have a very simple answer. Replace the phrase Gen AI code with open source and see what your answer is. So let's go back to this. Does using open source code increase developer job satisfaction? I'm sure you would say yes. The idea of rebuilding frameworks or rebuilding modules or libraries that already exist, when you know there's a simpler answer, it's much more satisfying to use an open source answer instead. It also, if you think about it for a moment, open source makes developers a lot more productive in that you don't need to build the front end framework. You can just have one and then add your customization to it. So we know that open source is almost universally adopted. You're already using a tool that makes it easier for you to code and focus on the parts that only you can do. And there's such a value in that. That's true for open source, and it's true for Gen AI code as well. So if anyone says, I don't know if it makes me real, if I'm not sure if I'm a real developer because I use it, ask to use open source, it's really the same thing. There is, however, one really big difference, which is why I wanted to bring this back up, between open source and Gen AI code. As you hopefully know, if not a quick refresher, for open source code to be the safest, what you want to do in all situations, or almost all situations, is not modify it. You want to reference the most recent version. You want to keep up to date with the most recent version. One reason for that is the code's maintainability. Another reason is the security. Open source code has security vulnerabilities that are publicly known called CVEs, and staying up to date with the most recent version helps you achieve those. Helps you automatically fixes the errors, certainly the vast majority of them, the security errors. And so for open source code, you do not want to blend it. You want it to stay pure. Gen AI code is the opposite for reasons we're going to get to. And so you want to think about Gen AI code similar to open source, with the exception that you really want to make it yours. You want to blend it because it becomes safer for a variety of reasons. Okay, so we've talked about what is Gen AI code transparency. I'll just give you a really simple example from our own company. This is, so we have two products. The newest product is AI Code Monitor, which detects the amount of Gen AI code in a code base. So this is the application it's from. Scoop is our first product, which has been around for 7 years and it's a code scanning tool. It's the right way to think about it. We also group some of our code into, it's still part of Scoop, but we haven't modified it in the last 3 months. And so this is looking at sort of an application level. This is an application, and these are two parts of the application. How much Gen AI is there? If I use this number in the sentence from the AI Code Monitor, 18% of the code originated with Gen AI, That means 1 minus 18 is 82. 82% did not originate with GenAI. And then of that 18%, at least 8% is blended, and meaning it was modified at least somewhat. We know that as a minimum. Up to 10% is unmodified. For Scoop, our older product, and I should say this is all code all time, there's much less GenAI code in it. 98% of it was generated without any GenAI. Now, you might already be coming to a conclusion about whether one of these is better or worse. It's okay to be naturally curious. At SEMA, we love, we build code metrics for a living. We love asking questions, but we really try to be curious before we're judgmental, because code is a craft. It's so contextual to know what is the right answer in any one circumstance, and there may be extenuating circumstances before you can come to a conclusion. So we like to ask questions rather than judge. And so a question here could be, is there a good reason to have a lot more GenAI code in the AI Code Monitor than in Scoop, our first product? And if I could do a poll, I'd see if any of you can think of a compelling reason. But since I can't, I'll just tell you, there is definitely a good reason. And that reason is the AI Code Monitor has been 100% created in the last year. And in the last year, GenAI coding tools have been available. By contrast, Scoop is a very stable product. Almost all of it was built before GenAI tools became around, and so most of it didn't have an opportunity to have GenAI in it. And so there's always a story about data, whether it's GenAI code or not. And so we lead with inquiry first, and I really encourage you to do that as you think about data about code. So we've covered what is GenAI code transparency, our first question. Second question, why should I care? And I'm going to say to you, you may or may not care yet, but the organizations you're a part of and organizations you might be working for today or might be working for in the future, many of them already care. And I know you'll remember this conversation. In the next 6 to 24 months, everyone will care about knowing how much GenAI is in the code base. So consider yourself on the cutting edge by being here for this presentation. I'm going to start this section with a news story that came out last Friday. So Axios is a major tech publication in the United States with a global reach. When AI code, produced code, goes bad, the same generative AI tools can produce flawed, potentially dangerous code. It matters, of course, because generative AI code is touching so much. So it's beginning to seep into the consciousness that while it's an incredibly good idea to be using GenAI for coding, it also comes with some risks. This article, in fact, if you read it, points out 2 of them. There's really 5 categories of risks. And all 5 of those risks are reasons to know the composition. Because if you know how much GenAI code is used and where it's used, you're then more likely to be able to address it. The 5 are the quality of the code. So GenAI code may be lower quality, for example, because it's hallucinating or not giving appropriate context. Second, GenAI code comes with security bugs. By the way, all code comes with security bugs. There's nothing against that. You just need to take precautions to find them and address them. Not using, so here's a risk, and this is again from the organizational perspective, but we would say if developers aren't using GenAI enough, they're missing out on opportunities for greater job satisfaction and for organizational productivity. Again, imagine if developers weren't using open source and how much less fun their work would be. So measuring it helps make sure that we're getting to the right level of developer productivity. The fourth risk is that some uses of generative AI at work, code or otherwise, create some intellectual property risk. And like I said earlier, it is a must-have if you work for a business, for that business to give you an enterprise-grade license. Almost all of the Gen AI products have one, but you need it to protect the organization's code, because if you're not using an enterprise grade tier, your code can be used as part of training data. And so you're basically giving away organization secrets. So please, if your company hasn't approved a license, send them to me and I will explain why it's just a must-have for the safety of the business. We don't care which tool. It just has to be a tool with the right protections. The last risk of the 5 is something we call exit risk. And so that exit risk refers to generative AI code being a risk when someone's trying to sell the business or take investment in the business. And so the process of looking at the code during a sale or potential investment is called technical due diligence. And leading investors around the world are already looking at how much Gen AI code is in the code base. And under certain circumstances, it could be harder to sell the business. So that is a very, very, very high stakes decision for the owners and investors of a company. And so if as Gen AI code composition becomes part of the due diligence process, becomes even more important to understand it along the way, how much your composition is. So those are the 5 categories of reasons. You're now you're among the experts on earth, because this is such a new field. Even a fancy article, fancy publication like Axios only thought about 2 of the 5. You now know all 5 reasons. Remember at the beginning when we talked about the big difference between open source and Gen AI code is that for open source, you do not want to blend. For Gen AI, you do. I'm just going to say this briefly because I bet getting to questions is more fun. But basically, every risk is reduced by developers taking the code coming out of the prompt and customizing it, modifying it for the circumstances, making sure it's correct, putting it through security gates. And I think we're just talking about this quality gates right in the previous session. We want you to use it. If it's up to us, we want you to use it, but Gen AI, but we want you to make it yours and really make sure it is correct, secure, contextual. Lastly, just a little bit, and then we'll go to questions because I know it's always more fun to have the discussion. Some people may wonder, how on earth do you detect Gen AI code? Just in case the segue wasn't clear, I talked a little bit about detecting human language use of Gen AI code. So plagiarism detectors, you think about that refers to folks passing off work as their own. And there are now plagiarism detectors that are looking for, is this paper for school, was it written by a Gen AI tool or was it written by a human? Plagiarism, another way of saying that, is Gen AI detection of human languages. And what SEMA is doing, and folks in this space are doing, is Gen AI detection for computer languages. When you say plagiarism, you're looking for it because you don't want it there. And so the goal, of course, in the academic settings is to not use Gen AI where it's not approved. In this context, there are a few circumstances where Gen AI should not be used. And so the detection is about not using it. It's all based only on company policy. Sometimes companies say, we just don't want this part of the code to be using it. But the vast majority, to be using Gen AI, but the vast majority of situations involve, it is appropriate to use it, but how much is it used and how much is it blended are the really important parts. In order to detect Gen AI code, so just a little bit of our secret sauce, we have an AI model that is a deep learning model that is trained on Gen AI code and not Gen AI code to create predictions about whether the next token is going to be Gen AI or not. We then add to it a blending calculator to decide if certain code was modified by developers or not. And again, I'll say just a little bit about this. In order to detect Gen AI code, to use a detection engine, you can't just feed the whole thing in as an entirety and say, is there Gen AI in it or not? I guess you could, but it's not interesting to say, if you think about 100,000 line code base, yes, no, was there Gen AI in it? That's not so useful. You want it to be as a granular unit as possible while still being able to have an accurate detection. And so that process is called chunking. There's an art and science to getting the code that's being evaluated just the right size. That's what chunking is about. The way that we train the model is, you have Gen AI code and not Gen AI code. Gen AI code we synthetically generated by feeding instructions into a Gen AI tool and asking it for code, doing that at scale, obviously. And not Gen AI code, we picked examples that came from before Gen AI tools were in commonplace, so using slightly older code. Last thing I'll say about blending is that we have a very simplistic model today where we at least understand if there's been more than one commit. What's going to be coming in the years ahead is more and more sophisticated ways of measuring it, but we wanted to start somewhere. Two things, and then I will stop. Three things, and then I will stop. If you decide that you care as an organization about Gen AI code composition, we think there's two more things that it's not enough to just look at it at a dashboard view. You have to make it easy. You have to make it more useful. One way to make it more useful is for developers to have Gen AI code detection when they're doing code reviews. Almost all of you are familiar with seeing quality gates or security dates during the code review process. It's just a magical way for code to get better and coders to get better. And so Gen AI detection code detection should also be at that stage. And then the other, because there's all these high stakes decisions like, am I going to pass diligence or not? There's this notion of attestation, which means humans going through and either agreeing with or overriding whatever the label was about Gen AI to detect, to come up with a permanent record of how much Gen AI is in the code. So you'll be hearing a lot about attestation, and you'll probably have to do it with some of your companies in the years ahead. Before I stop, there are several ways to learn more if you find this topic interesting. We have a whole bunch of blog posts. Simon, I'm sure you're going to post this as a PDF. So you can find the blog posts, cmosoftware.com. If you are an engineering manager or a CTO, engineering managers and up, we have AI advisory councils. Feel free to drop us a note and say if you're interested, free of course. And if you'd like to try it out, the AI code monitor that we saw today, if you use GitHub or Azure DevOps, we're offering 2-week trials. I think that's it, Simon, for the presentation. Should we do questions?
Wow, that was great. Very crisp to the point. I really loved it, Matt. that was a very good session. Okay, let's take a few questions. Mahesh Chen, who's the founder of CSharpCorner, he's saying, this is a great talk, Matt. Curious if you have come across any company that has asked many Gen AI related questions, and what kind of questions, if any. Thanks.
Yeah, so Mahesh, I'm going to try to answer it. If I get it right, great. If not, feel free to write again. So CIMA does two things. The AI detection is our second product. Our first product, this code scan product, is for technical due diligence, that process of evaluating companies during tech companies during a sale or investment. Major investors are currently asking in diligence, how much Gen AI code? Do the developers understand it? Is it in the right parts of the code? Is it too little? Is it too much? And so those are all now part of not every diligence, but many diligences. They're already coming out. And organizations are, I don't want to say struggling with, or maybe wrestling with, how do we encourage a new tool that is very effective without telling developers how to do their jobs? Because it's so annoying, as we all know, to have a new tool force down their throats. Hopefully that was responsive, Mahesh. If not, please feel free to ask another question.
I think that was great. He'll definitely follow up. Let's say candy sushi was a thing. I didn't
That's
expect that
exactly
in
it.
the
Yes,
session.
candy sushi.
How does it taste?
It tastes terrible. Oh, it tastes terrible. It's Rice Krispie. I don't know if you've had Rice Krispie treats. It's marshmallow mixed in with Rice Krispies, and then a peep is a marshmallow, sugar. In the United States, it's there during the spring months for around Easter, and so that just tastes like raw sugar. And then you put fruit roll-ups around it for seaweed, and that tastes like fruity sugar. So it's the most. My kids eat them. I just play with them.
Okay, yeah, they look good in the picture, I would say that. Let's take a question from Rohit. He's asking, what tools or methods do you recommend for for accurately tracking and documenting the use of Gen AI generated code in a code base?
Yeah. So
Is
great
there any
question,
tool if you use
Rohit.
any?
Yeah. So the GitHub Copilot API has
Mm-hmm.
at least the total percentages of how much Gen AI is being used, at least coming from Copilot. Now, people could be using more than one tool, but at least the top level stats are available from that. Other than that, the answer today is to find a tool that, well, I guess you have two choices. You can keep track of it by hand and put in a comment, I use Gen AI here or not, or you can automatically look for it, use software to automatically look for it. We definitely recommend, no surprise, using software to automatically look for it and then override that decision if you don't agree with it, because it would be so time consuming to manually track. There are a couple companies who are working on this. Of course, we're one of them, but we're definitely not the only one. So if you're thinking about this, feel free to do your research and see if there's a tool that's right for you.
Perfect. I think that's very well answered, Matt. Let's take one more question from Gaurav. He's asking, what are the potential risk of not having transparency in the usage of Gen AI generated code?
Gaurav, I'm going to ask you
Yeah.
that question. You promised me, all of you attendees promised me you would know the answer to this. Remember, there are five risks. One is the code may not be sufficiently maintainable, so there's a code quality risk. Second, the code, it may not be secure. So imagine, Gaurav, if you were looking at code and you saw it was all pure Gen AI, no human had modified it, that tells you that it could be the case that there were no security bugs with it, but more likely there were security bugs and nobody addressed them. Now, if you're doing a side project, whatever, that's fine. I should say this, you don't need Gen AI code composition for your side projects. It's interesting, sure, but you need it at work. Larger organizations need it. And so having undetected security bugs would be unmodified code is a sign that there wasn't security cleanup. Third, intellectual property risk. If you're using Gen AI in the wrong spots, the company's IP could be lost, which most companies today, number one most valuable thing is the team. Number two is the software, is the IP. There's exit risk, which is the threat that so if you've never gone through this process, I'm trying to think what the analogy is. It's like passing a driver's test or not, except it's 1 or 0. You either pass a test or you don't. But driver's test you get to take again if you fail. Technical due diligence, you might lose billions of dollars. Your company might lose billions of dollars, and you don't have another chance. Or if you do, it's at a substantially different valuation. All right, Gaurav, those were 4. Now I have to remember the 5th that I didn't just say. Most importantly, developer productivity and satisfaction. So companies are doing this so again, now that you think about this, we know companies can know how many licenses people have to Gen AI tools, but without knowing how much are using it, no idea if it's in place, right? Counting licenses is not at all the same thing as counting usage. And so this helps get to who's using it more or less, and how do we help people use it at the right level for their sake and for the company as a whole.
That's very well answered. I really love it. All the answers are to the point, just as it was your session. That's Mahesh actually says, we'd love to have you in our AI conference. We are also doing AI conference. I think you would be the perfect fit for that. There's then one more question from Pravesh. He's saying, can you provide examples of how transparent usage of AI generated code has helped in managing or reducing technical debt? I think you did give a couple of case scenarios, right? In your
So
session.
we had we were debriefing this technology with one of our, their results with one of our clients, and she said, a CTO of a British company, I really hope the team is using all of their Gen AI efforts on the new platform rather than a legacy project, because that legacy project is interesting but doesn't have business value. And she had concerns that developers were over investing in reducing technical debt of that project. She looked at the results. The developers were in fact using too much GenAI on that project, and we're not using enough on the new project. And she used it to help guide the team and remind them, hey, the focus here is we got to make the newer product the best it possibly can be. So that's one example. Of course, SEMA, we look at this. So our engineers, this is not a secret dashboard. We look at the results together. We understand where the riskier parts of the code are to be pure Gen AI, and we make sure that keep pure as little as possible and blended as much as possible.
Okay, that's perfect. Gaurav says thanks.
Thank you,
Matt, very
Gaurav. Great
nice and
question.
reference. Yeah, at least Rohit also says thanks, Matt. What else have we got? What have we, Pravish saying? Namaste from India. I think,
Namaste. Yes.
yeah, I think that is it, Matt. Anything else you want to add? By the way, where are you joining from US? Which city?
I live in Baltimore, Maryland, which is near Washington, D.C., although today I'm in Philadelphia, where the Rocky movie, if you've seen Rocky 1, he was in Philadelphia. That's where I am today for a conference.
Oh, that's great. Mahesh is actually from Philadelphia.
Oh, fabulous.
Yeah.
Small world, Mahesh.
Yeah. All right, Matt, thank you so much. Any final thing you want to add before we wrap it up?
No, I'm so honored. I really encourage you to reach out. No question too big or too small. And if you're at a company that is not buying you a license of the right size, of the right enterprise level, please give them my number, because they are putting their companies, we don't sell that. That's not an advertisement for us. That is a protection for your organization's IP. So please make sure that you use a high enterprise grade tool at work.
Yeah, you sound very committed for that. All right, Matt, thank you so much once again for accepting the invitation. Lovely session, really loved it. Very crisp, as I've said. I'm repeating myself. Thank you so much. Have a nice day ahead, and yes, see you in other conferences that we do.
Many thanks. Thanks, everybody. Have a great day. Goodbye.
You too. All right, ladies and gentlemen, that was a stunning session by Matt. We hosted him for the very first time, and I can't wait to host him once again. We now move to our second final session. Again, for this session, we are hosting James. James is going to talk about code reviews are mostly useless. This is this session is against the entire conference. I'm glad this session is around the second half. I mean, during the second half. It's not like we put it purposely, it's because James wanted time around the same time. That's why. But session is very daring, I would say. James is actually founder and lead instructor of Don't Use This Code. Again, very interesting company name too. So without any further ado, let's welcome James to the Code Quality Conference. Well, hi, James. Your camera was working perfectly fine. Now look at you. My goodness, you're the most handsome speaker we have at this Code Quality Conference. How are you doing today?
I'm doing well. How about you?
I'm doing absolutely great, James. Thank you so much for your time. As you were behind the scene, I was saying, and before you even get started, James, I want to ask you, oh, you have a tea with you. Like, you're all set up. I need some my tea.
It's good to stay hydrated when you're going to share something very controversial that's going to require a lot of spittle flinging out of your mouth and a lot of harsh words.
Oh yeah, you're 100% right. Your session is going to be very unique, just the way your the entire session title is. I'm not going to take much of time. James, Are you going to share your screen, or how it's going to work?
I'll share my screen. And so behind me, you'll see my screen. I'll, of course, hide in the corner here. And
Oh,
whenever you're
wow.
ready.
So you want me to put you full screen?
Sure.
Oh, wow. This is really interesting. All right, James, the next 45 minutes is all yours.
Fantastic. This is code reviews are useless, or maybe I should be a little bit fairer and say code reviews are mostly useless. We're at Code Quality Conference 2024. It's Thursday, June 27th. My name is James Powell. You can follow me on LinkedIn. There's also a QR code that you'll see in the presentation with a couple of links to some of our materials. There's one disclaimer I want to share with you before we get started. First, I'm going to share with you a couple of very strong opinions about the process of code review and how we conceptualize code quality. And where I choose to include examples, they're going to be Python examples. And I know a lot of you are C# programmers, but I think you'll be able to squint a little bit and get a sense for what we're aiming for. Here's the question upon us. Are code reviews a useful activity, or are they completely useless? And it's my view that they're pretty much useless. Here's my proof. I'll start with a little bit of evidence. My first piece of evidence is you've all had this experience where you were part of a code review and the change itself was 5 lines of code long, and people litigated every single minute detail of that code change. They said, oh, in PEP 8, there's supposed to be 2 spaces between class definitions. Oh, you need to write this in this slight way over here. Oh, don't use a comprehension, or do use a comprehension. And it became a long, arduous process. And then maybe a week later or 2 weeks later, you were part of a code review where the change was more significant, 10,000 lines of code. And the response you got was, looks good, okay, fine. And you might think, if code reviews are an actual useful, real process, surely the 10,000 line of code review would be a much more engaged activity than the 5 line of code review. Surely, if we're litigating every single line in a 5 line of code change, then there must be a lot that we can say about a 10,000 line of code change. And yet, in practice, this doesn't seem to be the case. The other piece of evidence I'll share with you is, if we think of code reviews as a process by which we can assess the quality of some code and determine whether that code is ready for inclusion in some production system, then, well, why do we need such a detailed code review process? Code quality is very easy to assess. In fact, I can tell you, in the span of no more than 1 sentence, the difference between good code and bad code, as I have seen this in almost every code review I've been a part of. And you can say the same thing. We don't need books on what constitutes better code quality, cleaner code. We don't need long, detailed arguments. Good code is code I wrote, and bad code is code you wrote. And unfortunately, in a lot of code reviews, this seems to be how it plays out. And so, given these 2 pieces of evidence, I assert that code reviews are completely useless. That's my proof. However, because we're at a code quality conference, I think it makes sense that we should take a step back and we should litigate these points a little bit more delicately. And we should go through each one of these points and really get a better understanding for, well, are code reviews useless inherently, or is it a consequence of the surrounding environment? Why is it the case that a 10,000 line of code review is considered to be a burden? Why is it the case that when you see that 5 line of code review and it's Friday and it's 3 p.m. leading into a 3-day weekend, you say, well, I only got 2 more hours. I might as well cite chapter and verse for all of the things that are wrong in this small code review and really grill the junior programmer who submitted it to me. And yet when you get the 10,000 line code review, you say, it's 3 p.m. leading into a 3-day weekend. Is this really what I want to be doing? Is this really where I want to spend my effort? And you say, looks good, let me just head off early. Well, if it's the case that the code review is seen as a burden, then it's likely the case that's not a particularly useful process. If you're regretting code reviews, if you look at all of the work that you have to do as part of a code review and it's something that you don't look forward to, it's not an opportunity for improvement, then it's probably the case that we're approaching this wrong. If we think about code reviews, and especially long code reviews, as things that require a lot of reading, or a lot of context, or a lot of effort, well, it's definitely the case. 10,000 lines of code, you need to read through every single line there. You need to have all the implicit context of every change that was made. It's a huge amount of effort, and you're left asking yourself, why? What's the point? Well, I think that code reviews are often rendered useless as a consequence of contextual factors, specifically cultural factors in an organization. That is to say, with the lack of a culture of training, a culture of learning, a culture of knowledge, and a culture of quality, it is very difficult to make code reviews a useful practice. Let me go through each one of these one by one and give you a sense of what I mean. So what do we mean when we talk about a culture of training? Well, here's an example. Let's say you have that 5-line of code review, and in that there's 2 lines that look something like this. I said they would be Python examples here. And the person reviewing your code looks at that and says, no, I don't like that syntax. That's too new for me. I really didn't learn Python after Python 3.6, so the equal sign and the F string is something I'm not familiar with. I don't like it. Figure out how to rewrite that. And the exercise turns into one of those guess what I'm thinking types of exercises, which are extraordinarily frustrating. You say, if you don't like the way that I wrote my code, if you're not a fan of the stylistic choices I've made, don't make me guess what stylistic choices you would make. Why don't you just accept it if it's functionally correct and then go fix it yourself? You can submit your own PR with any changes that you want. The guess what I'm thinking style of code review is definitely one that all of us have experienced, the one that we definitely want to avoid. What might be a more pleasant experience is the let me show you how I'd like it to be experience. And if it's the case that the code review isn't well, you wrote the code in this way, but let me show you the style that we use in our code base. Let me show you the practices that we have, or let me show you what constitutes consistency across all of the other code that's been written. Well, maybe that's a better code review practice. They might say, you know what? Instead of that comprehension, write this as a for loop in this formulation. Saving yourself 1 line of code really doesn't benefit anybody. And just using syntax because it's there is definitely not a benefit. However, what's missing here is the culture of training. When we see things in a code review, we really need to use these as an opportunity to train, especially junior programmers, in what is acceptable within our organization, what approaches that we want to use, and how to use these tools better. A better form of code review should be, let me explain to you how I'd like it to be done. Let me explain to you the foundational concepts for why it is the way things are done the way they are. And so in the case of this 1-line complaint, we could say, well, you know what? If we think a little bit about how Python works, a comprehension is supposed to express to the reader of this code that it's building something. In this case, a list comprehension builds a list, whereas a for loop is to express to the reader that it's performing an action. And if we think about the change that you had, you were printing things to the screen, you're not building something, you're building a list of none values. Nobody wants to use that. You're actually performing an action. And through this explanation, we can share with them not only why it is that the code that they've submitted is unacceptable, but also what they can do to generalize that learning to make sure that they approach the problem better next time. Instead of always trying to guess what it is you want until they've figured out how to mimic you, they can understand the core principles that you're using in order to deliberate whether this code is good or bad. And if it's the case that such principles do not exist, maybe you're just nitpicking. And maybe it's the case that as part of the code review process, you shouldn't really be nitpicking these small stylistic details. Now, some of you might try to take it maybe a little bit of a step further and say, oh, well, in an even better organization, could we make this a discussion where we discuss how something should be done rather than having the code reviewer explain to the person under review? And unfortunately, I do think that that is likely to be unrealistic, especially in the case of junior programmers. It is very much the case that as part of a code review process, we are establishing that there is some hierarchy. There's one person who reviews and one person who is being reviewed, even in the case of a peer code review. And it's very likely to be the case that if it's a junior code review, well, the junior might be missing some of the important context or this important perspective. It's often the case that we see junior programmers will say, oh, you know what, let's just fix everything. And you say, well, hold on a second. We tried that 10 years ago. That's not quite the direction the business is taking right now. There's a lot of details that they may need to know in order to be able to effectively process what something should look like. And so I think it is appropriate, even within a culture of training, to still be a little bit prescriptive about this is what we want, rather than having to make every single part of this a discussion, since it is unlikely that some code reviews would actually be able to turn into a discussion where both sides have equal say in how the code will look. Now, there's some cases where, when we take a look at code reviews, we can see that there's a lot of nuance that needs to be added there. And this is important in that culture of training. The reason we want to train people is because we don't want them to just memorize formulations we like, or to rely on standards documents. Oh, it's already documented here. This is how we write our code. Because, for example, if we rely on PEP8, which is largely and erroneously assumed to be a standardized way to write Python, it's not. It's how Python largely should mostly be written if you're contributing to Python itself or the Python standard library. It will give us some guidance where that guidance is wrong. For example, PEP8 says if we want to determine if a structure is empty or not, we shouldn't use the first two formulations, checking the length. We should use the last formulation, just converting this thing to a Boolean value. But this is actually bad advice, because if we have a list, yeah, sure, this if clause, the code contained within, will be triggered if this thing is not empty. But if we have a NumPy and D array, this code's going to break. It's going to raise an exception. It's going to tell us that the truth value of an array with more than one element is ambiguous. The guidance that PEP8 gives us is not correct guidance in this case. In fact, one of the other formulations would be more nearly correct. Now, as you can see, we're beginning to enter a very delicate territory because there's an enormous amount of nuance to this. If we think about the difference between a list and a NumPy and D array in Python, well, a list is some potentially nested grouped collection of elements, whereas a NumPy and D array is a mathematical structure. So if we go back to this area of disagreement in our code review, is PEP8 the guide that we want to stick to or not? And we say, well, this line of code here that's following PEP8 is asking, does this list, this container of entities, have any stuff in it? Whereas if we already have an NumPy and D array, this is asking, if this were to work, does this thing have dimensions? That's not a very meaningful question to ask for NumPy and D array. And of course, any subsequent operation that we perform on that NumPy and D array will not broadcast. Obviously, the broadcasting rules won't let you broadcast against something with no dimensions. And so it's unlikely that you would see code that looks like this in generalized numerical computing, analytical, or machine learning code. And so the nuance here is, PEP8 is wrong strictly, but it's actually mostly right in terms of how we use these things. And no simple sloganeering, no simple one-line message, write it this way, is going to be able to provide that context and that opportunity for growth for somebody who's under review. This context is important to how we do our work, and it makes everything that we do in our work much richer. It makes our understanding of the problem domain and the tools that we use far greater, and it allows us to use these tools more effectively in terms of using them in a more efficient way and also using them in a more precise way. And in a culture of training, we have that discussion. We have that larger context of, well, why is it the way that we might do these things? Now, in some cases, we may cut it short because we don't want to spend 2 weeks teaching somebody every one of the necessary details behind why we do things in one place. In some cases, we might simplify these, but we should always have some willingness to kind of say, okay, this is why things are the way they are. I'm willing to show that to you. And we might then simplify these in the form of general guidances, but we shouldn't confuse those guidances for the training process. We might provide a guidance like, well, library code in which the user, out of convenience, might provide an NumPy and D array that represents a collection of elements, should be handled slightly differently than library code, which uses a NumPy and D array as a mathematical structure. And in some cases, we might go against PEP8. In other cases, we might not. And through that context, even if those lines of code find themselves excised from the code base one pull request later, the code review process is still a very useful one because both parties have had an opportunity to communicate or to learn more about the underlying technologies and the underlying system, irrespective of whether the code that they've written is code that will be included in the final product or not. Other guidance you might provide is to be aware that EQ may not compose with bool in Python. And these are cases where you might give somebody some guidance on errors that they might see. For example, if you had some code like if x's equals y's in Python, you didn't know what x's and y's are, which is very much a library concern, not really a user code concern. Well, this is actually strictly wrong. And in fact, you even see this incorrectly in the Python standard library, cases where you might, for example, try to create an enum value that represents cardinal directions, and you might want these to be the offsets in R squared. And if you try and create an enum where the values are NumPy and D arrays, somewhere in the code you see something that looks like this, and you get the truth value of an array with more than one element is ambiguous, use any or all, and it breaks. I actually brought this up to a Python core developer, and they gave me the feedback that NumPy is wrong, let's go change NumPy. And this is why in some cases we may need to be willing to have the conversation, but also say, well, hold on a second. We're not going to rewrite NumPy. NumPy was created now almost 18 years ago. It's very unlikely that we can make such a substantive change. And with the perspective of knowing that these tools are so widespread, we have to sometimes just accept that things are the way they are. But we should never shy away from part of that culture of training people to at least give them a little bit of context and a little bit of understanding for why things are the way they are. So what is a culture of training? Well, a culture of training is instilling in people a sense of deliberateness, that the actions that we take are deliberate choices. We're not just writing the code for the sake of writing the code, but we make choices at every single line of code that we make, and there's some reasoning behind it, even if it's the case that we don't relitigate that reasoning every single time, or we don't explicate that reasoning every single time. It is a willingness to share knowledge. Understanding the code review process is an opportunity for you to share knowledge. It's a training opportunity for you to work with your colleagues, even in a peer code review, and to share with them why it is that things are the way they are. It is not an opportunity for you merely to denigrate or to say, this code's not good enough, try and make it better, make it as good as I want it, make it to my satisfaction. A culture of training is seeing that code review is a mechanism, and one of the most important and most common mechanisms by which we share this knowledge, and hopefully capturing and recording shared knowledge in a code review. This is one thing that you can see from failed code review processes. Well, does anybody ever go back to previous reviews and look through them to understand why decisions were made one way or the other? If it's the case that they don't, then it's likely that the code review process is useless. Now, let's talk about a culture of learning, because here we can see another place where cultural misalignment will lead to a code review process that is not particularly useful in your organization. Here's an example. I do a lot of corporate training as part of my work. We do a lot of consulting, we do a lot of corporate training. And as part of corporate training, especially in Python, we want to teach people not only how to use Python, but how to use Python the way that it was designed to be used. Unlike many other tools that are very non-opinionated about how they're to be used, C++ is a great example. Every organization uses their own unique subset of the C++ functionality and says, these are the things you should use, and then these are the things you should never touch. And then the next place you work on a C++ code base, they reverse the things you should never use and the things you should always use. Whereas in Python, it's a much more holistically designed language, and there's a particular opinionated way to go about using Python. And being a good Python programmer is understanding that that way is relatively consistent across all uses of Python, or at least all good uses of Python. One case of that is encouraging people in Python to use iteration helpers. So you provide them with some code that looks like this, that's looking at some values, and it's looking at these values piecewise. It's trying to determine what's the pairwise difference, from -2 to 94, that changed by 96 from 94 to 7. And you ask them, is this code readable? Is this code understandable? And maybe they might say, well, not really, but I can rewrite that code very slightly. I can make the code look like this. And so it's a little bit easier to see that we're looking at previous values and current values offset by 1, and we're looking at overlapping windows. But what you really want to teach them is, well, in Python, there are iteration helpers, things in the built-in like zip and enumerate, or things in the itertools module. And instead of all of these other contortions, we have direct ways in which to write some code that very, very clearly expresses the idea. Look at things in overlapping pairs. Look at the previous value and the current value, then the next previous value and the next current value, with all of that, without all of that administrative noise of managing that loop state. Now, when we show that to people, what often happens is, we ask, is this better code? And by a metric of how many lines of code it is, it's shorter. But a lot of people very legitimately say, you know what, the earlier formulations are what I'm more used to from writing code in C or C++ or Java. I've never used iteration helpers. It's a very Pythonic approach for solving problems. And as a consequence, I'm a little bit more comfortable with the other approaches, even if maybe you're saying that they're not better. In fact, we even get feedback that says things like, yeah, sure, that's great. That's the way to do it in Python, but I kind of have to know what itertools.pairwise is and that it exists. And as a consequence, well, we try and say, well, if you're learning about Python, then you ought to learn about Python, and this is the opportunity for you to learn that these things exist and how to use them. And I share with them a very genuine rubric that I use for determining what I should include in my code, and for answering that question of, is this code too complex or not? Is this code worth putting in front of a junior person or not? Because, anytime somebody says to me, I don't use fancy features that my coworkers may not know, maybe they're all junior, that feels too wishy-washy and too subjective for me to really be able to say, oh, this is code that's acceptable and this is code that's not acceptable. And so I understand, because originally when we showed this examples, itertools.pairwise didn't exist, so we showed this to them in the context of an n-wise that we constructed ourselves. And we get where, if you actually have to look at how all of this stuff works, it gets a little bit confusing. But I think in a code review, complexity can be boiled down to a fairly simple rubric that we can litigate. I think that what's fair game in code is anything that takes me less than 90 seconds to explain to somebody, or takes me less than 5 seconds to explain to somebody, or takes me less than the space of one cocktail napkin to write out an explanation. And if I can explain something under under these 3 restrictions, then maybe it's at a sufficient level of complexity to be included. And maybe we can remove the subjectivity of an argument, is this too complex or not? And in the case of itertools.pairwise, I can do that. Itertools.pairwise looks at something you could iterate over in overlapping windows. Here, I could write this on a cocktail napkin, and I can explain this in 2 sentences and 30 seconds what it does. But if we think about the generalized problem lurking behind all of this, what really seems to be the case is a lot of people look at code and they say, I don't like that code. And in my code review, I'm going to express my displeasure on this code. I don't like it. It's too complicated. They might even pejoratively say it's stupid because it's too complicated. And I know they might say that because I know I've said that before. I've looked at some code and said, oh, I hate this. I hate this with all of my being. It's far too complicated. But what I really meant was, I hate this with all of my being because I don't already know it. I hate this with all of my being because, well, I'm not getting older. I sure am feeling older these days. And I'm actually kind of scared of being left behind. I'm scared of being confronted with things that I don't know and I'm not already familiar with. I'm used to the way that Python used to be written 10 years ago. And I'm kind of scared because the ways that people are writing it these ways are very different. And I know that happens because it happens to me all the time. Well, when we think about a culture of learning, distinct from a culture of training, this is one of the important and critical aspects of an effective code review culture. Specifically, a culture of learning is understanding that learning never stops. I know every single day, I might not look older, but I feel older. And I understand that, for all of the years that I've spent learning all of my tools, it could very well be the case that tomorrow Python goes away and I need to learn Rust. Rust goes away and I need to learn Zig. Zig goes away and I need to learn the next thing. And I should be aware of and come to terms with an idea that the learning never stops. It's a consistent thing. It's a constant thing as part of our work. That there are things that I'm not going to know. And it's okay that there's things that I'm not going to know. And there's things even within my area of expertise that I won't know. And it's a very human thing for me to, especially with my coworkers, kind of brush off and say, oh yeah, that was added recently. Oh, yeah, I knew that, even if I didn't know that. And that's a human failing. And it's a fault that I am aware that I have. But it's something which, when I take a step back and I say, well, you know what? I'm not going to know everything. There's always going to be some detail I don't know. This is an opportunity for me to learn something new. A culture of learning is understanding that the learning process is not always easy, even in fields where you have expertise. It can be very difficult and it can be very intimidating, but it's worth doing no matter what. In fact, if we think about it, continuous improvement, continuous learning is our responsibility. It's worth doing no matter how difficult, how intimidating, even though it's something that never stops, and even though I'm only going to discover more things that I don't know. In fact, some people may go so far as to say that learning is above all other human pursuits, that it is the greatest human pursuit, and honestly, I wouldn't go that far. I would, however, say that knowledge and the search for knowledge is genuinely above all other human pursuits, which leads us into a culture of knowledge. And one thing that is critically missing, and unfortunately one thing that, unlike a culture of learning and unlike a culture of teaching where we can try through some deliberate process develop these, the culture of knowledge is actually quite difficult to instill in an organization if it's not already present. Here's what we mean by a culture of knowledge. Well, one of my biggest pet peeves when we're talking about design decisions in a design or code review is when people say things like, it's a series of trade-offs. Okay, yeah, but what in life isn't a series of trade-offs? Everything's a series of trade-offs that added no knowledge, no information. Or when they say, well, use this feature under these circumstances, or you say, when do you use a generator versus a generator coroutine versus some other feature in Python? And they say, it depends. And I'm just thinking, yeah, it depends on what? The knowledge here is giving me some guidance for how to methodically apply some theoretical constructs to reach an end goal, not to just give me some pat statement saying, well, I don't know, it depends. Sometimes it's this way, sometimes it's the other way. And carving out within what is oftentimes a wholly unknowable field, the regions of knowledge that we can find. Another thing that is a humongous pet peeve for me is when I see circumstances where people are relitigating in the sense that it is an interesting, controversial questions that are ultimately and utterly meaningless and are in fact not controversial and not particularly interesting, but are instead almost and completely obvious in their answer once you understand some foundational theory or some foundational knowledge. I recently saw online some people going back and forth on should they parse the output of ls in a shell script, and I just saw, This is hours of human effort, and the answer is so blindingly obvious. This is not an interesting or controversial question that should be getting that much attention. It's really just a understanding of the core concepts and then application of those core concepts, and then we move on with our life. But to give you an example, I want to show you a little bit of code that I was looking at recently, a representative example that came up in some code review that has an enormously subtle bug. This is one of the most subtle bugs that I've seen in code in a while, and probably the only case where we would make use of a fairly recent feature that was added in, I want to say Python 3.7 or 3.8, that otherwise doesn't have a lot of use cases. You're not going to be able to spot the bug, but you can at least get a sense of what this code does. The person's using some kind of functional programming in Python to write a function that performs or calls another function some number of times and allows you to pass in variadic positional arguments, variadic keyword arguments that are just forwarded through. And the bug here is a design flaw. The first two arguments need to be passed positional only. Because if they're not passed positionally only, then if the function that is then being repeated here contains or has an argument called n, that argument n cannot be passed by keyword or without an ambiguity between, wait, was that the n that I'm passing to the function that I'm calling, or is that the n that I'm passing to represent the number of times I'm calling that function? And that ambiguity means that the first of these two calls will work, but the second one won't. And it's a very hard bug to find unless you know how to look for it, unless you dig to the underlying theory. Now, if we take a look at this, we could actually go a little bit further and say, you know what, we shouldn't be doing this eagerly. We shouldn't be collecting this in a list, because who knows if the end user really wants to collect this list. We should make this a generator and just yield these. And you know, if we're making this a generator, why not just represent this as an infinite sequence of function calls and then give them the ability to control modalities externally? Because what if they want to be able to run this function until it gets a particular output, which they wouldn't do in the first formulation without adding modalities? And so instead, we should write this as an infinite loop and then use itertools.islice or itertools.takewhile in order to control the modality of when it stops. And if we're doing that, maybe we shouldn't even do this in the first place. We should just let them write a list comprehension or a generator expression if they want. And this function doesn't even need to exist. Oftentimes, the use of core theory that has been derived by really searching for the knowledge, the meaning behind the structures that we write, leads to code reviews that look like this, where we start by litigating small details in a useful sense, because it gives us an opportunity to better understand some of the constraints that we're operating under and some of the details of our tools, and then melts away the complexity until we discover, oh, actually, we didn't even need to do this at all. This thing didn't have to exist. The code review is moot. We shouldn't even be going in this direction. But I want to back up a little bit to the original bug. And the original bug is probably one of the most obvious bugs, and yet appears all over the place throughout the design of so many tools. It's a classical in-band versus out-of-band encoding problem, where if we think about what an in-band encoding is, it's any case that we could describe as having a single channel through which we're encoding distinct data and metadata, whereas out-of-band would mean using distinct channels for encoding data and metadata. And whether we're talking about two data signals or we're talking about a data and metadata signal really just comes down to the case, but it really is, do we need to encode two things in the space of one, or do we keep them separate? And this is a problem that shows up all over the place in very distinct manifestations, and yet is underlying the same problem. For example, all of you have written a shell script somewhere that used find in order to find the files that existed on disk. And then you said, oh, I want to do an operation on each one of these files. So you pipe that to xargs. Let me find out how much disk space is being used by each of these files. Except one of the files has a space in its name, and this blows up in your face. And if you went to your users and you said, well, just don't have spaces in the names of your files, that's probably the wrong answer, because you made a mistake here. And the mistake in the design of this is an in-band encoding mistake. Fundamentally, if we think about how the system shell works on Linux, well, shell scripting on Linux has a single binary channel by which it transmits all information between processes, the standard out on one side and the standard on the other side. And as a consequence, the connection between find and xargs needs to transmit over that single binary channel two pieces of information: the names of the file and the delimiters between the files. The standard on these systems, the standard with these tools, is to space separate these, or to new line separate these. And so we have an ambiguity. Is the space a space separating the different file names, metadata, or is that space part of the file name, data? Classical in-band encoding ambiguity. And every time we see an in-band encoding ambiguity, there's pretty much the same approaches that we take to disambiguate that. In the case of this, we can either partition, we can prefix, we can escape or quote, all zero in on partitioning. What that generally means is you partition the space of values and indicate that some values can only ever be data and some values can only ever be metadata. In which case, for the shell scripting example, well, you say backslash and a null byte can never appear in a file name on Linux. A backslash may be able to appear in a file name on other file systems, but as far as I know, there are no file systems ever that allow a null byte to appear in the file name, which means if we delimit them, if we partition the space of all the characters that we have in that singular channel, such that anything that's not a null byte is data, and anything that is a null byte is metadata, the delimiter, well, we can actually unambiguously delimit these file names. If we take a look at the actual tools we use, we'll see that they implement this. Find has a print 0 argument, xargs has a -0 argument, and we've solved the problem. But the point of this example is not to show you how to fix a shell scripting problem, but to show you where foundational knowledge ends up being much more powerful than you think, and why the search for foundational knowledge is a critical thing in your code review process. Because if we think about things like floating point numbers, IEEE 754, and we look at all the bit patterns of our IEEE 754, we will see that certain bit patterns have been carved out. Some represent actual values and some represent metadata, infinities, nans, and payload nans. And as a consequence, IEEE 754 floating point has an in-band partitioning where it can partition this is actual data and this is metadata, specifically nans representing the absence of a measurement. Which is why, if we happen to be pandas users, one of the things that we've almost certainly run into in earlier versions of pandas was if we had a pandas series, a pandas data frame, or even a pandas array, and we wanted to represent there was missing data, we could do that if it's floating point data, because floating point has that partitioning, but we couldn't do that if it was integer data. Because integer data, well, how do we distinguish, is a 0 value an actual 0 or a 0 representing something that's missing? And as a consequence, we need either some sort of in-band disambiguation mechanism, of which there really isn't a good one, or we need an out-of-band encoding, and we could think about how a capital I in64D type in pandas is that out-of-band encoding. It's something very similar to a NumPy masked array, which represents the missing values separate from the values themselves. It's a classical out-of-band encoding. And despite being in a completely different domain, with a completely different programming language, this is literally the exact same problem, the in-band encoding ambiguity problem and the mechanisms by which we disambiguate, either within an in-band encoding or the reasoning by which we push ourselves towards an out-of-band encoding. As the shell scripting example, two very different domains, two very different problems end up being the underlying same problem that you can unify and take from something that's relatively controversial to something that's just, oh yeah, this is an in-band encoding ambiguity, here are our choices, and methodically work through them. In fact, even if we look at the design of different tools, like for example, our system path on Linux, which is colon separated, or tools like Docker, where if you're mounting a volume on Docker, you have the source and the destination separated by a colon. When you look at this, you say, well, that's going to be an in-band encoding ambiguity, because what if there's a colon in the directory name? Well, if there is a colon in the directory name, you can't mount it in a Docker container. Docker, a tool that was written very recently by very knowledgeable people, has exactly the same flaw as all these other tools because we didn't search for that foundational knowledge, explicate that foundational knowledge, and bring that to light. Because once you see these problems, you can never unsee them. And then you look at the design of better tools, tools like BRAP, and you say, oh, that's why BRAP has separate arguments for the source and the destination when you're doing a mounting here, because there's an out-of-band encoding that is created by the shell's globbing mechanism and the shell delineating these into different arguments of your argv. When you find that foundational knowledge, it's very much the case that once you see these things, you can never unsee them. And this is the value of finding that foundational knowledge. This is the value of making your code review processes an opportunity to search for that knowledge itself, so that you're not just litigating some tiny detail about one piece of code in one system at one point in time, but searching for knowledge that tells you about all instances of patterns similar like that across all projects, across all time. It is often the case that the search for that foundational knowledge, that foundational underlying theory, takes things that were once controversial questions that turn into flame wars in your code review process, with one person saying one thing, the other person saying the other thing, and everybody collecting evidence on both sides, but nobody coming to a conclusion, and it turns them into just obvious answers. Here's the methodical approach for understanding this problem. It leads to these conclusions. Maybe both people were right if we take a look at it through this lens and through this framework. The underlying theory is often lurking in plain sight, and yet there seems to be this resistance in the code review process to really dig into what that underlying theory is. For example, one of the other hugely controversial things that I see all over the place that comes up in code reviews all the time, and yet is not a particularly controversial question is, in this code review, should this thing be a function? And people say things like slogans, don't repeat yourself. Anytime you're in a code review and you're not talking about some foundational knowledge, you're not searching for that foundational theory, but you're instead relying on simple slogans, there's a very good chance that you're misleading yourself. Because there is theory behind this. We don't have to rely on silly things like don't repeat yourself. We could reach back to theory that already exists, like the theory of normalization, where in the theory of database normalization, there's a topic of why we normalize, and one of the reasons we normalize is to eliminate update anomalies. You perform an update on one part of the system, but that update doesn't flow to another part of the system. You update somebody's address in this table, but the mail still goes to the wrong address because there was another system. And that leads us to say, oh, the way we do that is we create a single source of truth. Well, if we think of what a function is a single source of truth. It's a single implementation of some mechanism, such that if that mechanism changes, it changes in one place, there's no risk of update anomaly. Well, that's really what a function is, and all of these arguments back and forth, should this be our function or not? Some of them may be legitimate, but in many cases, we're just dancing around the underlying theory of normalization, the underlying theory of repetition being either coincidental, two pieces of code just happen to be the same at some point in time, or intentional. Two pieces of code are the same because they must always move in tandem, and they must always be the same. If we dig just a little bit beneath existing theory of normalization, we can discover that there's just one tiny amendment to this. The idea that repetition could be coincidental, that two pieces of code that look the same might just happen to look the same because at some point in time, somebody wanted them to be the same, but they could rightfully and very readily diverge. Or two pieces of code must always be the same, and if one changes, the other must change. If you have intentional repetition, then you unify, and you definitely want to write a function. If you have coincidental repetition, then it's likely that you've assessed it to be coincidental repetition by assessing that it's likely to diverge over time, which means that managing that divergence over time will cause modalities to sprawl in the code, likely deep in the code, then requiring you to revalidate things. The two pieces of code just happen to be the same at one point in time. Somebody changes this, but they've already been unified into a function. So somebody adds a keyword argument to this function, but they have to thread that keyword argument 3 functions deep. They have to retest almost the entire framework to make sure this didn't disrupt anybody else's work. And in this case, we can see a deliberate piece of found theory that's not particularly formalized, that gives us methodical guidance as part of our code review process for what we should do, removing all of the subjectivity and all of the controversy, the unnatural, unnecessary controversy that might arise, all of the flame wars that might arise as this. What is a culture of knowledge? Well, a culture of knowledge is about avoiding these intellectual shortcuts, avoiding these slogans, always be willing to ask why. When somebody says, don't repeat yourself, say, well, actually, I do repeat myself sometimes. And sometimes I do that and it's worthwhile. Why is it that I'm not taking my own advice? Self-reflect and try and figure out, well, maybe I'm right. I'm just phrasing this wrong. Don't repeat yourself intentionally, but do repeat yourself coincidentally. Always dig for knowledge. And that knowledge, and know that that knowledge is often hiding in plain sight, even though it may take you a while to dig for it. When you take a look at a code review, really ask yourself, what is the reasoning behind the advice that I'm given? And is this generalized reasoning? How do I collect all the evidence across all of the things that I do or don't do and unify those into one singular piece of theory? How we go about doing this is actually quite difficult, and I can't really give you a lot of advice for how to develop this culture of knowledge or how to build that knowledge, but I can give you one critical pointer. Typically, the education that most programmers are subjected to is wholly quantitative. They are hired for their quantitative skill. They're hired because they did well in computer science courses, in engineering courses, in math courses, in courses of that nature. And they don't understand that knowledge can take many forms, including non-quantifiable forms. There is such thing as qualified objective knowledge, and understanding that sometimes, while we may not be able to say everything definitively about a particular question, we may not be able to enumerate facts and figures or create formula, we can still formulate rigorous, thorough, arguments about something, making use of qualified knowledge. One thing that I would strongly encourage every programmer who went through a science, technology, engineering, or mathematical background is take liberal arts classes. Learn about history, learn about literature, learn about art, because the kinds of reasoning that are used in those fields are very foreign to us, but they are part of the key to understanding the fundamental epistemology that allows us to really search for knowledge and perform code reviews that are not just litigating tiny details or relying on shortcuts or slogans. Finally, one thing that we are often missing that leads to code reviews not being particularly useful is a culture of quality. And just like the culture of knowledge, it's very difficult for us to instill a culture of quality where none exists. It's difficult for us to create rules or create guidances or write memos that say, everybody, focus on quality. If that culture of quality doesn't exist, I'm not sure how we create it, but I do know that I've seen it exist in some places, and I've seen it fail to exist in some places. But before we talk about the culture of quality, one important thing we should ask ourselves is, does code quality really matter? Because many of you are going to say, yes, of course it matters. Bad code quality leads to bad code that has security faults, that leads to you losing money, that leads to you losing customers. But some of you are also going to say, well, actually, I have some colleagues and they work at a company and their code is atrocious, and yet they make money hand over fist. In fact, between you and me, we do quite a bit of consulting at some very big tech companies in the US, and you may be surprised to learn that at some of the top tech companies, the code quality is not that good, and they still make money hands over fist. And if you were to give me the choice between having $10 billion or really good code, I'm not sure that I would pick the really good code. And so maybe we should ask the question, does code quality really matter, well, to a particular audience? To whom? Does code quality matter to employers? Well, you almost certainly have seen circumstances where a colleague of yours doesn't really know what they're doing, but is able to talk very convincingly, and they're able to get a job. And it's very difficult to measure code quality in an interview circumstance. So maybe it's the case that to employers, they kind of want a proxy for code quality, but also they kind of want somebody who will just do what they're told and will just ship features. Does code quality matter to the market? You know, we could say that if there's poor code quality, it leads to security issues, and security issues lead to bad press, and you might lose customers. But the unfortunate truth about security issues is a lot of companies have had some very embarrassing security circumstances and don't seem to have lost much money at all. Maybe a temporary dip, and then they recover from that. And so oftentimes, if we look at the market, we can say, you know, quality does seem to matter. There are better goods that do better than worse goods. There are better design products that do better than worse design products. But there's also a lot of junk out there that seems to do very well. So it's not certain to me whether or not code quality can be said to uniformly be of importance to the market or not. Does it matter to the project? Well, I would say yes, but oftentimes when I'm working on a project, I'm working to a certain standard, I'm working under certain deadlines, and I know that the project evolves over time. So I know if I ship bad code today, it may very well be the case that in 3 months, I'm going to rewrite it anyway. So why should I put all that effort into shipping the best thing I possibly can, knowing that it's going to be rewritten? Does it matter to my colleagues? Well, I don't want to be I don't want to be chasing after somebody else's code and trying to clean up after that. So I guess it kind of does. But also it's the case that, you know, a lot of the code that I write is really not that important. And as long as it's functionally correct, if it's a little bit sloppy, you know, then just kind of fix it. If there's a bug, we'll fix it. I think when we talk about quality, and I think the key to a culture of quality is really asking ourselves, does quality matter to you? And for all of the other audiences, sometimes it matters, sometimes it doesn't. And we can find evidence and arguments that it does matter or it doesn't matter. And we can find very compelling arguments both ways. But when I think about it deep in my heart, quality matters to me. I want to do my work to a standard. I want to do that work to a standard that I think I can achieve, and I want to push that standard forward. And if I don't do good quality work, I don't feel like I have done a good job, and I don't feel good about myself. And I think that if we're talking about a culture of quality, and if we're talking about caring about quality, it really is something that has to be built culturally from within. You need to find people who fundamentally care about doing good work for the sake of doing good work. So when we talk about a culture of quality, well, you know, it's about working to a standard and wanting to set a high standard for yourself. Now, if we think about it, in the absence of such a culture of quality, in the absence of a culture of knowledge or a culture of learning or a culture of training, what are we really doing in a code review? In fact, I would argue that in those circumstances, code review probably is useless. I'm James Powell. Thank you all for joining me for this presentation. It's been an absolute pleasure.
Thank you so much, James. That was absolutely amazing. I can clearly say that your session was out of this world, right? And not only you shared all those tips and tricks, but during the session where you would, share your pearls of wisdom, I think that was something very unique in your session, and also your style. Very unique way to have your presentation in the background. Very nicely done, James. So I know this session was only one session from your bag of magic tricks. What other ways people can connect to you, get to know what else do you do? I did search. You have a YouTube channel. You're putting in content there. Perhaps you've also written books. Perhaps you want to enlighten people more about you, what you do, so that they can stay in touch after this conference too.
So I was talking to a colleague of mine about what is the core of our mission or our vision for the things that we do. Because if you really look at the things that we do corporate training. So we go into hedge funds and different sites for the federal government, scientific research sites, weapons design sites, all of those things. And we teach them how to use Python. But to a large degree, that's kind of like, I need to do simulation work. Teach me NumPy. Very rote. We go into big tech companies and hedge funds and we build systems for them, data pipelines or machine learning systems. And again, it's like, I have this website that's helping me as part of my strategy research process. I need to write it in Flask. Can we just go and write some code? What's the unifying theme to all of this? And I think the unifying theme behind all of our work is very similar to this idea of searching for quality and the desire for quality in yourself. We, at our core, at Don't Use This Code, want to develop expertise in what we do, where expertise isn't being seen as an expert, because you can just put on a tie, right? A suit and a tie and a pocket square, and everybody thinks you know what you're doing. And it's not winning an argument online. It's about searching for real knowledge that exists in the world and figuring out the ways in which something should be done correctly to meet whatever human goal this is subordinated under. And so what I do for work is I search for and try to develop true expertise in scientific computing and financial analysis tools in Python and deliver that in the form of consulting and training.
Wow. That's good. That's good to know. So everyone's watching in. If you are someone who's looking for data science or anything, what just James said, I think just Google "Don't Use This Code" and you'll get in touch with them. I've also in the comments share a link about that. I think that's about their newsletter. That link will take you to the newsletter, and we have about 620 people watching now. So go ahead and click on that link if you want to stay updated with whatever James is doing at Don't Use This Code along with his team. I see he has built a nice team. You can stay in touch. You're saying
And
something,
we have a
James?
Discord server. We have a YouTube channel, and all of those things we're building up slowly. We even have some on the open science stuff, some free trainings that we're doing. But for the most part, I think the real pitch is this. Do you just want to do your job? In which case, ChatGPT can do quite a bit of it for you right now. Do you just want to get the job? Just study LeetCode. Or do you want to do the job well? Do you want to figure out how to continuously improve how you do your work? Do you want to always reach for better? Do you want to have arguments that are not just these wishy-washy arguments about what's elegant or inelegant, but very substantive arguments about if we do something this way, it will lead to these consequences, which will lead to these consequences, which may or may not be desirable, or maybe things that we can tolerate, and to objectively and methodically work our way through improving the quality of the work that we do. If so, I'd be more than happy to talk to you. I'd love to talk to you and understand more about where we can help out.
That's perfect, James. One final question I'm going to ask you is, for how long you have been running this Don't Use This Code? I'm just curious because you sound absolutely amazing with your ideology and your vision.
I've been doing this for, if I say exactly how many years, you'll see that I actually have gotten quite a bit older.
I won't get judgmental. It's okay.
I think I've been doing this for maybe eight years or so.
Oh, you're young then.
Yeah, not that long. Part of it was part of it's the kind of standard story of I worked in big companies and I saw how things were done in big companies, and you're always a little bit dissatisfied because you're so misaligned. You're told to care about one thing, but the company doesn't care that much about that, and a little bit of that dissatisfaction. Some of it was about building a community of people who are like-minded and working with people who I really looked up to and people who I could really learn from. And part of it was just the mechanics of seeing a little bit more upside, from the efforts that I have. But I will add one important qualification. That I've been doing this for a long time, I think is separate from that I know what I'm doing. Because one of the things that I am most dissatisfied and most resentful of is the story where it's like, this person has been writing code since they were 3 years old. Look how smart they are.
I don't buy that.
Yeah. If programming is actually to become a real engineering discipline, the only way it can go that way is through the development of foundational methodical approaches. And somebody who's searching those out and explicating those, teaching those to other people, and popularizing those. Because if somebody said, oh, this bridge builder is really great, he's been building bridges since he was 3 years old.
I'm not getting on that bridge.
Exactly. You'd say, well, there's a theory behind this. There's a formulation for if you build a bridge this way, you run into this problem. There's some history. You can see that these bridges were built incorrectly, and as a consequence, they fell down. And I feel like as a discipline, one of the things that I'm trying to do in my small corner of the discipline, but I think the discipline needs to do, especially if we are to really genuinely care about quality, is to find and write down and propagate this foundational theory.
Thanks. And I see Mahesh Chan in the comments. He's been following to what you say. I mean, when you shared the story about I've been doing it from 3 years, he's saying that story is terrible, which actually means that you're doing this job for so long and in the same way. And he goes on to add that I would rather like to see I just learned this in past 1 year, right? That tells that this person is going much faster. So yeah, very much to what you said. He relates to it, and he's the founder of CSharpCorner. Yeah.
Fantastic. Well, good news, Mahesh. I was born in 2008, which makes me 16 years old.
You're hilarious, James. James, thank you so much. You're one of the very unique speakers. I'm so happy that you accepted our invitation. Thank you so much. I'll get back to you on the emails with the all details and stats of this conference. I'm also going to give you a dedicated session recording of this just for your session so they can share it with your connections. Once again, thank you so much, and I can't wait to see you in the other events that we do. Thank you so much, and have a great day ahead.
Thank you, Simon. Thank you, everybody, and I'll see you all next time.
Yeah. That was James. Thanks again, James. He came with his great way of presentation, and thanks to the team involved by James, Diana, right? She has been helpful and helped us with all the communication all this time to have James in this conference. Having said that, ladies and gentlemen, we now move to our final session of the day. Well, actually a new day, because it is a new day for me here in India. So our next session is by Drew Skurs Kobala. Now, for some of you who have been following C# TV in the past 4 years, you may know that we have hosted Drew in a couple of past conferences. I do remember 2 of them, and that is SQL Server Virtual Conference that we did. And I think we also did the Cloud Summit. He was there. He's still not here because we have about 9 minutes before his session starts. But never mind, I'm going to take a couple of minutes break. You all can take a break, and we will be back very soon. Just about a minute and a half break. Get yourself a glass of water, and I'll see you super soon. Hi everyone and welcome back to Code Quality Conference for one last time. This is the fourth edition of Code Quality Conference. We have been doing it from last 3 years. It gets bigger and better. This year at this instance, you can see we have more than 600 people watching in. Most of our viewership is coming from Twitter. We are once again live on LinkedIn. And just in case you have missed those 2-3 hours of streaming on LinkedIn, don't worry. If you have registered for this conference, we're gonna send you an email with all the recordings and stats and other things to follow up. Just in case you want to watch it again anyway, you can watch the entire stream on CSharpCorner YouTube channel. Having said that, let's now move to our final session of the day, that is by Drew. Drew is the Principal Program Manager at Microsoft. Last time I hosted, I think he got promoted. I think things are moving very fast for him. I'm so happy to host him after almost 2.5 years. In fact, a couple of days back, I was talking to Anna Hoffman. She was like, "Oh, it's been so while." So yeah, good friends at Azure Data team. Drew is going to talk about check and detect T-SQL code analysis. Always a great topic to talk about. So without any further ado, let's bring Drew to wrap up this conference with his final session. Hi, welcome to the Code Quality Conference.
Thank you, Simon. Thank you for having me.
I think we need to update that video. It has some really old pictures. I can see that.
That's all right. Been
All right,
learning a long time.
Yeah, exactly. How has life been?
It's been great. I can't say how much it's always an exciting time to be a developer. The more and more things change, and now we have new opportunities between AI and things like the .NET ecosystem continue to bring new things to us. So it's always fun to keep learning.
Yeah, that's great. I'm so happy we could connect once again, Drew. Your session is the final session, so you can take all the time that you need. No problem at all. I'm gonna add your screen to the stream. Everybody else can see Drew, and next 45 minutes or whatever, it's all yours.
Great. Yeah, well, we'll be 45 minutes today, folks. I do want to talk a bit about T-SQL code analysis. Just a real quick recap. I work at Microsoft on that Azure Data team with Anna Hoffman. My focus area is with SQL development. I did a master's degree at Georgia Tech recently, and some of that nerd is going to come out today, and that'll be a lot of fun. You're welcome to connect with me on LinkedIn, especially if you have follow-up questions today. I'm happy to chat. Recently, I asked folks, like, are you looking to control or try to monitor the SQL code quality in your database and applications? There were a lot of great talks today about improving the workflows that we have as developers, whether it's what people are doing or automation around things. How do we make sure that the applications we build are reliable and work well? For SQL code, the paradigm of SQL being separate from the C# or the Java or the Python or other application languages or writing, it being separated kind of bites us a little bit with disadvantages. We might think, oh, the ORM is creating the database objects for me. EF Core does a great job. But is it perfect? Do I need to double check? Maybe someone else is responsible for the database. There are DBAs that are going to make sure that the database is working well. So I don't need to worry about that. And my personal favorite is it runs fine on my machine. The query is super fast. I know that it's going to return the right results, so we're good to go. Maybe you're the only one who knows the database, kind of back to that, my code is perfect. But we can never be too perfect. So if we think about the database is truly part of your application code, and you want all of your code to consistently have good quality. We don't review 500 lines of C# code only to ignore the 50 lines of SQL code that go along with those stored procedures. So to that end, what we're going to talk about for the next 40-ish minutes is how can we bring SQL along for the ride into ensuring code quality. I've got 3 things to touch on. The first one is a really cool project called SQL Check. The second is a .NET library called ScriptDOM. And then the third is a whole development paradigm that leverages ScriptDOM and provides a whole world of code analysis opportunities. SQL Check is a graduate project of now Dr. Joya Rulraj at Georgia Tech. This is available on GitHub, and it's database agnostic, so that's a huge advantage for it. If you have a SQL script like this, the way SQL Check works is that it is a command line interface that when you run it will provide some text output. If I run SQL Check against this create table statement, it's going to give me 3 results in that text output. The first one is there's a high risk around the primary key just generically being named ID. We'll come back to that concept in a minute. And then the next 2 are more general hints around as we write queries, we want to be careful in using null and not null statements. As a general practice in writing SQL code, it can be really helpful to have a CLI like this that we can pass a SQL script and it can give us some feedback. SQL Check is really cool. Some of the nice things about SQL Check itself is that it's compiled from C++. So as far as the speed that it has, it's quite quick. This also means that it's cross-platform, and you can compile it yourself if you have a really specific environment where you need SQL Check or your code analysis to be running really quickly. It's open source, and the code structure of it is in such a way that it is effectively extensible. It is not extensible in the way that you write an extension for it, but is extensible in the way that if you pick up the code yourself, you can write additional rules. The things to be aware of when you're thinking about SQL Check and passing it your SQL scripts and using it is that it is based on regex string matching. I am not great at writing regex, so this commentary comes from that place. If you are a regex master, if you're an aficionado of regex, maybe you can write the string parsing that you need to perfectly match individual statements. But there are some things that we want to watch out for with regex parsing that we'll take a look at in a second. The other limitation that I want to point out with SQL Check is that it's outputting text output. And so unless you parse that text output, you can't necessarily do anything if you have that inside of like a CI check for when you open up a PR. So instead of having an API surface area, it does do text output. This makes it really easy to pick up and start using, but it does present some limitations as your environment gets more tricky. So if I step into VS Code here, I have the SQL Check tool, the whole source code downloaded. I've built it locally here on my machine, and so it's installed. So when I run SQL Check, I'm going to use the C flag to get colorized output to make it easier to read. And then I'm passing it the file that's open here on the top. I'm going to expand the terminal just a bit. And we're going to get similar results to what we saw in the PowerPoint. I removed the not null flag to simplify the results just to make this example easier to follow. But I have a risk right now that my ID key is too vague. When I need to join this table to another one, it's going to be tough to track that. So maybe we would want a more specific name. Being a developer that is more familiar with SQL Server and Azure SQL, I oftentimes see square brackets around my column names. So when I do that in this SQL script and save it, and then run SQL Check again, I find that, unfortunately, this time, it didn't pick up that the ID column is blank. We would need to modify it to do that. Now we can get around that by now doing some really ugly things with the column name, like adding spaces around it. So the column name is technically space ID space. No one's having a good time. But to kind of take this example too far, let me say, hey, the column name is actually ID space not space null. And when I run this again, now I'm getting hints about not including null and not null expressions when it was actually part of a column name and not a column specification. So when we use regex parsing, it is extremely helpful. It can give us really good insights into our script. So if I have not null column, it's going to correctly tell me this time. You don't want to be using that on line 4. It's really specific. It tells us where to look. It's extremely useful, but it has those limitations that as your code base gets larger, you might want to move past that. So check out SQL checks, see if it's helpful for you, but I do want you to know that there are additional options. If we don't do string parsing, how do we process our SQL to make sure that it's good? We know we can throw it at a database, and the database will tell us, yes, this is valid, or no, it's not. We can do that kind of integration test, but I want to know if it's good. What do we use for that? This is where syntax parsing comes in. Syntax parsing is a concept that exists across all code, all application code. So C# has syntax parsing that brings you IntelliSense and linting in the editor. And the same thing exists for SQL code. It gets a little bit more difficult because there are different flavors of SQL code. There's PostgreSQL and SQL Server and MySQL, but it does still exist. Why we like syntax parsing is that it can output to us an abstract syntax tree. I promised we would nerd out a little bit today, and here we go. An abstract syntax tree gives us a linked data structure, or a tree, as the name suggests, of what the code represents. There's a SQL Explorer abstract syntax tree tool that I use, and I've linked at the bottom of the slide. And when I pass that, the example query that we were using with SQL check before, it'll help me branch out and see what are the elements of that syntax tree. So it, within the tree at the top level, notices that we have 2 statements in our SQL code. The first one is the first line where it says drop table if exists. That one is collapsed in the Explorer. And then I've expanded out the create table statement where I have a couple different keywords, the create keyword, the table keyword, and then an identifier for the name. So we can see where we can more specifically access parts of our code in a way that we can check things about it. So ideally, we have a syntax parser that we can pass our code to and get an abstract syntax tree out that then a code analysis engine or a compiler can do better testing with. And in this example on the right, I have highlighted in yellow that column name for ID. We could be checking that in the world of we're looking for columns named ID. For abstract syntax trees, one way we can get them is through that script-dom library. Now, this is a .NET library. So for those of you, the probably decent handful of you on this call that are comfortable with C# development, .NET development, this may be right up your alley. It is available for .NET Framework. It's also available for .NET 6 and 8. And what this library does is if you pass it one or many SQL scripts, it parses them into their abstract syntax tree representation. It represents the SQL Server and Azure SQL syntax area. What is especially interesting about it is not limited to just object scripts. You can do some of the administrative scripts with it as well. So if you're in an environment where you're worried about metadata or management of SQL, you can also use script-dom to keep an eye on those scripts. Something that I'm very proud of the team for is that we did open source ScriptDOM back in 2023. And so it's available on GitHub, both for you to kind of take a look at, but also interact with the team. If I have a SQL parser like ScriptDOM, what do I do with it? How do I use this library to get more information out of my code? For that, I have a quick example. We're going to take a file. We're going to go into this code here that's on the screen, and we're going to take a look at a query, and we're going to check it for two things. First, I want to make sure that the developers on my team aren't doing select star. If we have components in the code, we want to make sure that we're not getting any unexpected columns or we're losing columns, which can happen if you do select star and the objects underneath the query change. So I want to avoid select star. I need to be able to catch that. The other one is the no lock hint on tables can sometimes get used like finger painting in queries by well-intentioned developers. I also want to avoid that from getting checked into code. And so I want to go ahead and be able to catch both of those anytime a SQL script gets parsed. So if I go back over to VS Code, I'm going to start with a query here. It is parsing out a table. It's just a sample query where I've declared the current year is 2024. And I'm selecting a bunch of columns from a table, including select star on the end, because I just want to be double sure that I'm getting all these columns. This is not a pretty query. The project itself is just a plain old vanilla .NET console example, but I have picked up the package reference for ScriptDOM. This is the important part where if I want to leverage that library, I need the package reference. And now in my toy proof of concept here, we have a little bit of code where in the main method, I'm going to ask for a file path. And when I open up that file path, we're going to use the surface area, the API surface area of ScriptDOM to do a few things. The first thing is we're going to declare a parser. And this parser is for T-SQL 160. If you're not familiar with the SQL versioning, it's a little bit weird. And T-SQL 160 represents the SQL 2022 surface area. So I'm saying I want to make sure that this code is valid for SQL 2022. I could change it back to SQL 2019 and make sure that I'm not suddenly getting things that aren't supported. When in the next line, line 26, go ahead and parse the file that's been read in, the first thing ScriptDOM is going to tell me is whether or not it can be parsed to a valid syntax tree. So right off the bat, I'm already getting error checking, so I could output those. Because I know that my SQL is always nearly perfect, I don't expect to have to use that catch block today, but I am going to do something called a visitor pattern, where T-SQL fragments that are found in the syntax tree can accept, where we see tree.accept, can accept overrides to a visit method. What this looks like is when tree.accept is called, each statement is checked for whether or not it's going to be able to accept that visitor. The select star visitor can only be accepted by select star expression. So there are different classes for different kinds of objects in that syntax tree. One of them is the select star expression. Another is a table hint, which represents the with no lock clause. We could do this for a column name or a table or an index. There's all kinds of different classes that you can find in the .NET API documentation. In this example, when I run it in a moment, we're going to be passing the abstract syntax tree for that query to a select star visitor that's going to tell us whether or not it finds a select star expression. And then we're also going to pass in the no lock visitor. The select star visitor is the most bare bones one possible, where it's just only going to be accepted by select star expressions, and then it's going to output a line. you can do more complex operations in these visitors. Not only can you manage kind of control flow by saying, hey, I want to check the hint kind and make sure it's a no lock table hint, but you can declare objects and accumulate information. Like you can only have one no lock. You can't have 5 within a single query. Then I know you're really not paying attention. You can do all kinds of things like that. Keep in mind, right now, this query does not have a with no lock clause. So we should expect to see that it parsed the query correctly and that it finds a select star expression. And let me go ahead and copy this path real quick. Do .NET run, and then when it asks me for the file name in a moment, I'll give it that file path. So it said no errors found, but it did find a select star expression. If I do with no lock, it's going to find a no lock hint. Now here's the thing that I hammered home earlier. The very specific syntax matters when you are doing regex parsing. But what about for syntax parsing? When I'm not doing string parsing, but when I'm doing syntax parsing, now I can kind of mangle this no lock table hint up. There's a number of different ways that are technically accessible. And I'm going to run it again. And so I've removed the with, but it still says no lock, which is a valid table hint. And it did not find it that time. So what did I mess up? I love it when things don't work like I expect. That was awesome. There we go. So I had broken the table hint by not including the parentheses around my list of table hints. Once I put the parentheses back, we were good. Now I have to go file a bug that it didn't throw on the no lock. You get more robust syntax parsing when you use a syntax parser. One of the reasons why we wanted to open source Scriptdom was that the surface area for SQL is always changing, and we wanted to be more open to people bringing us issues that they find. Yeah, Jake is helping me out in the chat and reminding me that no lock is a valid alias, so it should have been okay without those parentheses. So I get to go work on that later this afternoon. So when we use Scriptdom, we're able to use visitor patterns to catch different parts of the syntax tree and then react to them. You can do more extensive things. One example that I've seen more recently was taking the SP execute SQL expression where you're using SQL to execute dynamic SQL and find what is actually being executed within that without having to run it. That is another way of using the syntax tree and then kind of decompiling it from there. Let's head back over to our example. With our kind of quest towards code quality, we know that we want code analysis, code quality to be a part of our process. And that's where I introduce CI automation as just something to keep in the back of our minds. Today, we are not going to go build out a PR check pipeline, but what I want us to think about is when I check some code in, we do a few things like making sure that it can build. Sometimes we are using unit tests and .NET Test, or potentially we're generating migrations with EF migrations. There's all of these pretty common things that we know need to happen. In the SQL world, we do have one thing that's analogous to that, and that's the concept of a SQL database project. These are a little bit of a divisive topic sometimes because the most common way that they are used is in the forward direction where you're building your database objects specifically in a database project, either in Visual Studio or VS Code, instead of using an ORM like EF Core to generate your objects for you. This is not to say that you can't use them in conjunction with an ORM. It just is not a very common pattern, to be honest. But the database projects have, similar to C# projects, a build process where then they have a build artifact, which is a DAC pack. So now for SQL, we have two kind of tools in the back of our tool belt. We have the script DOM syntax parsing library, but we also have a database project that has a build process. So can we link our ability to parse scripts with the fact that we have a process where we're going to be building and validating our database objects? When a database object builds, or when a database project builds, it looks at all of the objects in the scripts that are defined as a part of that project and validates their relationships. It makes sure that if a table has a foreign key to another table, that that table actually exists, that that foreign key actually exists, for example, or a stored procedure, if it's calling to columns in a table, do those columns actually exist? That kind of check is happening. Can we extend this to making sure that the code itself is not just valid, but that it is good? And this is where code analysis can be enabled on SQL projects and take us that next step. The term that's sometimes used in the code analysis world is anti-patterns. I hesitated to put the term bad code on this slide because some anti-patterns, you have to do them. There's not a better way around it, but you at least want to know that you have done this. And that is why when you enable code analysis rules, you can go two different routes. And for specific rules, which we'll talk about in a second, you can either go to a feedback to the developer where it's just a build warning. We're familiar with build warnings, developing with C#, or you can go all the way to a build error. Let's say you absolutely ban nullable columns. You can block builds on an error if a nullable column is detected. So that is an option. As far as code analysis and kind of just running with it today, if you have a SQL project, there are out-of-the-box rules. In Visual Studio, there's the nice project properties pane. And in the project properties pane, you have the code analysis tab where you can checkbox to enable code analysis on build. This sets the project file property for run SQL code analysis to true. And that just gets it going. By default, the out-of-the-box rules are set as warnings. So you're not going to break your build by doing that first check. You can enable and disable specific rules out of the box. There's about 15 of them. There's some more around database design. So that select star example we hammered on earlier. You can start getting picky about how objects are named. Perhaps avoiding using reserved words for type names, things like that. And then last but not least, there's a whole performance category where we make some suggestions around how to improve your performance. So if you were coming today hoping to find out how do I write really good performance SQL code, I am not the person that's going to make those final recommendations for you, but here's tooling that, while there are a handful of rules here, in a moment we're going to talk about how can we go further on these rules. So if I've enabled some rules and then the specific ones that we want to serve as warnings or as errors instead of warnings, when we check that, we will also get a project file property that has that plus exclamation point and then the rule name. As you look at that rule name, it is not a mistake if you're thinking, geez, that sounds a lot like a class in a library. Because in fact, code analysis rules are a library and it is extensible. The way that the code analysis engine works is that it will load up all of the rules that it can find. which is a very weird way to phrase things, I understand. I promise I'll come back to the idea of the code analysis engine finding rules. When you are running code analysis rules, like during a SQL project build, you can incorporate rules either from a community project or from your own knowledge base. So if you've got specific rules for your development environment, you can write those rules yourself. But you can also adopt rules from a couple different community projects. There's SQL Server .rules, and then there's also T-SQL smells. Both of those are really cool projects where they spent a lot of time and took input from a number of developers to put together over 50 rules that can be pretty helpful. What's important to understand about writing code analysis rules is that the object definitions and the relationships are accessible while you write them. So keeping on theme with today, it's not just about parsing the strings, but you can go to the level of looking at every table and throwing a warning if a table has no foreign keys. It's possible that you have some tables that are completely unrelated from others in your environment. But that is the kind of thing where you can traverse the syntax tree as well as the relationships between them to test that out. So the relationships between them come from the DAC model, and then the syntax tree comes from the script DOM parsing library. So you kind of get both, 2 for 1 when you're using this code analysis extensibility. The rule configuration that's a part of this was what we saw on the previous slide, where you get to check for whether or not rules are enabled and disabled, as well as if they are an error. And then the concept of picking up all the rules for a target platform. That is a special one. So let's take a look at using code analysis rules in real time. Now, you already know I work for Microsoft, so you're not surprised to see me using AdventureWorks. In this example, I'm in VS Code, and I'm using not the SQL projects that are currently available in Visual Studio. I am using SQL Projects SDK. When I build this project, it's going to run SQL code analysis, and it's going to run SQL code analysis with some specific settings. First, you see the minus example. It's going to skip some of the out-of-the-box Microsoft rules. I've loaded in T-SQL smells rules, and I'll show you how I did that in just a second. And I've said I want these rules to be considered major issues. So if I do a .NET build on my SQL project, which again, just a quick review on what a SQL project is, it's a definition of all the objects that I want to be declared in my database, and it compiles them together into a single build artifact. To deploy that build artifact, you would use tooling like the SQL package CLI, or within VS Code and Visual Studio, there's a publish button, but likely you're automating. You can generate even a deployment script. While the concept of writing all those create statements can be a little scary, because you're thinking about like, now how do I update my database? That's what the SQL package CLI does for you, is it generates the deployment of figuring out how to make those changes. That's beyond us today. We want to focus on, I have my object definitions. How do I make sure that they're good code? When I run .NET build, it's going to take a look at all of the relationships in the database, all the object definitions, and then it's going to run the rules that I have enabled. And smells 005 is, again, the select star rule, and it found that. And it found it in a view that I named select star. That was very clever of me. And even tells me what line and character it's on. So if I go into views, select star, it's on line 3, character 8, and there's my select star. So if you have a huge code base and you want to start improving it bit by bit, enabling code analysis will tell you where to look, even when it finds these issues. Now, loading in custom code analysis rules is going to look from where the build engine is loading the DAC effects DLLs from. For Visual Studio builds, that's a specific folder within the Visual Studio installer folder. For the .NET SDK, we have a very interesting road ahead. So first, the workaround. Right now, the build pulls its targets from the build folder in the NuGet folder. So if I go into packages and drop my compiled DLL for T-SQL smells in there, I'm able to go ahead and pick up those rules. They're just picked up automatically. No further steps. Now that's still not as good as we want it to be, because again, our idea with SQL code analysis is that we're getting SQL to be just as a part of our development process as the rest of our application code. When I need to pick up development dependencies for my C# projects, I add package references. The direction that we're headed, and it is not there yet, is to have a package reference for different packages like code analysis. Let me go back to the deck real quick, because I want to kind of close out by wrapping up where we're at in this SQL project's evolution to bring code analysis to a better place. First, I want to start by recognizing that there's a fantastic community project for SQL projects that's been really setting the bar for how do we make it as easy to use as possible, especially in cross-platform environments. And it brings in the very extended code analysis rule set just right out of the box. So if you're looking for like, how do I get started today with the least amount of friction, picking up the msbuild.sdk.sql proj is one way to be able to take your SQL project and get a larger rule set on it right away. The other thing that the community SDK for SQL project at the top introduces is package references for DAC packs. If I have a large database and I need to break it apart, one of the ways to do this is to publish DAC packs as NuGet packages and then pick those up into a SQL project so that you can have a better architected database. Now, package references with SQL projects is a fantastic concept. And that's why I mentioned before where we're bringing code analysis references for SQL projects is that instead of needing to do that ugly workaround you saw where I had copied the DLL for the T-SQL smells into the NuGet packages folder, this should also be a package reference for custom rules. You can do that for DAC packs as well with that Microsoft.build.sql SDK, but it needs to be a package reference to make it even easier to bring in those additional custom rules. The Microsoft.build.sql SDK that you saw me using with AdventureWorks is an evolution on the original style SQL projects. If you're an aficionado of SQL projects, you probably are quite surprised at how short this file is. The default globbing of all the files, for example, is something that's a part of both SDKs. And so it makes it much easier to modify and edit the SQL project file. And so this will be coming soon into Visual Studio. Overall, when it comes to code analysis extensibility, it's not required. You are already going to get a win if you start in Visual Studio, enable code analysis on build, and just start getting warnings when your code needs some improvements. But if you want to take it further and either load in community rules or you have specific requirements for your own environment, this is where you can use community examples or follow the walkthrough in the Microsoft documentation to write custom rules or rule. Like even if a single rule will help your environment, it's worth it. Have those custom rules. You get the analysis results as a part of a build, so that becomes part of your CI, and then you're all set. This is one of the best times to be hopping in on code analysis for SQL because we are bringing package references for custom rules to that build SDK right as it starts to land into Visual Studio very, very soon. So it's like best timing ever. With that said, we covered a whole breadth of topics today at a surface level. I'm happy to take any questions if folks have it, but we started with SQL check and looked at how even regex parsing can give us valid feedback on things. There are edges to what it can do, and that's why we like to head towards syntax parsing with scriptdom, which is a .NET library. You can use it standalone, like you saw in that console app example that I had it parsing scripts. I even got my demo to kind of slap me back in the face a little bit where it didn't recognize the no lock alias in one way. So now you get to see that pull request out in open source here soon. And then last but not least, SQL Projects brings code analysis as just a checkbox on build, so we can get those warnings in real time as a part of our CI. So Simon, as promised, I was not going to go over today. We have a little bit of time to take questions if people have them. I'm happy to go through any.
Well, that was a great session, Drew. I mean, I can tell you at this instance, we have about 600 people watching in, but the time here in India is 1 a.m. So there's not a lot of questions, but most of the viewers are from Twitter. But I really like, from where you started, the example that you gave where your ID wasn't working and you had square brackets on. That is really sometimes irritating. So I think I really like that part. That's very relatable. And then, of course, syntax parsing, it's in every programming language. So that was one good section of your session. I really like that part. Drew, so I know most of this must have come from your personal experience, but is there any resource that you take it for reference? Because this presentation had I won't say if someone would just read it from somewhere or watch any video and learn it. Do you follow any resource? And how did you come up with a presentation that was full of best practices? It is different than other best practices that I have seen.
Yeah, so for me, I have two experiences in my background. First, I was a developer for about 8 to 10 years before I joined Microsoft. And so I saw in real time when code landed in the database and it wasn't great, how painful it is to bring code back out versus if you can catch it before it goes in. Now at Microsoft, I kind of get that double lucky where I get to work with the folks that are also building the code analysis parser. So it's a little bit easier. To that end, if I could give one resource today, it is the top link down at the bottom on devlogs.microsoft.com. There's a blog post by Arvind Shyam-Sundar, and he wrote about kind of how do you get started parsing with the scriptdom parser, and links to a bunch of great community examples there. So that is like the best place to start if you just want to think, how do I pick apart SQL? That's where I would go.
Perfect. There's a question coming from the community. I think we caught one. There's by Jake is asking, are you saying you wanted your no-log visitor to throw the error about no-log usage?
Yes, so that's a great question. What I was expecting was for the visitor to pick up that I had no lock in the query and output to the console found a no lock hint. At one point, I had no lock without the parentheses around it. It just said no lock. And it didn't pick up on that. I didn't have with and I didn't have no lock. I removed both. And what was interesting, I will run this again real quick, is it doesn't find an error in the syntax, so it parses this query as valid syntax. Jake is absolutely right. So this is aliasing instead of being a table hint at that point. So yes, awesome. Now I know. I love it when I learn things. And that's the other thing to your good question earlier about like how do you learn some of these things. There's so many smart people in the community around SQL especially, and then you overlap with the great .NET community. There's these great developers that are always happy to share their advice and what they know. So when you get involved in these different projects, you learn a lot from other people. So thank you, Jake. I really appreciate it.
Oh, I see other comment from Eric. I did host Eric like a couple of weeks back, so welcome back, Eric.
Yeah.
So Eric is asking, how soon will the updated project type appear in VS? Is it VS Code or Visual Studio?
He's asking about Visual Studio. That is a great question. Thank you, Eric. Eric is another really knowledgeable person in the community,
Yeah.
like Jake, that has a lot to share. So when I talked about the SQL project's evolution, I highlighted the community project for the msbuild.sdk.sql proj. That is supported by a group of people, including Eric, that they bring great functionality to that. The Microsoft.build.sql SDK is on its way to Visual Studio. You will see it there by the end of the year. It will be in preview, and it will be in preview by early fall. So we're looking at very soon, like soon enough that I am comfortable to say you should be hearing from me again soon.
All right, Drew. Having said that, what's new happening in the SQL family? I see you guys are definitely talking about vector databases here and that. Other than that, what's new happening there?
Yeah, so you heard about the vector database work. We've introduced support for JSON type as well. So there's a lot of ways that developers can be passing data into SQL or handling it within SQL as they need. So if you have a front end or a back end that's handling JSON data, and you want to do some of the parsing in the back end, but you also want to be able to pick it apart in the SQL database. One of my favorite parts about the JSON support that we're bringing is JSON indexing, where a property within your JSON text can be part of an index. That's like kind of really pushing the limits on what we think of as a traditional relational database and what makes it most performant, to something that's like, hey, this is JSON text that I've thrown in my database, and now I'm getting great performance out of it. So yeah, that's been pretty cool to see coming through. I talked candidly to Eric's question around, we've said soon for SDK style SQL projects coming to Visual Studio. That is like this fall. You will see it in preview kind of soon. It's something we've got some people working very hard on. So that's personally very exciting to me. But it's one of many cool things that's happening right now.
Okay, I'm going to ask you one final question, right? And then I'll let you go. I know you have some other meetings, right? So recently we were hosting Mark Brown, right, from Cosmos TV, right? And he really likes to brag about, the ChatGPT. In ChatGPT, they're using Cosmos TV as the database. So I'm curious, how's SQL keeping updated with the AI ecosystem? What's new happening there? One vector database, definitely. Is there anything else that's happening in the SQL family?
Yeah, so right now rolling out in public preview across a whole number of different regions is a Copilot for working with your Azure SQL database. So if you're in the Azure portal, there's kind of two opportunities to work with AI to help make you a more effective developer. In the query editor, in the portal, is an inline Copilot that if you're writing a query and you need some help, you can give it comments and it'll give you feedback. What's specific about the Copilot in the portal query editor is it knows the database structure that you have. So the syntax it gives you is going to be valid for your database. If you've ever used GitHub Copilot in VS Code, it is awesome. But if you have it help you write queries, it's going to effectively hallucinate and give you columns and tables that may or may not exist. The portal query editor's Copilot knows what it should be suggesting. The other Copilot in the Azure portal, it comes from working with your SQL database and helping manage it. So that's in the primary Copilot pane in the Azure portal, and it'll help guide you through managing your SQL. Oh, I love it. You just popped up, Eric, reminding that regex is also landing in T-SQL. Like there's so much that keeps evolving with SQL. I know sometimes it gets that perception of like, it's been around for a while. There's a reason that it's been around for a while, because it's such a solid base to begin with. And then now there's continuing to be so many things added to it. I hope you have trouble keeping up because I know I do.
Now you tell us, we are CSharpCorner. And .NET C# has been there for like 2 decades, and we
Yeah.
do all this stuff. They're like, C#. Do people still visit? Do they still use it? I'm like, no. There's a reason it has been existing for more than 2 decades, and
Yep.
most of our applications are still written in C# and .NET and Java, right? So it's
Yep.
it's gonna be there. That's why. So
You-
thanks, Drew. Any final things you want to add before we wrap it up?
No. Everyone should be using the tools that work for them, and then make sure that you're using the tools that help make you a better developer. So if that's something that helps with code analysis, if that's some kind of AI, keep improving what you do by using what's available to you.
Yeah, thank you so much, Drew. I always enjoy hosting you. A meeting after a very long time. Let's try to bring this gavel close. All right,
Yeah.
we'll stay in
See you this
touch.
fall.
Yeah. All right. Thank you. See you. Bye bye. Have a nice
Thanks,
day
Simon.
ahead.
Bye.
All right, everyone. So that was it. That was Drew for you, coming with all tips and tricks and many ways to write your T-SQL code better. With that said, ladies and gentlemen, that was the final session of this Code Quality Conference 2024. This is the fourth continuous year we have done it. I cannot believe it. I want to thank every single person involved in this conference. We have speakers. I'm going to name each one of them. Thanks to Mahesh, Peko, Wahid, Matt, Aliru couldn't join us, but still thank you. Drew, Rijwan, Adam, Satya, Sagar, David, James, Abhishek. Thank you all to all these speakers for making this conference. This conference has come just because of you. You are the one because of which this conference has been successful. I also want to add our sponsors. We have MCN Solutions, Mindcracker. They're always helpful. Having said that, CSharpCorner, the main organizer of this conference. I'm putting CSharpCorner t-shirt. I usually put C# TV t-shirt, but it wasn't ironed today. Never mind. Thanks to all our sponsors, and I also want to thank all the viewers and attendees. We have been streaming it from last about 9 hours and 11 minutes. So thank you so much for everyone who's tuned in. At this instance, I can see Eric, Jake, then we have Sean, we had Sophia, Pravesh, Gaurav, and all the everyone who dropped comment. Ivan, right? Thank you so much, everyone, for dropping the comments. I see Bhaskar and a couple of guys who have been working behind the scenes. Actually, I don't have a big team. I don't have a big team, but this guy who has been working behind the scenes, that is Rohit Tomar. He is the one who has been doing all this social media from last 9 hours, continuously taking all those screenshots and putting it on social media, tagging you. And for all the promotional banners that you see, he's the one who has been doing it and promoting from last 3-4 months. And if you love all the videos, which I can see all the speakers are loving it, all those videos have been put by Rohit again. And all those amazing graphics that you see has been made by Aditi. She is a graphic designer on that. And a couple of speakers we had. Ivan, one of my team member who has recently joined in, he helped to bring a couple of new speakers to the Code Quality Conference. And once again, thanks to David for for coming up with the idea of a conference like Code Quality. We couldn't unfortunately have him this year, but I really looking forward to have him next year. Hopefully, we have 2 more upcoming conferences coming up. The first one is Software Architecture Conference, and the next is React and Chill Conference. Software Architecture is on August 16, and React is on August 2022. Follow csharp.tv and CSharpCorner on Twitter and LinkedIn. You will get updated about all the upcoming events, live shows, and in-persons and chapter events that we do. Having said that, ladies and gentlemen, that is it for the Code Quality Conference 2021. Thanks everyone who have been involved. My name is Simon, and I, on behalf of C Sharp TV and C Sharp One, I would like to thank you all, and I'll see you in the year 2022. Oh, I always mess it up. Why did I say 2022? Ladies and gentlemen, I'll see you in 2025.